Welcome to the Java Bootcamp 0 to Master. In this course, you're going to learn Java from the ground up through 100 hands-on projects and 50 quizzes. We're going to start with the Java fundamentals, including variables, conditionals, functions, loops, and arrays, and then followed up with object-oriented programming. So by the end, you'll have built real hands-on projects and gained practical coding skills. Now, this course is designed for complete beginners, but if you want to go even deeper, then also feel free to check out our Ultimate Java Bootcamp because that one also covers advanced topics like data structures, exception handling, higher order functions, multi-threading, unit testing, and so much more. You can find the link to the Ultimate Java Bootcamp inside of the video description. And now let's begin our Java Bootcamp. And as I just mentioned, this course is very hands-on, so we'll start by downloading the course resources. I'll see you in there. This video is for Mac. If you're using a Windows computer, please go to the next lesson. This course includes workbooks and challenges. In each workbook, you will solve a simple problem. In each challenge, you will build a bigger project. Now, I recommend not skipping the workbooks or challenges because the best way to learn a programming language is to always practice, practice, and practice. So start by downloading the course resources from GitHub. The link should take you to my GitHub page. GitHub is a place where you can download code or even post your own. I posted all of the resources for this course on GitHub. You simply have to click on this big green button, download the zip file, and it should download the resources for this course. Once you download the resources, go to it. Unzip the resources into a folder by just double-clicking it. Once you open the folder, you will see workbooks and challenges based on the section that they belong to. Here you would find the workbooks and challenges for the Getting Started section. Here you would find the workbooks and challenges for the Variables section, etc. This course includes workbooks and challenges. In each workbook, you will solve a simple problem. In each challenge, you will build a bigger project. Now, I recommend not skipping the workbooks or challenges because the best way to learn a programming language is to always practice, practice, and practice. So start by downloading the course resources from GitHub. The link should take you to my GitHub page. GitHub is a place where you can download code or even post your own. I posted all of the resources for this course on GitHub. You simply have to click on this big green button, download the zip file, and it should download the resources for this course. Once you download the resources, go to it. And now extract the contents of your zip into a folder. Once you open the folder, you will see workbooks and challenges based on the section that they belong to. Here you would find the workbooks and challenges for the Getting Started section. Here you would find the workbooks and challenges for the Variables section, etc. Installing Java is very easy. Java 17 is the most recent version of Java with long-term support. So in this lesson, you will install Java 17. We're going to install Java through Amazon Corretto's JDK. A JDK is short for Java Development Kit, and it provides all of the tools needed to develop and execute Java code. And Amazon Corretto's JDK is among the most popular, high-performant, and it's free to use. So without further ado, let us install Java. Start by going on to Google, and here look up Amazon Pokerito. Click on the first link and choose Java 17, not 18, 17. Java 17 has long-term support, Java 18 does not. So whatever Java versions show up for you, please choose Java 17. Alright, because this video is for Mac, we're going to go over to the Mac platform. And what I want you to do is go to your Apple menu, About This Mac. If you see M1 or M2, then you have a MacBook with Apple Silicon, so you will choose the download link that corresponds to this architecture. If it says Intel here, then you have the x64 chip architecture, so you would choose the download link .pkg that corresponds to this platform. Alright, I have a MacBook M1, so I will choose the following download link. Shouldn't take very long to download. Press on it. And now just go through every single step in the installation wizard. Put in your computer password. And that's all. Once you're done, close the installation wizard and open up a new terminal. If your terminal was already open, please close it and open a new one. Once you do, write java-version. And you should get a Java version of 17. Congratulations, you just installed Java. Now your computer can execute Java code. Installing Java is very easy. Java 17 is the most recent version of Java with long-term support. So in this lesson, you will install Java 17. We're going to install Java through Amazon Pokerito's JDK. A JDK is short for Java Development Kit, and it provides all of the tools needed to develop and execute Java code. And Amazon Pokerito's JDK is among the most popular, high-performant, and it's free to use. So without further ado, let us install Java. Start by going on to Google, and here look up Amazon Pokerito. Click on the first link. And we're going to be downloading Java 17, not 18, 17. Java 17 has long-term support, Java 18 does not. So whatever Java versions show up for you, please choose Java 17. Because this recording is for Windows, go to the Windows platform and choose the following download link. Shouldn't take very long to download. And now just go through every single step in the installation wizard. Press on it. And that's all. Now from your Start menu, go ahead and launch your command prompt or PowerShell, whatever you prefer. And if you, by some chance, already had your command prompt open, please close it and open a new one. And here I'm just going to write Java-version. And you should get a Java version of 17. Congratulations, you just installed Java. Now your computer can execute Java code. We can write Java code inside of a text editor. The best text editor on the planet is Visual Studio Code. Visual Studio Code, also known as VS Code, is fast, lightweight, and it has great support for Java. As a Java developer myself, I use VS Code every single day. In this lesson, we're going to download Visual Studio Code. Okay, so download VS Code for whatever operating system you're using. I'm using a Mac, so I'll choose this link. And the download should not take very long. VS Code is very light. Few seconds left. All right, once your download is finished, you can go ahead and unzip the package and open it. Now we're going to be writing a lot of Java code. So if you want support for testing, debugging, autocomplete, the first thing we're going to do is download the Java extension pack. So go to the extensions tab and write Java extension pack and download the extension pack for Java. I already have it enabled and installed, so I'll give you a couple of seconds for you to do that and then we can resume. Okay, that's really it. You downloaded VS Code and now we can start using it. This video is for Mac. If you're using a Windows computer, please go to the next lesson. So far you installed Visual Studio Code, a text editor where you can write code, and you installed Java inside your computer, so now you can run Java code. In this lesson, that's exactly what you're going to do. You will write and run your first Java code. Step 1 is to create a folder. Simple enough, inside of your desktop, make a new folder and call the folder section 1. This folder is going to contain your Java file. Step 2 is to launch the folder from Visual Studio Code. Here I have Visual Studio Code open. Go to File, Open. Find the section 1 folder that you just created. Mine is inside of desktop. And here, select the folder section 1. Once you select it, press open in order to launch it. Step 3 is to create a Java file. When creating your Java file, you must name it using the camel case format, where the first letter of every word is capitalized and the words themselves are joined together. And your file, for it to be considered a Java file, it needs to end with the extension .java. Let's do just that. I'm going to create a new file by pressing the plus icon, and the file is going to be called Hello Java. Again, using camel case, where the first letter of every word is capitalized, followed by the .java extension. And here we've created a Hello Java file. Beautiful. Step 4 is to create a Java class inside the Java file. In Java, you will write all of your code in a class. And there are 2 parts to a class: the class keyword, followed by the class name. Inside brackets is where you would write your code. And furthermore, the class name needs to always match the file name that it's in. So if the file name is called hellojava.java, the corresponding class is Hello Java. Inside your Java file, you can create your Java class. So start with the class keyword, followed by the class name itself, Hello Java. And inside brackets is where you're going to write all of your code. Perfect, we made a lot of progress. Let us delete all of our progress. We're going to delete our Java file. But wait a second, Rayan, we made all of this progress and now we're just going to delete it. Just trust me. So go here, delete your file, move to trash. Because we already created a Java file, now VS Code knows that this workspace is meant for Java development. So the second time we create a Java file, remember to use camel case, now VS Code is ready and it's going to auto-generate the class for you. By default, it adds a public keyword, which makes our Hello Java class publicly accessible to other classes that may exist inside of this workspace. But there are no other classes in this workspace, so public is not really doing anything. You can keep it, you can remove it, it doesn't really matter, it's up to you. I'm just going to keep it. Step 5. Your class needs a main method. Main is the entry point of a Java application. This is where Java starts running your code. When you run your application, Java starts by looking for the main method. So inside of your class, press enter after the first bracket to get proper indentation, and then write main. Choose the first option, and by clicking this option, VS Code automatically writes the main method for you. Now this might look like a lot of code, and it might look a bit scary, but rest assured, the main method always looks like this. All you need to know is that this is the entry point. This is where Java starts running your code. Inside of main, we're going to print a message, and you can do this using the println function. So system.out.println. Inside of double quotes, I'm going to write hello Java. Before we do anything else, let's break this line of code down. Println is a function that prints a message to the console. In parentheses is where you place the message that you want to print. And the semicolon is very important. The semicolon means end of statement. Every statement in Java, every line of code needs a semicolon at the end. If you forget your semicolon, Java's going to throw a big red error. If you hover on the error, it tells you that you forgot a semicolon, so you need to insert it. On the topic of errors, if you misspell the function, you're going to get an error. Java has no idea what function this is, it has no idea what you're talking about. And last but not least, code in any programming language is case sensitive. If you capitalize a letter that shouldn't be capitalized, you're also going to get an error. Java does not recognize the print capital T function, so please be careful. Your syntax needs to always be exact. It needs to always be perfect. And you'll remember that the class name needs to always match the file name. So if I were to misspell the class by capitalizing a random letter that I shouldn't, here Java tells us that this class name does not match the file name that it's in. So we need to fix it. So please make sure that your syntax is always exact. Step 6 is to turn on autosave. The white dot means that you have unsaved changes. So what you would do is go to File and then press Save. Now your file is saved. And if I were to change the string, for example, if I were to add a bunch of exclamation marks, the white dot reappears. And now I have to save my code again. Now this can be a bit annoying, so just turn on autosave. And now every time I make changes, the application saves by itself. The final step is to run your application. So once you're certain that your code is good, there are no syntax errors, there are no red underlines, you can execute it. The run button executes your code. Let's dismiss the debug console. And there you go, it prints our message. Let's have a closer look at what's going on when you run your code. When you execute your code, Java looks for the entry point, it looks for main, tries to find it, and once it does, it's going to run the code inside. The first line of code inside main prints hello Java, then it looks for more code inside main, but there isn't any, so it reaches the end. If you have any syntax errors, your code is not going to run. Here it's telling me that I have an error inside of line number 4 and I need to fix it. If I rerun my code now, it works beautifully, and now I can keep running my code to my heart's content. All right. With that being said, congratulations, you wrote and ran your first Java code. In this lesson, you learned that all of your code must exist in a Java class. You created a class called Hello Java. Main is the entry point. This is where Java starts running your code. So far, you installed Visual Studio Code, a text editor where you can write code, and you installed Java inside your computer, so now you can run Java code. In this lesson, that's exactly what you're going to do. You will write and run your first Java code. Step 1 is to create a folder. Simple enough, inside of your desktop, make a new folder and call the folder section 1. This folder is going to contain your Java file. Step 2 is to launch the folder from Visual Studio Code. Here I have Visual Studio Code open. Go to File, Open Folder. Find the Section 1 folder that you just created. Mine is inside of Desktop. And here, select the folder Section 1. Once you select it, press Select Folder in order to launch it. Step 3 is to create a Java file. When creating your Java file, you must name it using the camel case format, where the first letter of every word is capitalized and the words themselves are joined together. And your file, for it to be considered a Java file, it needs to end with the extension .java. Let's do just that. I'm going to create a new file by pressing the plus icon. And the file is going to be called Hello Java. Again, using camel case, where the first letter of every word is capitalized, followed by the .java extension. And here we've created a Hello Java file. Beautiful. Step 4 is to create a Java class inside the Java file. In Java, you will write all of your code in a class. And there are two parts to a class: the class keyword, followed by the class name. Inside brackets is where you would write your code. And furthermore, the class name needs to always match the file name that it's in. So if the file name is called hellojava.java, the corresponding class is Hello Java. Inside your Java file, you can create your Java class. So start with the class keyword, followed by the class name itself, Hello Java. And inside brackets is where you're going to write all of your code. Perfect, we made a lot of progress. Let us delete all of our progress. We're going to delete our Java file. But wait a second, Rayan, we made all of this progress and now we're just going to delete it? Just trust me. So go here, delete your file. Because we already created a Java file, now VS Code knows that this workspace is meant for Java development. So the second time we create a Java file, remember to use camel case, now VS Code is ready and it's going to auto-generate the class for you. By default, it adds a public keyword, which makes our Hello Java class publicly accessible to other classes that may exist inside of this workspace. But there are no other classes in this workspace, so public is not really doing anything. You can keep it, you can remove it, it doesn't really matter, it's up to you. I'm just going to keep it. Step 5, your class needs a main method. Main is the entry point of a Java application. This is where Java starts running your code. When you run your application, Java starts by looking for the main method. So inside of your class, press enter after the first bracket to get proper indentation, and then write main. choose the first option, and by clicking this option, VS Code automatically writes the main method for you. Now this might look like a lot of code and it might look a bit scary, but rest assured, the main method always looks like this. All you need to know is that this is the entry point. This is where Java starts running your code. Inside of main, we're going to print a message, and you can do this using the println function. So system.out.println. Inside of double quotes, I'm going to write hello Java. Before we do anything else, let's break this line of code down. Println is a function that prints a message to the console. In parentheses is where you place the message that you want to print. And the semicolon is very important. The semicolon means end of statement. Every statement in Java, every line of code needs a semicolon at the end. If you forget your semicolon, Java's going to throw a big red error. If you hover on the error, it tells you that you forgot a semicolon, so you need to insert it. On the topic of errors, if you misspell the function, you're going to get an error. Java has no idea what function this is. It has no idea what you're talking about. And last but not least, code in any programming language is case sensitive. If you capitalize a letter that shouldn't be capitalized, you're also going to get an error. Java does not recognize the print capital T function, so please be careful. Your syntax needs to always be exact. It needs to always be perfect. And you'll remember that the class name needs to always match the file name. So if I were to misspell the class by capitalizing a random letter that I shouldn't, here Java tells us that this class name does not match the file name that it's in. So we need to fix it. So please make sure that your syntax is always exact. Step 6 is to turn on autosave. The white dot means that you have unsaved changes. So what you would do is go to File and then press Save. Now your file is saved. And if I were to change the string, for example, if I were to add a bunch of exclamation marks, the white dot reappears. And now I have to save my code again. Now this can be a bit annoying, so just turn on autosave. And now every time I make changes, the application saves by itself. The final step is to run your application. So once you're certain that your code is good, there are no syntax errors, there are no red underlines, you can execute it. The run button executes your code. And there you go, it prints our message. When you execute your code, Java looks for the entry point, it looks for main, tries to find it, and once it does, it's going to run the code inside. The first line of code inside main prints hello Java, then it looks for more code inside main, but there isn't any, so it reaches the end. If you have any syntax errors, your code is not going to run. Here it's telling me that I have an error inside of line number 4 and I need to fix it. If I rerun my code now, it works beautifully, and now I can keep running my code to my heart's content. All right. With that being said, congratulations, you wrote and ran your first Java code. In this lesson, you learned that all of your code must exist in a Java class. You created a class called Hello Java. Main is the entry point. This is where Java starts running your code. This video is for Mac. If you're using a Windows computer, please go to the next lesson. Every developer should know how to use their terminal. So far you learned how to run your code using the run button. Now the run button is nice, but it's really important that you learn how to use your terminal. So in this lesson, you will run your code using terminal commands. Javac means Java compiler. So in step 1, the terminal command javac is going to compile your Java code into bytecode. Specifically, we want to compile the code inside of hello-java.java. So tell your terminal we want the Java compiler, javac, to compile the code inside of hello-java.java. By doing so, the Java compiler will compile all of the Java code into a format called bytecode. The compiled bytecode is going to live inside of a .class file. From VS Code, you can open up a new terminal by going over to Terminal, New Terminal. If the debug console shows up for you, feel free to dismiss it. And your terminal should automatically point to section 1. The hello-java.java file lives inside of section 1, so over here we can compile the code inside of it. Java compiler, javac. And now press Tab. By pressing Tab, it guesses the file that I'm trying to compile by looking inside of the folder section 1. There's only one file inside of section 1, so it auto-completes hello-java.java. And now you can compile your Java code. But anyways, by applying the javac command on our Java file, the Java compiler compiled all of its Java code into bytecode, and the bytecode lives inside of a .class file. In step number 2, the terminal command java executes the compiled code. So to summarize, the javac command compiles your code, and the Java command executes the compiled code. By design, the javac command includes the .java extension. The Java command does not. So please be very careful when writing your commands. Alright, back to our project. We will write Java and then press Tab. It's going to autocomplete based on what it finds inside of section 1. Do not add a .java extension at the end. Just like that, it's able to run the compiled code. What these two commands are doing is pretty much what the run button was doing for us behind the scenes. But I want you to be comfortable running terminal commands, so I'm going to keep using terminal commands throughout this course. Now, let's say I want to re-execute the compiled code. Instead of rewriting this command, what I can do is press the up key. The up key remembers previous terminal commands, and we can use it to re-execute the compiled code as many times as we want. Awesome. Remember that when you execute your code, Java looks for the entry point, main, it tries to find it, and once it finds main, it runs the code inside. The first line of code inside main prints hello Java, then it looks for more code inside main, but there isn't any, so it reaches the end. Alright, with that being said, I need to warn you to always compile your code first. When you make changes to your code, compile it first using javac, and then run the compiled code using the Java command. Let's look at an example where I don't do that. So I'm going to change the message to greetings Java. And now I would expect that by running this code, it should print this message. So just run the code without compiling, Java hello Java. And it still prints hello Java, and that's because you're running the old compiled code. When you make changes to your code, you need to recompile it using javac. Javac hello java.java. And then execute the newly compiled code with the Java command. Java hello Java. And once you do that, it executes the new code. With that being said, congratulations, you executed your code using Java commands. So far you learned that all of your code must exist in a Java class. You created a class called hello Java. Main is the entry point. This is where Java starts running your code. And finally, you can use the javac command to compile your code and the java command to execute the compiled code. Every developer should know how to use their terminal. So far, you learned how to run your code using the Run button. Now, the Run button is nice, but it's really important that you learn how to use your terminal. So in this lesson, you will run your code using terminal commands. Javac means Java compiler. So in step 1, the terminal command javac is going to compile your Java code into bytecode. Specifically, we want to compile the code inside of hello-java.java. So tell your terminal we want the Java compiler, javac, to compile the code inside of hello-java.java. By doing so, the Java compiler will compile all of the Java code into a format called bytecode. The compiled bytecode is going to live inside of a .class file. From VS Code, you can open up a new terminal by going over to Terminal, New Terminal. And your terminal should automatically point to section 1. The hello-java.java file lives inside of section 1, so over here we can compile the code inside of it. Java compiler, javac, and now press Tab. By pressing Tab, it guesses the file that I'm trying to compile by looking inside of the folder section 1. There's only one file inside of section 1, so it auto-completes hello-java.java. Because you're using PowerShell, it adds a /. Please remove the /. And now you can compile your Java code. But anyways, by applying the javac command on our Java file, the Java compiler compiled all of its Java code into bytecode, and the bytecode lives inside of a .class file. In step number 2, the terminal command java executes the compiled code. So to summarize, the javac command compiles your code, and the Java command executes the compiled code. By design, the javac command includes the .java extension. The Java command does not. So please be very careful when writing your commands. Alright, back to our project. We will write Java, and then press Tab. It's going to autocomplete based on what it finds inside of section 1. And here it adds a .class at the end. Now, I know that the Java command is ultimately executing the bytecode inside of the .class file, but by design, the Java command does not have any extensions at the end, so please remove it. Do not add a .class, do not add a .java, Java file name, that's it. It also adds a /. Please remove that as well. Just like that, it's able to run the compiled code. What these two commands are doing is pretty much what the Run button was doing for us behind the scenes, but I want you to be comfortable running terminal commands, so I'm going to keep using terminal commands throughout this course. Now, let's say I want to re-execute the compiled code. Instead of rewriting this command, what I can do is press the up key. The up key remembers previous terminal commands, and we can use it to re-execute the compiled code as many times as we want. Awesome. Remember that when you execute your code, Java looks for the entry point, main, it tries to find it, and once it finds main, it runs the code inside. The first line of code inside main prints hello Java, then it looks for more code inside main, but there isn't any, so it reaches the end. Alright, with that being said, I need to warn you to always compile your code first. When you make changes to your code, compile it first using javac, and then run the compiled code using the java command. Let's look at an example where I don't do that. So I'm going to change the message to greetings Java. And now I would expect that by running this code, it should print this message. So just run the code without compiling, Java hello Java. And it still prints hello Java, and that's because you're running the old compiled code. When you make changes to your code, you need to recompile it using javac. Javac hello java.java, and then execute the newly compiled code with the java command, java hello java. And once you do that, it executes the new code. With that being said, congratulations, you executed your code using Java commands. So far you learned that all of your code must exist in a Java class. You created a class called Hello Java. Main is the entry point. This is where Java starts running your code. And finally, you can use the javac command to compile your code and the java command to execute the compiled code. This course contains a lot of quizzes, and it's time for your first one. I left you a link to the Java practice quizzes inside of the video description. Make sure that you go to it, and then go to quiz 1 and try to solve it. All right? Make sure that you do not proceed with this video until you solve quiz 1.1. So pause the video now, go there and do it. Inlay hints are markers that provide more information about your code. An example of an inlay hint is this little x, but how does this x provide more information about the printline function? In this case, it really doesn't provide any useful information. An easy way to think about it is, hey, x marks the spot where you should write the message that you want to print, but it's not really that useful. Inlay hints will become useful once you reach the section on functions. Personally, I'm going to disable my inlay hints because for me, I don't find them useful, but I highly recommend you keep them because they will become very, very useful once you reach the functions section. So if I have convinced you to keep your inlay hints, then please skip this video and go to the next one. But if you want to disable your inlay hints like me, which I don't recommend, then keep watching. So because I'm using a Mac, I'm going to go to Code, Preferences, and then Settings. Windows, same thing, but you would go to File and then Preferences and Settings. So I'm going to do just that on my Mac. And here I will look for inlay hints. Shows up first, and I will disable them. And just like that, my inlay hints are gone. It's worth investing a little bit of time customizing your editor. First, I will show you how to adjust the color theme. So go to your VS Code editor, and if you don't have it open, just pause the video and do that. And then on Mac, go to Code, Preferences, and Color Theme. On Windows, it's the exact same thing, but you would go to the File menu instead. And then you can cycle through the color themes and choose the one that you like. And this would make sense if you could see the code, so I'm going to create some space, and that way you can see the changes in each theme. And as I cycle through the default themes, to be honest, none of them really appeal to me. The one that I like to use is called Brackets Dark, but it's not available when you first install VS Code, which means we have to go to the marketplace, and there we can install it as an extension. So here I'm looking for Brackets Dark Pro, but that doesn't exist anymore. Look up Brackets Dark instead. It's the same thing. And in my opinion, Brackets Dark is the best color theme we can use, so we're going to click on it and install. Once you install it, you can set the color theme. And if you were to go back to your preferences, notice that now we can see it there. All right, let's see how it affects our code. And I think this looks pretty nice. The only other thing you can really play with is the font size. So once again, you would go to Code, Preferences, and for Windows, once again, go to the File menu instead, then click on Preferences, but in any case, Preferences and Settings. And here you can adjust the font size. A good font size is typically between 14 and 20. It depends on your eyesight and the size of your screen, so I suggest just, play around with it and keep doing so until you find a size that works for you. I use a font size of 20. Alright, that's all. I hope you took the time to change your color theme as well as the font size.
As I mentioned before, this course contains a lot of workbooks and challenges, and you're ready for your first workbook. I left you a link to the Workbooks and Challenges GitHub repository inside of the video description. Please make sure that you go to it. And then once you do, go to Getting Started, and you're ready for Workbook 1.1. All right, best of luck. All right, this wraps up the Getting Started section. Now you're ready for the final challenge. So make sure that you're at the Java Workbooks and Challenges repository. Click on the Your Initials challenge, and I wish you the best of luck. Do not continue with this course until you've completed this challenge, and I will see you after you're done.
Variables are used for storing data. Int variables can store whole numbers, long variables can store big whole numbers, double variables can store decimals, string variables can equal text, and char variables can store single characters. In this lesson, you will use variables to store numeric data. So here is the process for this lesson. Step 1, first we have to identify a data type that can store bus passengers. The three numeric data types we will be dealing with are int, long, and double. Double is used to store decimals, and it doesn't make sense to have 0.5 of a passenger, so it's going to be between int and long, two data types that can be used to store whole numbers. Beautiful. So we have two contenders. Now integers occupy 4 bytes in memory, so it has the capacity to store whole numbers in the range -2 billion to 2 billion. Long consumes more size in memory, but it has the capacity to store whole numbers with a magnitude of 9 quintillion. Which data type should we use to store bus passengers? Here's the golden rule. Use the smallest amount of memory possible. Int takes up less memory than long, and it can store numbers up to 2 billion. That is more than enough to store passengers on a bus. And so now that we've identified the data type, step 2 is to name the variable using lower camel case format. The naming convention demands that the first word starts with a lowercase letter, but the words that follow start with an uppercase letter. The name variable starts with a lowercase letter. The phone number variable contains 2 words. The first word starts with a lowercase letter, and the word that follows starts with an uppercase letter. The date of birth variable contains 3 words. The first word starts with a lowercase letter, and the words that follow all start with an uppercase letter. Using lower camel case format, I will declare a passengers variable that can store integers. And step 3 is going to be to set the variable equal to a value. The passengers variable is of type int, which means it can only store integers in the 2 billion range, but that's more than enough to store passengers on a bus. Because how many passengers could we possibly have? 5? 8? 6? 2? Perhaps 1? I think we should be fine. Start by creating a new folder called Section 2. And we need to launch this folder from VS Code. Now what you could do is go to File and then open your folder from here. Or you could just drag your folder onto VS Code and it's gonna get launched. And inside this folder, we'll create a new Java file called variables.java. It will contain a public class that shares the exact same name as the file that it's in. The class is going to contain all of our code. And remember that the main method is where execution of your code will start. So here I'll create a passengers variable of type int. Because it's of type int, it can only store integers, and we're going to store the integer 5. There are 5 passengers on the bus. And now what I want to do is print the value inside of this variable. So I'll say system.out.println, and I will print the value inside of passengers. All right, let's run our code, open up a new terminal. Dismiss the following. First, we can compile the code by saying javac variables.java, and then we can run the compiled code. It simply prints the value inside of passengers. And now, instead of running all of the code at once, what if we can visualize it step by step? There's actually a way to do that using breakpoints. So I'm going to apply a breakpoint at every single line where I want the runtime to stop. And now don't press run, press debug. So when you run your app in debug mode, you'll notice that it starts running on a new terminal. So this was the one that we opened before and where we ran our javac commands. And now by running your app in debug mode, it's going to output everything here. And so you'll notice the runtime stopped at line number 3 where we told it to stop. If I press continue, what it's going to do is continue to the next breakpoint and run the code inside of line 3. And beautiful, by running the code inside of line 3, it created a variable called passengers that stores an integer of 5. And here I'm just printing the value inside of the passengers variable. So by pressing continue again, because there are no other breakpoints, it's just going to resume execution. Beautiful, it prints 5. And now because we're done debugging, let us close this debug terminal and go back to our old terminal. This one is a lot less cluttered, okay? You can also set variables equal to each other. Each passenger needs 1 bus ticket. There are 6 passengers, so we expect the bus ticket variable to equal 6 as well. So here what I'll do is I'll create another variable called bus tickets that can only store integer values, and because each passenger needs 1 bus ticket, we expect the number of bus tickets to equal the number of passengers. So the integer's value inside of passengers is going to get copied over to bus tickets, and we can prove this by printing the value inside of the bus tickets variable. Okay, first we're going to run the app normally, then we're going to visualize the runtime line by line. And then execute the newly compiled code. So first we printed the value inside of passengers, which was 5, and then by setting the bus tickets variable equal to the value inside of passengers, it contains a value of 5 as well. Let's visualize the runtime step by step. So I want the runtime to stop at line 3, line 4, line 6, and line 7. Then by pressing debug, now everything's going to be happening in the debug console, not in our old terminal. So let's go to it. By pressing continue, it's going to go from line 3 to line 4. And by executing this line of code, it creates a passengers variable that stores an integer of 5. And here we print the value inside of this variable. So we'll continue to the next breakpoint. It runs line number 4, printing a value of 5. And now by running line number 6, it's going to create a bus tickets variable. And because we're setting it equal to the integer value stored inside of passengers, that value is just going to get copied over into the bus tickets variable. Press continue again. So now bus tickets stores a number of 5. By printing the value inside of bus tickets, we're going to get an output of 5. Beautiful. And now that we're done debugging, let me close the debug console. And while you could remove all the breakpoints individually, an easy way is to just press this X to remove all breakpoints. Okay. Now integer occupies 4 bytes in memory. It has enough space to store any value in the 2 billion range. The highest value that it can store, to be specific, is 2,147,483,647. What happens if we try to exceed this limit? Let's create an int variable called maximum value. Remember, using lower camel case. And then we're going to set it equal to 2,147,483,647. This works fine, no errors. If I try to go one above the maximum possible value that a 4-byte integer is able to store, Java's gonna yell at us. And it's gonna tell you that the number you're trying to store is out of range. An integer which occupies 4 bytes in memory does not have enough space to store this value. To recap, you used the int data type to store passengers on a bus. The golden rule is to always use the smallest amount of memory possible. Int and long are the two data types that we can use to store whole numbers. Integers take up 4 bytes, whereas long takes up 8. Our passengers variable is of type int, which means it can only store integers in the 2 billion range, but that is more than enough to store passengers on a bus. You can update the value inside of a variable. In the first line, I initialized an integer variable, which occupies 4 bytes in memory, and after initializing a variable, you can keep updating its value as long as you respect the range that it's able to store. The 4-byte integer has just enough space to go up to 2,147,483,647. If I try to go above the maximum possible value that a 4-byte integer can store, Java's gonna yell at me because the number I'm trying to store is out of range. In this lesson, we will update the passengers variable. Before we do anything else, our terminal is pretty cluttered from when we ran this code, so what I'm going to do is clear the terminal output. And this is much better. And you might have been wondering why max value is grayed out. This is just because we created the variable but never used it. So for example, if you were to try to print it, then that warning should go away. I've gotten a lot of questions about it. Just want to let you know that this warning is meaningless. Don't worry about it. Okay, first we'll start by creating a new file called bus.java, and execution of your code will start inside of the main method. So here we're going to assume that we're bus drivers, and our bus starts off with 0 passengers. And let's assume that we make our stop at the Parliament Hill and we end up picking up 9 passengers. So what I can do is update the passengers variable by setting it equal to itself. So at first it's 0 plus the 9 passengers we picked up. And now after updating our passengers variable, I want to print the value inside. System.out.println passengers. First, I'm going to run the code the normal way, java c bus.java, java bus, just to make sure that we get the proper output, and beautiful. Now our bus has 9 passengers inside. That is perfect. Before we visualize the runtime line by line, let's give it some more logic. Let's assume that 5 passengers want to leave the bus. They want to be dropped off at the Rita River. So here, once again, we have to update the passengers variable by setting it equal to itself minus 5, because we're removing 5 passengers from our bus. Now let's print the updated number of passengers. System.out.println will print the updated value inside of the passengers variable. Run the code again. And here we update the passengers variable to equal 0 plus 9, which ends up printing 9. Perfect. At this point, we've got 9 passengers. 9 is equal to 9 minus 5, results in 4 passengers left. And now it just so happens that 4 more passengers want to be dropped off at the skating rink, so we can say passengers is equal to passengers minus 4. And here I can print the updated number of passengers. Let's visualize the runtime. Press debug. So if I continue to the next breakpoint, it's going to run line 3 of my code, and it creates a passengers variable that equals 0. Let me dismiss all of these. Okay. And now here we're updating the passengers variable by setting it equal to itself, which initially is 0, as you can see here, plus 9. Now my passengers variable equals 9, and here I'm just printing the value inside of my updated passengers variable. Beautiful, it prints 9. Now, once again, I'm setting the passengers variable equal to itself, 9 minus 5, which is going to end up equaling 4. Now, once again, I print the updated value inside of the passengers variable. And now here, once again, I'm updating the passengers variable by setting it equal to itself, which right now is 4 minus 4, resulting in an updated passengers value of 0, which we then end up printing. Perfect. Now, updating a variable by setting it equal to itself plus some other value is really ugly. Please don't ever do that. There is a special operator called the plus equals operator that updates a variable by adding to it the value on the right. So here what I will do is I will update my passengers variable by adding to it the value on the right. Let's visualize the runtime. So here I'm creating a passengers variable that equals 0, passengers equals 0, and I can update my passengers variable by adding to it the value on the right, 9. Beautiful, which I then end up printing. I don't want to execute the remaining lines, so what I'll do is I will press stop. Now, once again, updating a variable by setting it equal to itself minus some other value is also really ugly. Don't ever do that. There is once again a special operator for this called the minus equals operator that updates a variable by subtracting the value on the right. So here I can say passengers minus equals 5 and passengers minus equals 4. All right, let's visualize the runtime for each case. So my bus starts off with 0 passengers. Here we created an integer variable that equals 0. And here I update the passengers variable by adding to it the value on the right, 9. Now I've got 9 passengers. And by the time I reach line 8 of my code, my passengers variable stores a value of 9. And I can update this variable by subtracting from it the value on the right because we're dropping off 5 passengers, which means I'm only going to have 4 passengers left, which ends up printing. And in line number 11 of my code, at this point, my bus only has 4 passengers left, and I'm updating the variable by subtracting from it the value on the right. 4 minus 4 is going to update our passengers variable to equal 0, which I then end up printing. And that is all. So to recap, you updated the number of passengers on a bus. The plus equals operator updates a variable by adding to it the value on the right. And the minus equal operator updates a variable by subtracting from it the value on the right. The string type can be used to store text. String, unlike int, varies in memory. No matter what you store in the integer variable, it's always 4 bytes. But with strings, empty text alone takes up 24 bytes. And the more text that you add to a string, the more memory it takes up. In this lesson, you will use a string to store text data. I'm going to start by creating a new file called joining_strings.java. And inside of my class, I will create the main method. Okay. So here's the process for this lesson. Step number 1 is to identify the data type that can store text. Int long doubled, those only store numbers. Char is for single characters, as you will see in the next lesson, and the only data type that we can use to store text is string. So now that we've identified our data type, step 2 is to always name your variable using lower camel case format. I will be creating a variable called announcement. Announcement is just one word, so the first letter will just start with a lowercase. And step 3 is to set the variable equal to a string value. You can create a string value by placing text wrapped inside of double quotes. And whoa, why does it take up so much space? In just a second, you will actually see why string takes up so much space. But for now, all I want you to know is that we can use the string type to store text. So over here, I will create an integer variable called year, and this variable is going to store the integer 2010. Then I will declare a string variable called winner, and the winner of the 2010 World Cup is Spain. Alright, let's go ahead and visualize the runtime. I'll put 2 breakpoints here, press the debug button. So here, if I continue to the next breakpoint and executes line 3 of my code, the year variable stores an integer value of 2010. And now if I press continue again, because there are no other breakpoints, the runtime will just resume and finish. We won't be able to visualize our string variable. That is a shame. So let's press debug again. Let's once again go to line number 4. And I don't want the runtime to continue. All I want to do is step over this line. So what I can do is press the step over button. And it just steps over line number 4. And here you can see that winner equals a text value of Spain, but the string type is much more complex than the other types because behind the scenes, what our variable actually refers to is this big ugly object that in this case takes up 48 bytes in memory. Anyways, we don't care about objects right now. That was just a small aside. All I want you to know is that we can use the string type to store text, nothing more. And here you can see that our winner variable stores a text value of Spain. And here I will create another string variable called announcement, and it's going to store the following text. The winners of the some year World Cup are some team. And this makes me wonder, how do I blend the winner as a string value over here? You can use the plus operator to join 2 string values. Fairly simple. So here what I can do is remove the placeholder and then just to this string concatenate the string value that our winner variable equals. And now how do I join a number into a string? Same thing, you can use the plus symbol and what it's going to do is blend that number into a string. So what I'll do is I will actually break the string here, break it here as well. And now instead of this placeholder, I'm going to blend in the integer value that is stored inside of the year variable. Okay, we're looking good. Let's just print the announcement system.out.println. And then instead of running the application the normal way, what I will do is add 4 breakpoints and visualize the runtime. Here, by running this line of code, we can see that the winner variables is text value and the year variables is integer value. They were blended into our string announcement, which we can then print. All right. So you can use the string type to store text. Using the plus operator, you can connect a string with another string. And once again, using the plus operator, you can also blend numbers into a string. In this lesson, you will use the char type to store single characters. Inside of our folder, I will start by creating a new file called grades.java. And inside of my class, I will create the main method, and that will be all. Before we start, Java only allocates 2 bytes in memory for the char type because it's meant to only store 1 character at a time. And when setting a variable equal to a character, you need to wrap that character around single quotes. And no matter what character you store inside the variable, char always takes up 2 bytes in memory. And now inside of VS Code, I'm going to create 3 char variables. The first variable is going to be a student's grade in potions. We'll give them an A in that. We'll give them a B in arithmancy. And we will give them a C in charms. Then I'm going to print each grade as part of one long string. So here I will say system dot out dot println, and just how we connected a string to a number or a string to another string using the plus operator, we can do the same thing over here. So here what I'm going to do is I will print that their grade in potions is some grade. So what this is going to do is embed the character that is stored inside of potions to this string. So it should say potions A. We will repeat the same thing throughout, except now we will present their grade in arithmancy, which is whatever value is stored inside of the arithmancy variable, and their grade in charms will be whatever value is inside of the charms variable. Okay, let's just go ahead and visualize the runtime. Forgot to put breakpoints, my bad, otherwise the runtime will not stop. So we want it to stop at line 3, and then we'll continue from there. So here, by pressing continue, it goes to line 4, executing line 3. Our variable potions of type char simply stores a single character, in total taking up 2 bytes in memory. And here we define 2 more variables of type char, each one storing a single character. And here all we're doing is printing each character as part of one long string. Beautiful. Now before we move on, you might be asking yourself, why not just always use string? Like so. And then since we're using string, instead of single quotes, you would put double quotes. If I were to run this, I can use the same terminal, doesn't matter, javac grades.java, java grades. I would get the exact same result, so why not always use string? Especially considering the fact that string can store not just one character, it can store billions of characters, so why limit ourselves to the char type? Remember the golden rule to use the smallest amount of memory possible. Using a char versus a string is the difference between taking up 2 bytes in memory versus about 48 bytes. So if you only have to store one character, I highly recommend using the char type. So we're going to switch this back. In this lesson, you use the char type to store single characters. The size of a character that is stored in memory is limited to 2 bytes, so no matter what character you store inside the variable, char always takes up 2 bytes in memory. If you only need to store a single character, always favor char over string, in accordance with the golden rule of using the smallest amount of memory possible. The long type can be used to store large whole numbers. Integers are limited to 4 bytes in memory, whereas long is given 8 bytes in memory, and it has the capacity to store numbers in the magnitude of 9 quintillion, an unimaginably large number. In this lesson, you will use the long type to store large whole numbers. First thing we'll do is create a new Java file called wholenumbers.java, and inside of our class, we're going to create the main method, which is where execution starts. All right. So when do we use long? The int type is limited to storing numbers in the 2 billion range. And if you expect your number to exceed this range, then you should use the long type to store your number. Here is a real-world scenario. YouTube never expected one of their videos' view counts to exceed 2,147,483,647 views, which, as you'll remember, is the maximum possible value that a 4-byte integer can store. By the way, 8 bits is equal to 1 byte, so 4 byte and 32-bit are the exact same thing. Anyways, when Psy came out with Gangnam Style, YouTube realized that a 4-byte integer data type is not enough to store the view count of a video. So they ended up using a data type with 64 bits of memory, and that data type, because it has so much size and memory allocated to it, it can store values up to 9 quintillion. 8 bytes in memory, 9 quintillion, does that look familiar to you? When numbers start reaching astronomical levels, the long data type will come to the rescue, so let's see this in action. First, what I'll do is I will create a variable of type int called global population, and I'm going to try setting it equal to 8 billion. So 8 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. This is obviously not possible because it exceeds the maximum possible value that an integer variable can store. What we need to do is define this variable as a long, because long can store up to 9 quintillion. And here we still get an error because Java doesn't know that you intend on putting this in a long. All it sees is a very big integer that has no business being this big. So what we'll do is we'll add an L at the end. By adding the L, we're basically telling Java, hey, relax, we're going to be storing this in a variable that is more than capable of handling it. And there are over 8.5 billion Google searches a day. That's not something we can store in an int variable. We need a long that takes up 8 bytes in memory. So let's just copy this and put a 5 over here. If you don't include the L, Java's not going to know that you intend on storing this big integer inside of a long, so you need to add the L to tell Java, hey, relax, we're going to be storing this big number in a variable that is more than capable of handling it. And now let's just print a nice message to go along with these variables. So you can actually autocomplete system.out.println by just autocompleting sysout. Here we will say the global population is... We will concatenate whatever value is stored inside of global population variable. And over here we will say sysout daily, there are this many Google searches. Okay, let's visualize the runtime. By pressing continue, it runs line 3 of my code, which creates a long variable that stores the value 8 billion. By pressing continue again, it's going to print the global population is 8 billion. This variable is going to store the number of daily Google searches, which is 8.5 billion. And now here we are printing that number within a string. Beautiful. And now before I forget, there are 9 zeros here, which makes things really hard to read. What I can do is every 3 zeros put an underscore. So the underscore doesn't change anything. All it does is it makes our number easier to read. That's all. This is still 8 billion. And here we can do the same thing. This does not change the logic, just makes our code prettier. So now let's visualize the runtime again. Here I'm still creating a variable that has the capacity to store 8 billion. And here I'm still creating a variable that has the capacity to store 8.5 billion. All right, and our message is print. This is beautiful. In this lesson, you use the long type to store large whole numbers. The 4-byte integer, or if you want to call it the 32-bit integer, can only store numbers in the 2 billion range. But if you're storing a number that may exceed the maximum possible value that a 4-byte integer can store, then you can use an 8-byte long. Please adhere to the golden rule of using the smallest amount of memory possible. The double type can be used to store decimals. So far, we've looked at all the core data types. The last one that we need to talk about is double, which can be used to store decimals. Rightfully so, in this lesson, you will use the double type to store decimals. First, what you'll do is you'll create a new file called decimals.java, and inside the class, create the main method. All right. Java allocates 8 bytes to the double type, and if you want to get granular, 8 bits equals 1 byte. So you can also say that Java allocates 64 bits to the double type, but to avoid confusion, let's just stick with the unit bytes. Anyways, because double are given so much size in memory, then a double value can go up to 15 decimal places, which is a lot. So here what I'll do is I'll create a variable of type double called percentage, and inside of our double variable, we can store a decimal of 73.5%. (73.5%) of percentages are made up. All right, visualizing the runtime. Here, by running line 3 of my code, we're creating a double variable that stores a decimal, and here we are printing it. Cool. Now I want to warn you never to use int for math calculations. If you multiply or divide two integers, the result will always be an integer, and Java is going to cut off all the decimals. So while 11 divided by 2 is actually 5.5, Java cuts off the decimal, in turn giving us an incorrect result. So let's just say that I have $20. So I'm going to say int wallet is equal to 20. And let's say that our program needs to split this money up between 3 people. So I'll say int people is equal to 3. So each person should get $6.66. But what is it actually going to print? Let's say wallet divided by people. All right. And let's remove these breakpoints. We want these to just automatically run and for our runtime to stop at line number 6. So here we're creating a wallet variable that equals an integer. Here we're creating a people variable that equals an integer of 3. And when you divide two integers, when you perform math operations on two integers, the result is going to be an integer. So although this should be 6.66, Java cuts off all the decimals and returns an integer of 6. This is not good. So we need to make sure that at least one of these values is stored as a double. And then Java is going to know to return a double result. Let's visualize the runtime. And here, notice that 20 gets stored as a decimal because you can tell it's 20.000. Here, 3 is going to get stored as an integer inside of our integer variable. And because at least one of these values is a double, Java is going to know to return a double result. And I know that the result is double because it clearly goes up until 15 decimal places. You can count the number of decimal places if you want. So I'm going to put a comment here. Always use double for math calculations. This will be stored as a double. 20.000. Just a note for you. All right. We used double to store decimals. Java allocates 8 bytes to this data type, so values of type double can go till 15 decimal places. When performing math operations, never use integers, because the result of performing math on integers will always result in an integer. If you have at least one double in your math calculation, then Java is going to know to return a double result and preserve your decimals. There are 9 different math operators that we can use to operate on values, and in this video we're going to look at an example of each one. So the first math operator we will look at is the plus operator, which is fairly intuitive. All that's going to do is add two values. So what we'll do over here is we will break the string and add bag of sweets 1 plus bag of sweets 2. And ideally what Java will do is add these two values together and then blend the result into the string. Is that going to happen? We will find out. And then here, once again, we break the string and we'll say there are stars in Milky Way plus stars in Andromeda. Whatever the result ends up being from adding these two numbers will hopefully be appended into this string. Is that what we can expect? Let's find out. I'm only going to put two breakpoints here and let these run naturally. Let's press debug. And here we expect it to print Fred and George collected 15 sweets, but instead it prints Fred and George collected 510 sweets. That's not right. Clearly those numbers did not add up together before being blended into the string. What really happened is that, well, in Java, things happened from left to right. First, the number was appended into the string, and then the second number was appended into the updated string. So what we need to do is set up some order, and we can do that by placing this operation inside of brackets. So now we're telling Java, hey, add these numbers first and then append the result of this operation into the following string. And you should always add brackets when you are performing math operations from within a string, just to make sure that things happen in the order that they should happen. Let's try this again. Fred and George collected 15 sweets. Beautiful. The math operation happened first, and then it was appended into the string. And now, if I press continue, it's going to run this line and every single other line. I don't want to do that. Let's just step over line number 13, and that's it. A trillion plus 250 billion is 1.25 trillion. Fair enough. And I'm going to stop the runtime right here. I don't want the remaining print line functions to run. Next operator, fairly simple, is used to subtract two values. So here what we can do is once again break the string, and to the string we're going to append the result from subtracting bag of sweets 2 by bag of sweets 1. Here once again we can break the string. The Andromeda galaxy has stars in Andromeda minus stars in Milky Way. Whatever that returns, more stars than the Milky Way. Okay, visualizing the runtime. So Fred should have 5 more sweets than George. Perfect. And the Andromeda galaxy should have 750 billion more stars than the Milky Way. I don't want to run the remaining lines. I only want to step over line 16, so we'll press step over. Beautiful. And now the multiplication operator is used to multiply two numbers. So here Snape made an error on his Excel, accidentally multiplying Ron's score to some result divided by 10. So we'll break the string right here, and in the middle we'll perform a math operation of multiplying Ron's test score by 1.25. Okay. And the division operator represented by the front slash, as you guessed it, is used to divide two numbers. So here Snape caught his error, and furious he divided Ron's score to whatever Ron's test score is. We'll just say he divided it by 2.0. Visualizing the runtime over here. And because we are multiplying two doubles, we expect Java to return a double value. Perfect. Here, once again, we're dividing a double by a double, so it's going to return a double. Fair enough. Alright, onwards to the next operator. The modulus operator is expressed by the percent sign, and what the modulus does is it returns the remainder of a division. When you divide two numbers like 10 divided by 2, what remains is the modulus. In this case, the modulus from dividing 10 by 2 is 0. And in Java, the modulus operation involves the dividend and the divisor. This operation will divide 10 by 2, but it won't return the result of the division. It's going to return the remainder. But why do we care about the remainder? It's very useful if you want to identify odd or even numbers, because when you divide an even number by 2, like 10, the remainder is 0. When you divide an odd number by 2, the remainder is not 0, which makes 5 an odd number. So here it says 10 is an even number since dividing 10 by 2 has a remainder of whatever the result ends up being from performing 10 modulus 2. 5 is an odd number since dividing 5 by 2 has a remainder of whatever the result ends up being from performing 5 modulus 2. Visualizing the runtime. So 10 divided by 2 modulus would return the remainder of that division, which is 0, which makes 10 an even number. And the remainder from dividing 5 by 2 is 1, which makes 5 an odd number. Perfect. The next operator we'll look at is the add 1 operator, and all that does is it increases a variable's value by 1. So here counter is 0. If I say counter plus plus, and I do that 3 times, every time I do it, it's just going to add 1 to our counter. Here it's going to equal 3. And conversely, the subtract 1 operator is going to subtract 1 from a variable's value. So here we'll say counter minus minus. We'll do that 2 more times, bringing our counter back down to 0. Let's see that in action. So here our counter variable is going to start at 0. Counter plus plus increases it to 1. This happens 2 more times. Now our counter is 3, which is what prints. But now I am minusing 1 from the counter each time, so it goes back down to 0, which prints again. Now the add by operator we've already looked at. What that does is it updates a variable by adding to it the value on the right. So you'll remember in bus.java, I already have my breakpoint set up. We created a passengers variable that stores a value of 0. Line number 5, we are updating the passengers variable by adding to it the value on the right, thus picking up 9 passengers, printing it. And you'll remember the subtract by operator is used to update a variable by subtracting from it the value on the right. So here, we update the passengers variable by subtracting from it the number 5, dropping off 5 passengers. Now we have 4 left. And once again, we update the passengers variable by subtracting from it the value on the right. So now we've dropped off all of our passengers and our bus is empty. So to recap, we just used every single math operator in Java. The first 4 operators were pretty obvious: addition, subtraction, multiplication, division. The modulus operation returns the remainder of a division. The add 1 operator increases the value by 1. The subtract 1 operator decreases a variable's value by 1. The add by operator, which you've seen in another video, increases a variable's value by adding to it the number on the right. And the subtract by operator decreases a variable's value by subtracting from it the number on the right. And that is all. I really hope you enjoyed this lesson. In this lesson, you will cast values from one type to another. Let's begin. Put breakpoints everywhere and press debug. Let's run line number 5 and line number 6. The number of ants is stored as a whole number, and you purchased 1 block of cheese, also stored inside of an int variable. And this will print there are 2,000 ants and 1 block of cheese. Okay. And unfortunately, we have an ant infestation at our house. An ant colony stormed in, and the fraction of cheese that each ant walks out with is determined by the following operation. Now, 1 divided by 2,000 should return 0.0005. However, when you perform a math operation between two integers, between two whole numbers, the result will always be an integer. So Java is actually going to cut off all the decimals and just return a value of 0. This is not very helpful. At least one of the values involved in this operation should be a double. So for the time being, what I'm going to do is store the block of cheese value inside of a double variable. Let's revisualize the runtime. So the number of ants is still going to be stored as an integer, as you can see here. And now the amount of cheese, although we wrote it as a whole number, it's going to get stored as a double, as you can see from the decimal followed by all these zeros. And now because one double is involved in this operation, then Java is going to know to return a double where each ant is going to carry 0.0005 of a fraction from the total cheese amount from our cheese block. Now, although we obtained the correct result, our path in getting there is not good. We shouldn't have to change the original variable because if you go to a grocery store, it doesn't make sense to purchase a decimal amount of cheese blocks. You can buy 1 cheese block or 2 blocks of cheese. The point is, this should be a whole number, not a decimal. So put this back to an int. But now we have a problem in that we have 2 values being stored as integers, as whole numbers, and we need an operation between 2 whole numbers to return a double result. How do we solve this conundrum? So inside the calculation, what we can actually do is place brackets before one of the integers. I'm going to place one right before the purchased blocks of cheese. And here we can tell Java, cast this number to a double before using it in the math calculation. Alright, we will visualize the runtime in just a second. And now the mortgage broker wants to know your monthly salary, but they're not interested in knowing your salary at the level of cents. They want you to give them a whole number. So for the sake of clarity, what I'll do is I'll create an integer variable called rounded salary, and I'm going to set it equal to this double. We obviously get an error because int can only store integers, it can only store whole numbers, it cannot store double values. So what we can do is cast this double value to an integer before storing it in our variable. And now that this variable stores the salary as an integer, we can present that number to the mortgage broker. We're going to present the rounded salary instead. And now let's visualize the runtime again. So here each variable stores an integer value, as you can clearly see, 2 whole numbers, no decimals. But what Java is going to do here is cast this number to a double before performing the division. And because at least 1 decimal is involved in this operation, Java is going to return a decimal of 0.0005. Or 5 times 10 to the negative 4. And here the monthly salary is going to get stored as a double inside of the salary variable. But our rounded salary variable is going to store this salary as an integer, which we then end up displaying to our mortgage broker. In this lesson, you learned to cast values from one type to another. Inside brackets, just tell Java the type that you want to cast your value to. In this case, we cast an integer to a double. You can also cast a double to an integer. In this lesson, you will build an interactive application, and this application splits into two parts. Part 1 is going to be to ask the user questions and pick up their answers, and part 2 is to respond to the user based on the answers they gave us. Okay. Step 1 of this process is going to be to create an instance of Scanner that can receive input from the system. Scanner contains many methods that we can use to scan for user input. 3 of those methods that we're going to use in this lesson are nextInt, which we can use to scan for integers, nextDouble, which we can use to scan for decimals, and nextLine, which we can use to scan for text. Now, Scanner with all of its logic and methods is defined inside of java.util. So in order to use Scanner, we need to import it from there. So write Scanner, click on the first option, and it's going to import Scanner from java.util. Perfect. And just like we can create a variable of type string, a variable of type double, a variable of type int, we're going to create a variable of type Scanner. And by doing so, we can set this variable equal to a new instance of Scanner that can receive input from the system. And the code needed to do that is actually documented by simply hovering over the Scanner type, and we can use the following code to set our variable equal to a new instance of Scanner that can receive input from the system. The new keyword is explained in more detail once you reach Module 2, Object-Oriented Programming, but for now, all I want you to know is that we've defined our scanner and now we can use its methods in order to pick up integers, decimals, and text from user inputs. Alright, so step 2 is actually to use scanners as methods to pick up input from the user. So here we're asking the user, what is your name? And upon printing this message, we need to tell Scanner to wait for them to enter the next line. So next line is going to wait for the user to enter text, and it's going to pick up that text, return it as a string, which will then get stored in our variable. And so after the user enters their name, next, how much money do you spend on coffee will get printed. Here, once again, we need to wait for the user to enter the next double this time. So the runtime is going to stop at line 17, wait for the user to enter the next double, which will get picked up as a double value and then get stored in the variable price. After they enter their double, then this message will get printed. How much money do you spend on fast food? Once again, we can use Scanner to wait for the next double to be inputted by the user, which we're going to pick up and then store in the variable food price. And then we're going to ask the user how many times a week they buy coffee. We can pick up their answer using nextInt. The integer that the user enters is going to get picked up as an int value and then stored in the variable coffee amount. And finally, we ask the user, how many times a week do you buy fast food? Once again, we need to tell Scanner to wait for the user to enter the next integer, which is going to get picked up as an int value and then stored in the variable food amount. So we're actually done part 1. That was pretty quick. We do get a warning here telling us we have a resource leak. We'll address that in a bit. For now, let's just visualize the runtime by putting breakpoints everywhere. Alright, press debug. So first it prints, welcome, thank you for taking the survey. Then we're going to ask the user for their name, press continue. Now, if I press continue again, notice that the runtime stops at line number 13. Now Scanner is waiting for me to enter text. I'm going to enter the name Rayan. The text Rayan is going to get picked up by Scanner as a string, which will then get stored in the string variable name. Let's see this in action. If I press enter, then runtime will continue again. And beautiful. And now we ask them how much money they spent on coffee. If I run this line of code, the runtime will stop at line number 16 until the user enters the next double. So here I'm going to enter $1.50. As soon as I press enter, that number is going to get picked up by Scanner as a double, get stored in the variable coffee price, and runtime will resume. Perfect. If you live in a region that uses comma for decimals, then it's likely that your application just crashed as a result of an input mismatch exception. Your scanner's locale is different than mine, so Next Double was actually expecting you to input a decimal as follows. So please input your double based on what scanner expects you to input. We will run line number 18, and at line number 19, once again, the runtime will stop until we enter a double. We'll say $4.50. Upon pressing enter, it's going to get picked up by scanner as a double and stored in the following variable. So now food price equals $4.50, coffee price equals $1.50. How many times a week do I buy coffee? By pressing continue, scanner is going to wait for me to enter the next integer. I'm going to say I buy coffee 5 times a week. That integer is going to be picked up as an int value and get stored in the variable coffee amount. How many times a week do I buy fast food? Once again, by pressing continue, it's going to wait for me to enter another integer. I don't buy fast food that often. We'll say once a week. And that got stored in the variable food amount. There were no other breakpoints, so the runtime just continued printing the following text. But I can assure you that food amount did store the number 1. Alright, and once you're done with scanner, always close it, otherwise you're gonna get a resource leak. And now your warning should be gone. Now it's time for part B, where we respond to the user. So at this point, the user inputted their name. So here what we can do is say, thank you, whatever name they input, for answering all counter questions. And what I want to do is replace this with a counter that counts how many questions were asked. So here I'm going to say int counter is equal to 0. And every time a question is asked, I'm going to say counter plus plus. Remember, the plus plus operator increases a variable's value by 1. And after we count every single question that was asked, we can replace this placeholder with the result of our count. Okay, and now weekly you spend some amount of money on coffee. So here what we need to do is multiply the coffee amount by the coffee price. And here what we need to do is multiply the food amount by the food price. And we don't need space here. And congratulations, you built your first interactive application. Before we visualize the runtime step by step once more, let's just run it normally using javac survey.java and then java survey. So first it asks me for my name. Next line waits for me to enter in a string. How much money do you spend on coffee? Now it waits for me to enter a double, which then is going to get stored inside of coffee price. I'm going to submit a double of $1.50. I'm going to submit a double of $4.50 here. This value is going to get stored inside of food price once it gets picked up by scan.nextDouble. How many times a week do you buy coffee? I do drink a lot of coffee. How many times a week do you buy fast food? We'll just say once. And now, after I'm done, it says, thank you, whatever name was inputted, Rayanne, for answering all 5 questions. The counter started at 0 and every single time it increased by 1. Weekly, you spend whatever the result is from multiplying these two, $7.50 on coffee, $4.50 on fast food. All right, and now before we wrap things up, this output feels kind of cluttered. And so what I want to do is, before asking each question, insert a new line of space. What we can do inside of a string is insert an escape character. An escape character is identified by the backslash, and it's a way of telling Java, hey, the next character that comes is special. And so by inputting n, you're telling Java, insert a new line of space here. I want to insert a new line of space here, a new line of space here, and before every single question. And we'll put a new line of space over here. And now our output should look a lot prettier. And just to introduce some variety, let me run the application in debug mode so that we can do a full recap. Here, counter starts by equaling 0. First, I ask the user, what is your name? And by printing /n, we're printing a new line of space, and what is your name gets printed afterwards. And now by running line number 13 of my code, scanner is going to wait for me to enter a string, which it will then pick up and store in the following variable. I will say Rayan, submit it. That gets stored in the variable name. Counter ++ increases our counter's value by 1. How much money do you spend on coffee? And here, before printing the text, it's going to print a new line of space. Run line number 17. Scanner is going to wait for me to enter a double, which will then get stored in coffee price. Our counter is now 2. Here I will say $4.50. Now counter is 3. How many times a week do you buy coffee? 5. It's probably more than that. How many times a week do you buy fast food? We'll say once. And after picking up all of the user's answers, we respond to them with the following messages. Congratulations, you built your first interactive application with Java. Debugging is a must-have skill for any programmer. So let me just clear this terminal, this one as well, and start fresh. The purpose of this code is to calculate the decimal average of 3 exam scores. And if I run this code, so if I go to my terminal and I just say javac debugging.java, what happens? What kind of result do we get? We get a decimal average of 0. This is clearly incorrect. Between scores of 85, 90, and 95, the decimal average should be like 0.9, but instead we get 0. Clearly we have a bug in our code. A bug is a flaw in our code that causes it to produce incorrect results. And when you do get a bug, you might feel overwhelmed or be tempted to ask for help immediately. And as much as I enjoy communicating with you guys on Discord, it's very important that you learn how to solve bugs on your own. Fixing bugs in your code is called debugging. And debugging involves tracing the runtime step by step instead of running all of the code at once. That way you can pinpoint where things are going wrong. So what I'll do is I will place one breakpoint at line number 7, one breakpoint at line number 13, and one breakpoint at line number 19. And now what I'm going to do is press the debug button. So I'm sure you've seen me press the continue button a lot. Continue, what it does is it goes from one breakpoint to another, running all of the lines of code in between. So if I go from breakpoint 7 to breakpoint 13, it runs all of this code and stops over here. And now if I press continue again, it goes from 13 to 19. And if I press continue again, there are no other breakpoints, so the runtime just stops. And uh-oh, it seems we've missed what's going on. So what I'll do is press debug again. And instead of just continuing to the next breakpoint, what I'll do is I will just step over line number 7. Only running this line, this just creates a variable that stores the value 85. Nothing interesting. I will step over line number 8, line number 9, line number 11. So running these line by line doesn't really produce anything interesting. I've got 4 variables, each one stores some type of score. But now if I just step over line number 13, I notice the first mistake. The decimal score for exam 1, while it should be 0.85, it's actually 0.0. So I've identified where things are going wrong. Now I know where to investigate. The division of two integers is going to ultimately produce an integer result, cutting off all the decimals. So 85 divided by 100, while it should produce 0.85, cutting off all the decimals will produce 0, and storing that as a double, it becomes 0.000. And I should see the same thing over at line number 14 and line number 15. That is not very good. So what I'm going to do is fix this code by making these into a double. Alright, and now what I can do is press the restart button to restart the runtime after having made these changes in my code. And now instead of stepping over these line by line, I'm just going to continue to the next breakpoint, run all of these at once. We can see that now all of these are decimals. This remained an integer, which is fine because if at least one of the numbers in the operation is a double, then the result of the operation will ultimately be a double result. So I'm going to step over these line by line to visualize this carefully. And indeed, we do get the appropriate decimal scores. So now if I add all of these up and divide them by 3, I know I'm going to get a good average. So if I just press continue, we should be good. And just for good measure, we can run all of the code at once by pressing run. Beautiful. So you can either run your code to run everything all at the same time, or you can debug your code and have it stop at particular breakpoints so that you can investigate what's going on and trace the runtime step by step. In this course, we're mostly going to be running in debug mode because I think it's a very valuable skill to learn. It is so important to be able to look to your left and identify the state of your variables. In the workforce, you're going to encounter a lot of developers just spamming print line statements everywhere to try to inspect the state of their variables. Please don't ever do that. I consider that to be wrong. Do not clutter your code with print statements to understand what's going on. Use breakpoints. They are so useful. And I promise you that learning how to use them will make you a debugging master. In this video, we're going to tackle a common issue that I like to call the next line trap. Now, there's one thing I want to really emphasize. Please make sure that section 2 is the only thing that shows up inside of your file explorer. Next line gets skipped when you place it after next int, next double, next long, or next. That is the next line trap. And why does that happen? The thing is, next int skips the white space and picks up the next integer. Next double skips the white space and picks up the next double. And the same thing can be said for next long and next. But next line is different because it doesn't just pick up one value. It picks up an entire line of data. And that property is what makes it vulnerable to the next line trap. Let's see it in action. So what I'm going to start by doing is opening up a new terminal window that points to section 2. I can go right ahead and compile the code inside of next line trap. Oh, forgot my .java. And then run the compiled code using the Java command. All right, beautiful. It starts by asking me to enter my age, my friend's age, and my parents' age. So the nice thing is about next int is that it doesn't care how much space I put in between each integer. So I could put 30 here, I could put 7 spaces, and then say 31 here. Then I could enter a whole line of space and say, I don't know, 60 here. This is going to pick up the next integer. This is going to skip all the white space, pick up the next integer. This is going to skip all the white space and just pick up the next integer. Beautiful. All the integers we can tell were properly picked up because they were then printed over here we see my age, my friend's age, and my parents' age. But hold on a second. Next line was just completely skipped, and we went all the way over to here. That's not good. Well, the problem is whenever you put next line right after a next int, a next double, a next long, or next, it gets skipped. Let's see exactly why that happens. So what I'm going to do is ask you to put one breakpoint over here and press debug. Okay. Now do not press continue because continue continues to the next breakpoint and there are no other breakpoints. What I want you to do is press step over to step over this line of code. All right, here it's going to ask me to enter an integer. So I will enter the next integer over here. I'll say 30, press enter. It gets picked up. Beautiful. Here, once I run this line of code, line number 10, it's going to prompt me to enter another next integer. We'll say 34. All right. And here, it doesn't matter how much space I put. If I say something like 60, press enter, everything works beautifully. So all of these values were picked up, which is good. But now this next line is going to be wasted. The reason is that the last next int, when it picked up 60, it didn't care about the remaining line of space. So when next line comes, it's going to recognize the empty space that wasn't consumed, and then it's going to be ready to consume it, essentially being wasted on empty space. That's not very good. So what I'm going to do is stop the runtime here, because the solution to the next line trap, whenever you have a next line after a next int, a next long, next double, or a next, is just to place a throwaway next line right before the real next line. So here we'll say throwaway next line to be wasted on empty space. Oh, spelled that wrong. We'll put one here as well. Put one here as well. And here too. And now our app should work beautifully. We have avoided the next line trap. And what I'll do is I will place a breakpoint where the next double example starts, where the next long example starts, and where the next example starts. All right, rerunning the runtime in debug mode so that we can visualize things step by step. So I don't want to continue to the next breakpoint. I just want to run line number 8. So I'll press step over. If I run this line of code, it's going to prompt me to enter a next int. We'll say 31. If I run this line of code, line number 10, it's going to prompt me to enter a next int. It doesn't matter how much space I put. If I say something like 34, it's going to skip all the white space and go to the next int, pick it up. Oh, forgot to press enter. Here as well, if I step over line number 11, it's just going to wait for me to enter the next int and pick it up. Regardless of how much white space I put in, it doesn't care. Here we print the values that we picked up. All right, and then we enter a greeting. Now you'll remember that because next int, it didn't care about the remaining line of space. This next line is going to notice the line of space that wasn't consumed, so it's going to get wasted on an empty line, as you're going to see very shortly. So our throwaway next line was completely skipped on the empty line, and now our real next line is ready to pick up real user input. Enter a greeting, hello. And now I can continue to the next breakpoint. Okay. So here I'll go through this one more time and I'll let you go through the remaining examples yourself using breakpoints, just because I want you to practice stepping over lines of code and continuing to the next breakpoint. It's always nice to be visualizing your code line by line so that you have full control over what's going on. So I'll do one more example with you. Here we enter the price of a book, a coffee, and a meal. Stepping over line number 22. Don't press continue, press step over. We don't want to continue to the next breakpoint. Here, if I step over line number 23, it prompts me to enter a next double. Doesn't matter how much white space I put. We'll say $20.99. Gets stored in book price. Beautiful. Coffee price, we'll say, I don't know, $32.99. That's a very expensive cup of coffee. And then we'll say meal price, I don't know, $55.99. Inflation is through the roof. Okay. Here we print all the values that we picked up. And now because this next line comes after a next double, it's going to realize that the last next double did not consume the remaining empty line. So it sees that there is still white space to be consumed, gets wasted on it. The throwaway next line did its job because now the real next line is ready to pick up user input. Enter a restaurant name. We'll say, I don't know, Java Foods. That gets picked up, and business as usual. And for the sake of practicing using breakpoints, keep stepping over each line of code using step over, and whenever you want to continue to the next breakpoint, use continue. All right, I'm going to stop right here and provide a final recap. The next line trap occurs when next line comes after next int, next long, next double, or next. And the solution is to just add a throwaway next line before the quote-unquote real next line. You're going to see an example in the upcoming workbook. I hope you're excited. In this lesson, you will use the Boolean type, create a new folder called section 3, and then launch that folder inside of Visual Studio Code. Inside of our section 3 project, we're going to create a new file called booleans.java. You will write all of your code inside of a class that shares the same name as the file. And as always, create your main method. Java only allocates the smallest unit of data for the Boolean type, 1 bit, and that's because a Boolean is limited to 2 values, true or false. Now, defining a Boolean is no different than defining any other variable. First, you specify the type, followed by the variable name, we'll call it bool1, and you can only set it to one of 2 possible values, true or false. I will create another variable called boolean2 and set it equal to false. Alright, I will print each one, sysout, bool1, sysout, bool2. There's really not that much going on here, but let's visualize the runtime anyway. So by executing line 3 of our code, I'm creating a Boolean variable that stores a value of true. Here I create a Boolean variable that stores a value of false. And here I print each Boolean. First we print true, and then we print false. Nothing too interesting, that's pretty much it. And you might have been wondering, what was the point of all this? And to be honest with you, nothing. Storing Booleans like this is pretty useless, but at least now you're familiar with all of the core data types. Booleans in particular are most useful when expressed in the form of a comparison, and that's what we'll be doing in the next lesson. This video is going to explore comparison operators. We're going to look at comparison operators that allow you to check for equality. And we're going to look at comparison operators that allow you to compare relative size. So the four operators we're going to look at to compare size are greater than, less than, greater than or equal to, as well as less than or equal to. The first one we're going to look at is greater than, which returns true if the value on the left is greater than the value on the right. Here the person is asking if they scored better in biology, so we need to write a comparison that checks if biology grade is greater than chemistry grade. If biology grade is greater, this will return true, otherwise false. Here, it's asking if we made money. This is only true if sales is greater than costs. So we're going to return the result of checking if sales is greater than costs. Make sure to wrap that in brackets. And I don't want to run all of the code at once. I just want to run these ones. So what we'll do is we'll just put one breakpoint over here, press debug. Now I could put a million breakpoints and keep pressing continue to the next breakpoint, or I could avoid all that and keep pressing step over to just step over this line. So this creates a variable chemistry grade that equals 95, biology grade 75. Here we ask Java a question, and Java is going to answer by comparing biology grade to chemistry grade. This should return false, because biology grade is smaller than chemistry grade. That makes sense. Well, what if we made this into a 98? Restarting the runtime from this breakpoint. Okay. Now, it's pretty clear that biology grade is greater than chemistry grade, so this will return true. Beautiful. Here, we're checking if sales is greater than costs. It definitely is, so we made money. Cool. The next operator we're going to look at is less than, which, as you can probably guess, returns true if the value on the left is less than the value on the right. So here, it's asking if the temperature is colder than our target. So what we need is a comparison that checks if the temperature is less than the target temperature. Let's stop the runtime and put some brackets over here where we can compare our temperature and check if it's less than the target temperature. So this will return true if the value on the left is less than the value on the right. Here it's asking if we're driving slower than the speed limit. So once again, we need a comparison that returns true if the value on the left, in this case, current speed, is less than the value on the right. And so I'm going to add another breakpoint over here, press debug. So this would be a good time to use continue, because I don't want to step over each line. I just want to continue to the next breakpoint, and it runs everything here right away. I want to skip all of these as well and just let them run right away. So we'll continue to the next breakpoint. And now we will just step over this line because I want to visualize this one line by line. So our temperature is 15.5. Our target temperature is 20. This asks if the temperature is colder than our target. And that is indeed going to be true because temperature is less than target. Pretty simple. Stepping over this line, it creates two variables where the current speed is indeed less than the speed limit. So that should return true. If we go, let's say, at 85 kilometers an hour, restarting the runtime, pressing this button to restart, we can just continue to the next breakpoint, continue to the next breakpoint. We'll add one more breakpoint here so we can continue to it. And we'll just run this block line by line. We are not driving slower than the speed limit because now the current speed is 85. All right. The next operator we're going to look at is greater than or equal to. This one returns true if the value on the left is greater than or equal to the value on the right. So here, we'll stop the runtime. It's asking Java if we're old enough to retire, and this is where we need to make our comparison. So we need a comparison that returns true if the age is equal to or greater than the retirement age. I can think of nothing other than the greater than or equal to operator. All right, let's put a breakpoint right here. Continue, continue. We'll just let these run naturally. And we'll stop here, stepping over this line, stepping over this line. Age is 45, retirement age 65. Am I old enough to retire? Age is not greater than retirement age, nor is it equal to the retirement age, so this is going to return false. Okay, now what if I am 65? Okay, restarting the runtime, continue, 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 continue. Okay, this time the age is 65. That's not greater than the retirement age, but it is equal to the retirement age, so this should return true. Because this checks if the value on the left is greater than or equal to the value on the right. So if we make this greater than the retirement age, then you can rest assured we are old enough to retire. Let's just skip over to here, and we can expect this to return true as well. Beautiful. Now, the final operator we're going to look at for comparing size is the less than or equal to operator, and as you can probably guess, this one returns true if the value on the left is less than or equal to the value on the right. So here it's explicitly checking, is my salary less than or equal to the maximum salary? So it's no secret that we need to use the less than or equal to operator. So we'll check if salary is less than or equal to the maximum salary. It clearly is, but let's just run the code anyway. All right, put a breakpoint here so that continue can continue to this breakpoint instead of just running the remaining code. Stepping over this line, stepping over this line. Salary is 50,000, maximum is 60,000. It is indeed less. So this is going to return true. What if we make these equal? All right. So the salary is not less than the maximum salary, but it is equal to it. So that's going to return true. But if we make this greater, then none of these are going to be true. So this will return false, but let's see it in action anyway. Stepping over this line, stepping over this line. The salary is not less than the maximum salary. It's not equal to the maximum salary either. So we are just going to end up with a value of false. All right. Now let's look at the equality operators. Equal, equal, and not equal are used to compare values for equality. The equal, equal operator returns true if two values are equal and false otherwise, and the not equal operator returns true if two values are not equal and false otherwise. All right. So here apparently the best possible grade you can get for a class is an A, and we want to check if we got the best possible grade. So we compare this character against this one using the equal, equal operator. We want to return true if my grade equals the best grade. And I don't want my code to stop here anymore, so let's remove all the breakpoints by going here uncollapsing this, pressing X over here to delete all the breakpoints. And I'm only gonna have one breakpoint over here. I want all of these to run naturally, and I want my runtime to just stop over here. Let's do just that. Actually, before we do that, we can also apply the equal operator over here. Hi Java, is this the correct phone number for my contact? So here we need a comparison that returns true if both of these are equal. So we'll check if phone number equals contact number. And might as well put these in brackets just to remain consistent. All right, we'll put one breakpoint over here, and now let's run and debug. My grade is an A, the best grade is an A. These two are definitely equal, so it's gonna return true. The phone number we were given is the following. The one we recorded is this one. We want to make sure they're equal. They indeed are. So that's going to return true. Now, if the phone number was wrong for some reason, okay, now clearly these two are not equal, so this comparison is going to return false. And now this one is asking me, are these two letters different? So now we want to put in a comparison that returns true if these two values are not equal. So what we're going to do is use the not equal operator. We're going to return true if letter 1 is not equal to letter 2. Same thing over here. Hi Java, are these two distances not equal? So we want a comparison that returns true if distance 1 is not equal to distance 2. All right. Let's put 2 breakpoints here. We'll remove these ones just so the runtime doesn't stop here. We want all of this to just run normally and stop at line 44. Here, I'll just press step over to step over the line, step over line 45. Are these two letters different? A is not equal to B, so this is going to return true. Beautiful. Stepping over these lines, distance 1 is not equal to distance 2, clearly, so that's going to return true. Nice. All right, and we'll be looking at strings in the next video. We're going to wrap up right here for now. In summary, the 4 operators greater than, less than, greater than or equal to, less than or equal to are used to compare relative size, and the equality operators equal, and not equal are used to compare values for equality. But one thing all of these operators have in common is that they return true or false depending on whether the comparison is true or false. You should be very careful when comparing strings in Java. Never ever use the equal or the not equal operator when comparing strings for equality. You will get inconsistent results. So here, what I'm doing is I'm checking if these two words are the same. So what we need to do is create a comparison that returns true if word equals second word. Now, you might expect this to return true because both values are indeed equal, but what can we expect? I'm going to remove all the breakpoints that I have and only put one right here. That way, when I call run and debug, everything before it runs, and I skip straight ahead where word equals hello, second word equals hello. I expect this to return true, but what does it do? It returns false, unfortunately. Okay. That being said, never use equal with strings. You will get inconsistent results. And the reason why equal doesn't work when comparing string values has to do with how memory is being allocated. And in the interest of keeping this lesson on comparisons, I'm not going to get into it, but I really want to emphasize whenever you see the string type or these double quotes, stay as far away as possible from the equal operator. Instead, you can compare one string to another by calling dot equals from one of them to check if the first string equals the second string. All right, and here we need a comparison that returns true if third word does not equal the fourth word. And it's really important that you do not fall into the trap of using the not equal operator. You are going to get inconsistent results. Never use equal equal or not equal with strings. Instead, we use dot equals to compare two strings. And if I want to check if third word doesn't equal the fourth word, I can add my not operator right over here. And that's pretty much it. So now I've got one breakpoint over here. I'll put one over here, press debug. This one checks if the first word equals the second word. That should be true. This one checks if the third word does not equal the fourth word. That should be true. And we are golden. So to summarize this lesson, just follow the golden rule of never using the equal equal operator or the not equal operator with strings. Instead, you should use equals or not equals to compare string values for equality. Doing so will prevent unexpected results and bugs, and it's going to save you from a lot of headache. Welcome back. Now we're going to dive into if-else statements. We're going to learn how if-else statements can be used to run specific code blocks based on various conditions. Anyways, here is the basic structure of an if-else statement. Beside the if keyword, you have a condition. The condition is usually the result of a comparison that returns true or false. So comparisons such as greater than or less than or equal to, equal, whatever it may be, anything that returns a Boolean. If the condition is true, the code inside the if block will execute. If the condition is false, the code inside the else block is going to execute. Now let's dive into our Java file and explore some examples. So here, in example 1, it's saying, did I score better in biology? So here, what we're going to do is check if the biology grade is greater than the chemistry grade, then we are going to print, yes, you did, congrats. Otherwise, if this ends up being false, then we're going to print, no, you did not. All right. Here it's telling me, hi Java, did we make enough money? So we need to check if the sales is greater than costs. If that's the case, if this comparison returns true, then we're going to print, congrats, you're rich. Otherwise, we'll just print something like, not this time. Hi Java, is the temperature colder than our target? So here we're going to check if the temperature is less than the target temperature. Then we're going to print, yes it is. The temperature is colder than usual. Otherwise, no, it is not. All right, there's only 4 left. Here it's saying, hi Java, am I driving slower than the speed limit? We'll say if the current speed is less than the speed limit, then we're going to print you are driving lower than the speed limit. Otherwise, if they're going above the speed limit, we'll say, please slow down. All right. Hi Java, am I old enough to retire? So here we need to check if the age is either greater than the retirement age or equal to it. In that case, we're able to retire. And we'll tell them, enjoy your pension. Otherwise, we're going to print you still have to work for retirement age minus what their age is, this many years. I should wrap that up in brackets. Okay. Here it's asking if we got the best possible grade. This is a char, so we can just say if my grade equal the best grade. If that's the case, then we're going to print, congrats, you got the highest score. Otherwise, we'll say no, but you will next time. All right, and now here we need to compare 2 strings. Are the 2 words the same? Remember, never ever compare strings by using the equal operator. We're going to say if word dot equals second word. If that happens to be the case, then we'll say they are the same. Otherwise, we'll print they are not. Okay. Now for this one, are the 2 words different? We're going to check if the third word does not equal the fourth word. So don't forget your not operator to check if the third word does not equal the fourth word. If that's the case, we'll say they are indeed different. Otherwise, we'll say no, they are not. All right, I think we're ready to trace the runtime step by step. So what I'll do is I'll put a breakpoint at line number 9, line number 20. So your line numbers may be different, but put a breakpoint wherever you see an if statement. Number 31, number 42, line number 53, 63, 74, and 86. All right, we'll run the app in debug mode. So biology grade is 75, chemistry grade is 95. So this is going to evaluate to false, running the code inside the else statement. So if you press step over, we see line number 12 running. All right, we'll continue to the next breakpoint. So here sales is 37.5, cost is 5.55. This is going to evaluate to true. So we expect the code inside of line 21 to run. So press step over. Congrats, you're rich. All right, let's just continue to the next breakpoint. So here the temperature is 15.5. The target is 20. Temperature is less than target. So this is going to return true and execute line number 32. Beautiful. Here the current speed is 60, the speed limit is 70. They are going within the speed limit, so line number 43 is going to get called. Okay, continue to the next breakpoint. Here it's checking if we are within retirement age. Our age is not greater than retirement age, nor is it equal to it, so we expect the else block to run, and what that's going to do is calculate how much time you have left until you can retire. You still have to work for 20 years. That's kind of sad. All right. Now, line number 60. Well, we don't care about that. Let me just continue to the next breakpoint. Here we're checking if my grade equals the best grade. And we can compare two characters using the equal operator. And because they are equal, this returns true. Executing line number 64. Now I'll just continue to the next breakpoint. Here, because we're comparing two strings, we must use the equals method, not the equal operator, the equals method to compare the two strings. And because the condition is true, the code inside of line 75 is going to run. Now I'm going to press continue. Here we're comparing the third word against the fourth word, checking if they're not equal to each other. That is indeed going to return true. Executing line number 87. And now if I press continue, because there are no other breakpoints, the runtime just stops. This is just beautiful. Now before we finalize this lesson, I just want to point out some common pitfalls that I see students fall into. So checking if my grade equals the best grade, this is a comparison because we're using the comparison operator. This returns true or false. I often see students use the single equal sign rather than the double equal sign. This is wrong. Equal is an assignment operator. This means that you're setting my grade equal to best grade. This is a comparison operator. This returns a Boolean result. So please do make the distinction. This is an assignment operator and this is a comparison operator. Two very different operators. And that's pretty much all I wanted to warn you about. And now, for the sake of just finalizing this video, we can just run all of the code at once and say java c if else.java, java if else, and beautiful. In the previous video, we tested only one condition. In this video, you will learn to test many conditions by embedding a series of else-if statements. Alright, let's start with our first example. So here the weather is rainy, and if the weather is sunny, we need to print the following message. If it's rainy, we need to print bring an umbrella. Otherwise, we're not sure what to do with the weather. Simple enough. So we'll say if the weather equals sunny, then we'll print it's a nice day for a walk. Otherwise, if the weather equals rainy, so if this condition evaluates to false, the next condition that it's going to check is this one. If this evaluates to true, we're going to say bring an umbrella. And now if both of these end up evaluating to false, then we'll say else. We're not sure what to do in this weather. Simple enough. Here we'll say if the score is 80 and above. So if the score is greater than or equal to 80, then they got an A. Else if the score is greater than or equal to 70, then we're going to say you got a B. Else if the score is greater than or equal to 60. So if this evaluates the false and this evaluates the false, we need to check this condition. If that's the case, if they have a 60 and above, then they got a C. If this evaluates the false as well, okay, now we've entered the 50s range. If the score is greater than or equal to 50, then we need to tell them that they got a D. But if their score is not greater than 80, if it's not greater than 70, if it's not greater than 60 or 50, then we know that it's under 50, in which case they failed. Unfortunately. All right, now what I'm going to get you to do is do these ones on your own. I'll give you a couple of seconds to pause the video, and then I'll just show you the solution so that you can compare. All right, so I hope you came up with something like this. If the title equals CEO, they're the boss. If this evaluates the false, we then check this condition. If it equals manager, they're just in charge of a team. Otherwise, they are employed. And here, first, we check if it's an A. If it is, excellent work. If it's not, we check if it's a B. Then we check if it's a C, a D. And if all of these evaluate to false, then we run the code inside of else. So I'll put one breakpoint over here, one here, one at line 30 for me, and line 40 for myself. So wherever you see an if statement. Then I'll press the debug button. Okay, collapsing this a little. So here you can see the weather is rainy. It doesn't equal sunny, so this evaluates to false. If I press step over, it's going to go to the else if statement. So here it's going to check if the weather equals rainy. This should evaluate to true, running the code inside of else if. And because this evaluated to true, nothing else is going to run. Beautiful. Now, what if I change this to sunny? All right. Here we start by checking if the weather equals sunny. This is going to evaluate to true. Printing, it's a nice day for a walk. Because this evaluated to true, nothing else is going to run. And we're finished. Okay. Now what if I say something like cloudy? Restarting the runtime. So first we check if the weather equals sunny. This evaluates to false. Then we check if the weather equals rainy. This evaluates to false as well. So we run the code inside of else. We're not sure what to do. All right, now the score equals 85. First, we check if the score is greater than or equal to 80. It is, so we got an A. Because this evaluated to true, nothing else is going to run. And we go directly to line number 28. But what I'm going to do is change this to a 70, or let's say 74. Remove this breakpoint and restart the runtime. Now the value is 74. 74 is not greater than or equal to 80, so this evaluates to false. So it has to be less than 80. Is it greater than or equal to 70? Indeed it is, so we got a B. Because this evaluated to true, nothing else is going to run, and we go directly to the next breakpoint. Okay, what if I make this into a 54? Restarting the runtime. Goes directly to breakpoint at line number 16. 54 is not greater than or equal to 80, so it has to be less. It's not greater than or equal to 70, so it has to be less. It's not greater than or equal to 60 either, but it is greater than or equal to 50, so they got a D. Okay, what if I make this into a 30? Restarting the runtime. It's not greater than or equal to 80. This evaluates to false. This is going to evaluate to false as well. False, false. And at this point, we know the score is less than 50, in which case they failed, unfortunately. Okay, continuing to the next breakpoint, line number 30. Here, their job title is manager, which does not equal CEO, so this condition is false. We go to this one, then we check if the job title equals manager. This condition is indeed true, so the code inside of it is going to run and nothing else executes. They are a manager, so they are in charge of a team. Perfect. Here they got a B, and so what we're doing is comparing this variable against 4 different letter grades. First, we check if the grade equals A. This condition evaluates the false, so we compare it against another value. Here, this condition will evaluate the true because the grade does equal B. Executing the code inside, what if I give them a D? Restarting the runtime. How about I remove this breakpoint, remove this one as well, and then just continue to this one. Okay, so the grade does not equal A, this evaluates the false. It does not equal B either, does not equal C. It does equal D, which means they still pass. Beautiful. And that's it. And now if you want, feel free to run all of the code at once. If else, .java, Java if else. Nice. So in this lesson, you connected a series of else if statements. Java is going to test each statement until one of them is true, and then it runs the code inside. And if all the conditions are false, then Java is just going to run the else statement. We can use logical operators to make our conditionals a little more complex. There are 3 types of logical operators: and, or, and not. We're going to use these operators to give conditions a bit more logic. Alright, let's begin. So the AND operator, represented by ampersands, what it does is it returns true only if both conditions are true and false otherwise. Let's look at the following scenario. Here we want to print, or we want to allow the user to legally drive if they have a license and if they have insurance. Otherwise, if one of these is not met, they cannot legally drive. So what we can say is, if they have a driving license and if they have insurance, then we're going to allow them to drive. Otherwise, they cannot legally drive. Now, before I do anything else, I want to mention one thing. Some of you might be tempted to say if has driving license equals true and has insurance equals true, then we allow them to legally drive. Please don't do this. This is very redundant. Think about it. The purpose of a comparison is to return either true or false. But the variable itself is already a Boolean, so there's no need to write an operation that will eventually produce a Boolean when we already have one. If this is true and if this is true, they can drive, otherwise they cannot. Before we run our code, let's do some more. So here we can only make them eligible for a loan if they're at least 21 and if they have an income of at least 40,000. Otherwise, they are not eligible. So we'll say if the age is at least 21, if it's greater than or equal to 21, and if they have an income greater than or equal to 40,000, if both of these conditions are met, then we're going to print you're eligible for a loan. Otherwise, they are simply not. All right. And here, we can only grant them access to their account if both their username and their password are correct. So we'll say if the inputted username, if it equals the correct username, and if the inputted password is equal to the correct password, then we can allow them access to their account. Otherwise, okay, that's pretty much it. Now what we're going to do is place one breakpoint here, one at line 18, one at line 30, and debug the runtime. So here, this is true and this is true. Because both of these are true, then the entire condition is going to be true, allowing them to drive. What if we made one of them false? What if they don't have insurance? So what we'll do is we'll restart the runtime. So although they do have a driving license, because they don't have insurance, one of these is false, so the entire condition is going to end up being false. They cannot drive. What if we made this true and this false? We can expect the same result. The AND operator requires both of these to be true. However, one of them is false. They don't have a driving license, so the entire condition is going to evaluate to false, running the code inside of else. All right. Here the person is 25. They have an income of 45,000. This comparison is going to be true. This is going to be true as well, which means the entire condition is going to end up evaluating to true. They are eligible for a loan. What if I make this equal to 35,000? So here, although, let me remove this breakpoint and just jump straight to the next one. So here, although this returns true, they do meet the age limit, their income is not greater than or equal to 40,000. One of the comparisons is false, which means the entire condition is going to end up being false. They are not eligible for a loan. Okay? And to grant someone access to their account, their username and their password needs to be correct. In this case, the inputted username does equal the correct username. The inputted password does equal the correct password. We expect this entire condition to be true. But if for some reason, let's just say they capitalized their inputted password by mistake, passwords are of course case sensitive. Let's restart the runtime. In this case, one of these comparisons is false, which means the entire condition is going to end up being false. They cannot access their account. All right. Now we're going to talk about the OR operator. The OR operator, represented by two vertical lines, is used to return true if either one of the comparisons is true, otherwise it returns false. So here, we want to promote our employee if they have a good performance or if they have been around for a long time. So we're going to say if, well, let's just stop the runtime. If they have a good performance, or if they've been with us long term, then they're eligible for a promotion. Otherwise, if they don't meet any of these conditions, then they're not eligible. Okay? Once again, you might be tempted to say if has performance equals true, or if is long-term employee equals true. Again, this code while it would work, is very redundant. Why write a comparison that will eventually produce a Boolean when your variable itself is already a Boolean? All right. Here we can allow a person to enter the venue if they're at least 18 or if they at least have a parent present. Otherwise, they leave us no choice. So we'll say if user age is greater than or equal to 18, or if they don't meet this condition, we can still check if there is a parent present. If that's the case, we can allow them to enter the venue. But if both of these end up being false, then they leave us no choice but to forbid them from entering. Okay, same thing here. The user has to be at least 18 or have a membership for them to use our service. So we'll say if the member age, if it's greater than or equal to 18, or if they have a membership, then they can access the service. Otherwise, the user cannot access it. All right, let's go ahead and remove all breakpoints from here. I'll add one breakpoint at line 42 of my code, basically wherever there's an if statement in the or operator section. Then I will debug the runtime. Okay. So the or operator returns true if at least one of these is true. They are not a long-term employee, but they did have a good performance. Because one of these is true, the entire condition becomes true and they are eligible for a promotion. All right, what if they did not have a good performance, nor have they been long-term? We'll restart the runtime. In this case, none of these are true, so the condition is going to end up being false. We cannot promote them. Okay. And so this condition is going to return true if at least one of these comparisons is true. The user is not greater than or equal to 18. They do not meet the age limit, but there is a parent present. The entire condition returns true. They can enter the venue. All right, let's just move on to the last one. In this case, the member does not meet the age limit, nor do they have a membership. Because none of these are true, then the entire condition is just going to end up being false. All right. Finally, we can discuss the not operator. The not operator reverses the value of a Boolean expression. Let's have a look. I'm going to start by stopping the runtime. So here we have a comparison that returns true if an option equals cash or if it equals credit. So what I'll do is I'll create a variable called not cash or credit, set it equal to the original expression. I'm going to wrap this up in brackets. The original expression returns true if something equals cash or if it equals credit. But what I can do is reverse the result of this expression to return false if something is cash or credit, and return true if something is not. Here, the following condition returns true if something is a vowel. So what I'm going to do is say Boolean not vowel is equal to the original comparison, which I'm going to wrap in brackets. This comparison returns true if something is a vowel, but what I can do is reverse the result of this expression to return false if something is a vowel and true if something is not. And here, what I'm going to do is say Boolean not hit or stay, copy this condition inside of brackets. This condition returns true if something is hit or if it equals stay, but what I can do is reverse the result of this condition such that it now returns false if something is hit or stay and true if something is not. All right, now before I complete this exercise, I want to place one breakpoint here, here, and here, removing all other breakpoints. pressing debug. So this is going to return true because the option is cash. But what I can do is reverse the result of this expression to return false if something is cash or credit. But if I were to say debit, this is going to return false because it's not one of the options. And because the original expression returned false, the not operator is going to reverse the result to return true. But now we have a condition that returns true if something is not cash or credit. That's beautiful. All right. We can remove this breakpoint. This is going to return true because the letter is a vowel, and this is going to return false because the letter is a vowel. What if I replace this with like an L, restarting the runtime? This is going to return false, and because the original expression returned false, the not operator is going to reverse the result to return true. So now we have an expression that checks if something is not a vowel. All right. Here, the player decided to stay, which is going to satisfy this comparison. This returns true. The not operator is going to reverse the result to return false. If I put an invalid move like, I don't know, sit, restarting the runtime, the original comparison returns false. This one is going to return true, which means now we have a condition that returns true if something is not equal to hit or stay. All right. And so now we have a condition that checks if something is not cash or credit. So let's just copy this over into our if statement. If something is not cash or credit, we're going to tell them to choose another payment option. Otherwise, pleasure doing business with you. Okay. And now we have a condition that checks if something is not a vowel, which we can just copy over inside an if statement. If something is not a vowel, then we're going to print that that letter is a consonant. Otherwise, the letter is a vowel. Okay? And now we're going to say, if the move is not equal to hit or stay, we can tell them to please choose a valid move. Otherwise, they win 10 bucks. Okay? We don't need these anymore. Don't need these. Don't need these as well. Let's just go ahead and visualize the runtime starting from here. So here we know this returns true if something is not cash or credit. Here we know this returns true if something is not a vowel. All right. And here we know this returns true if something is not hit or stay. And that's all. In this video, we have covered 3 logical operators. The AND operator returns true if both conditions are true. The OR operator returns true if one of the conditions is true. And the NOT operator reverses the value of a Boolean expression. You're going to get a lot more practice in the upcoming workbook, so I wish you the best of luck. Switch statements are very powerful. They simplify your code and make it much easier to read. Whenever you're comparing one variable against a long list of values, you should avoid having a long list of else-if statements because this looks, for lack of a better word, disgusting. Instead, you should favor using a switch statement which was designed to compare one variable against a list of cases. Now, there are times when you should use if-else, there are times when you should use switch, and this video will cover just that. And we can begin. But before we start, I just want to present you with a rule of thumb. When comparing a variable against a list of values, favor using switch over if-else. It's just a lot cleaner and more legible. In scenario 1, we're comparing one variable against a list of values. While if-else would work, it would simply be a lot cleaner to use switch, so we're going to do just that. If you write switch, and then press on this option, it should autocomplete a switch statement. Where it says key is where you'll put the variable that you want to compare. And here we can have a list of cases. We're going to compare the weather variable against a case of sunny. We'll talk about the break keyword in just a second. One case isn't enough. We're going to add another case to check if the weather is cloudy. In this case, we'll just leave it empty. And you know what? I want to discuss the break keyword after, so let's just delete it for now. We also need another case where we check if the weather is rainy. And another case where we check if the weather is snowy. All right. And if the weather is sunny, we're just going to say, you can wear a shirt. If it's cloudy, we'll say, you should wear a sweater. If it's rainy, you should wear a raincoat. And if it's snowy, you should wear a jacket. And if it's default, we'll say you can wear whatever you want. So this is the switch statement equivalent of an else block. And now if you wanted to use if-else, it would have worked perfectly. We had a very similar scenario inside of this file where we compared the weather against two possible scenarios, but in this case, we're comparing it against a much longer list of values, and using else if would have just been really tedious. In my opinion, this is a lot cleaner. But if you really want to use if else, then honestly, by all means, go for it. I simply recommend that when you're comparing one variable against a long list, switch is simply more legible. Okay, scenario 2. Here we have a role of 2, and we want to determine the user access level based on the role. 1 is admin, 2 is editor, 3 is user. Again, this is simply another scenario where we're comparing one variable against a list of 3 values. We're going to check if the role, which is an integer, does it equal an integer of 1? If that's the case, we'll tell them you are an admin. We're also going to check if role equals 2. In that case, they are an editor. We're also going to check if the role is 3. In that case, you are a user. If it's the default case, we'll just say, please contact HR. Okay. And now here we want to determine the comfort level based on temperature and humidity. we want to decide whether to use if else or switch. This is a scenario where it is impossible to use switch. The only thing you can really do with switch is compare one variable against a list of values. But what are you going to do here? Make a switch statement and compare this temperature against a million other temperatures? Using switch is simply not practical in this case. We need to use the more flexible if statement that wraps a comparison operation that is able to make much more complex comparisons. So here we can check if the temperature is greater than or equal to 80, and we'll say and if the humidity is greater than or equal to 60, then in that case, we'll print, I don't know, it's too hot and humid. Else if the temperature is greater than or equal to 80, then we'll say it's too hot. Let me add a new line here, a new line here as well. Else if, we can even make this more complex. The temperature is smaller than or equal to 60, and the humidity is greater than or equal to 60, then we'll print it's too cold and humid. Now, I know I'm going a bit overboard with this, but I'm just trying to demonstrate that if-else is suitable for complex conditions and when you need to compare multiple variables. They give you the flexibility to evaluate compound conditions using logical operators. You have the flexibility to compare against different ranges, so on and so forth. So I'm just going to stop rambling on and finish off this example. Else if the temperature is smaller than or equal to 60, then we'll print it's too cold. Otherwise, we'll print it's comfortable. All right. Now we'll get to these in just a second. We're going to race through them, but for now, I just want to execute scenario 3, 2, and 1 because there's still something that we have to address. I'll put 1 here, 1 here, and 1 here. And before we run this code, I want to check for a case of rainy. Okay? So here we're comparing the variable against a list of 4 values. It matches the value rainy. So you would expect it to only run the code that matches this case of rainy, but think about switch in the metaphorical sense that it turns on when there's a case match, running every single case that follows. It's going to run the code for snowy because it comes after the case match, and it's also going to run the code inside of default. And you might have been wondering why there was a break keyword at the end of each case, and it's to address that exact situation. We're going to add a break keyword after every single case, because in the event of a case match, we don't want the other cases to be executed as well. You do not actually need to put a break keyword beside the default case because it's the last thing that would run anyway. So what we'll do is press debug. This is going to match the case of rainy. It's going to execute the block of code inside of line number 8, and then it's going to break the switch statement. Beautiful. So now you know that we also need to add the break keyword over here because we don't want anything to run beyond the case match. We don't need to put it beside default. We'll remove this breakpoint, rerun, restart the runtime. Okay, a roll of 2 is going to match the following case, telling them that they are an editor. And then the break keyword is going to break the switch statement after the block of code runs. Beautiful. And you already know how if statements work, so let's just race through this. All of these are going to be false, running the code inside of else. Beautiful. All right. Now I'm just going to race through these. Once again, this scenario is really complex and there's no way we can use a switch statement for it. So we'll have to set up a logical comparison that checks if someone is or meets the age limit of 18. Check if they're, let's say, younger than 60. And we'll check if their income is greater than or equal to 30,000. In that case, we'll say, congratulations, you are eligible for the credit card. Then we'll say else. If this really complex condition evaluates to false, we'll say, sorry, you are not eligible for the credit card. Okay. Moving on. Once again, this is a very simple scenario of us comparing one variable against a list of 3 other values. We already know this is going to be a switch statement, so let's just race through it. I'll say switch, let it autocomplete. We don't actually need a break keyword over here. You can leave it if you want, it's harmless. But if I don't need something, I like to not include it. So here we'll compare the light color against green, yellow, and red. If it's green, we can just print go. Let's put the break keyword on the same line. I think that's a lot cleaner. If it's red, we'll say stop. And then if it's yellow, slow down. Or in some cases, speed up. I'm just kidding, don't do that. And if it's the default case, probably a power outage. All right. So here we want to compare the grade against different ranges, and based on the range that it falls into, then we can determine if they got an A, B, C, D, or F. This is not a scenario where we can use switch, because what are you going to do? Make a switch statement that compares this grade against 100 other grades? It's just not possible. It's not practical. We need to use if-else. In fact, we've done this before, so let's just go ahead and copy it over. All right. Instead of score, we'll say grade. So I hope you can see that the rule is really simple. Use switch when you can because it's just more legible than a series of else ifs. But when it's not practical to use switch, then 99% of the time you'll be using if else. Here we're comparing one variable against a list of values. I don't know much about Edge or Opera, so let's just delete these two and pretend they don't exist. We'll say switch. We'll compare the browser against Chrome. And if they use Chrome, we'll say, oops, I can't type apparently. If they use Chrome, we'll say, enjoy your Chrome extensions. The break keyword. Sorry guys, I should have collapsed this a long time ago. We'll use the break keyword. If they use Firefox, then we'll say the best non-profit browser. And if they use Safari, then they are most likely Apple users. So we'll say, I see you're a proud Apple user. Not a big fan of the Safari browser myself, but to each their own. And if it's anything else, we'll say, curious. What browser do you use? All right, and in the interest of time, I'm not going to use breakpoints to run the remaining lines of code. I just want to make sure that everything we wrote is good. So what I'll do is I will just run the code entirely using javac, switch statements.java, java switch statements, and all right. We stopped here last time. They are 25. They have a high income. They should be eligible for the credit card. All right, perfect. The light color is green, so this block of code executes. All right. 85, that's an A. We're good. And they use Chrome, so they can enjoy their Chrome extensions. You can feel free to add some breakpoints and debug the runtime, but in the interest of time, I'm not going to do that, and we will stop the video here. If you do have questions about how to debug the runtime here, if you ever get stuck, please feel free to reach out to me on Discord. I would be happy to help. Now it's time to put everything together and build an interactive application using the skills that we've learned. And once you have that all set up, we can begin. So in the first part of our application, we need to ask the user if they want to buy a car, sell a car, and we're going to pick up their option using scanner. Here, I can see myself comparing this variable against a list of other values, which means this is the perfect use case for a switch statement. We're going to check if the option matches a case of A. In that case, we're going to tell them that they chose option A. And we're just going to leave the break keyword over here, but we're going to need a second case, case B. By the way, if you want to shift your code backwards, you can say Shift Tab to clean it up. And in the event that it's case B, we'll say you chose option B. And in the default case, we're just going to say, I should have something for it here. I guess I don't. Oh, there it is. If it's the default case, we'll say invalid option. So we can remove everything inside of part 1. We don't need a break keyword at the end of the default case. We should be fine there. We do need a break keyword at the end of case B. All right. So in the event that it's case A, we're going to say, what is your budget? Copy that over here. What is your budget? Then we need to check if their budget is greater than 10,000. And obviously we're going to have to pick up their budget using scanner.nextDouble. All right. And then we need to check if their budget is greater than 10,000. So we'll say if budget is greater than, and you know what? How about we say if budget is greater than or equal to 10,000? That makes more sense to me. I'll make sure to make the update inside of your starter code. Anyways, if the budget is greater than or equal to 10,000, then we'll be ready to sell them a car and run all of this code. Otherwise, if they don't meet the budget requirements, we'll tell them we're sorry, you're not eligible. So let's copy this over, delete everything. Inside the else block, we're going to say else. We're sorry, you're not eligible. And if their budget is greater than or equal to 10,000, we'll tell them, great, a Nissan Altima is available. Do you have insurance? Right, yes or no. All right, here we'll pick up their insurance. We'll pick up their license. We'll pick up their credit score. You can just put all of this right here. And in order to avoid the next line trap, remember when you have a next line that comes after a next double, next int, or next, the next line is going to get skipped. If you're not sure why, please revisit the next line trap video in the variables section. But in order to avoid the trap, you'll remember that the solution is to just put in a throwaway next line right before the real one that is going to pick up your value. All right, so after we pick up their insurance, their license, their credit score, we need to check if they have insurance, a license, and a credit score greater than 660. If that's the case, then we're going to sell them a car. So here we're going to say if insurance dot equals, spelled that wrong, if insurance dot equals yes, and license dot equals yes, and credit score is greater than 660, in that case, we're going to say sold. Pleasure doing business with you. Otherwise, there should be print statement for it. I guess there isn't. Otherwise, we'll just say, sorry, we cannot sell you a car. All right, now I'm debating whether I should debug the runtime now or just finish up case B and then debug all the runtime altogether. I think I'm just going to finish case B first so that we don't get distracted later on. Case B is pretty short, so bear with me. We'll just copy all of this over in case B. All right, we're almost done. So you chose option B. What is your car valued at? We pick up the value. It's an integer because I guess we're just getting an estimate. What is your selling price? They give us their price to the nearest 1,000. And then if the value is greater than the price and price is less than 30,000, we print the following message. So we'll say if value is greater than the price they give us and if the price is less than 30,000, then we'll buy their car with great pleasure. All right. Otherwise, we're just not interested. Now we can go ahead and debug the runtime. Let's just put one breakpoint over here and step through everything line by line. So here it tells me to choose an option. I'm going to choose, first I want to test what happens if I choose something like option C. So it's going to compare this option against 3 possible cases, case A, case B, and a default case. Rightfully so, it executes the default case. Beautiful, invalid option. So if we enter anything that isn't A or B, it's going to stop the application in its tracks. Now let's try case A. All right, it should run the following case. You chose option A, beautiful. What is your budget? We're going to enter a budget. You know what? Let's start by entering a budget that is less than 10,000 so that this runs. Remember, all of this is part of this if statement. And then you've got this else statement that would get executed otherwise. I'm just going to put this back using Shift Tab. That was just to show you. So what is your budget? We'll say 2,000. 2,000 is not greater than or equal to 10,000, so the else statement is going to run. We're sorry, you're not eligible. And then we're done with case A. Break keyword breaks the switch statement, and then scanner closes. All right, let's try this again. Going back here, we're going to buy a car. Okay. You chose option A. Cool. What is your budget? Now we're going to enter, I don't know, 20,000. Oh, forgot to press enter. Sorry about that. So 20,000 is clearly greater than 10,000. This should be true. They tell us a Nissan Altima is available. Do we have insurance? Remember, the throwaway next line gets wasted by empty space that was left over by next double. Then the real next line is ready to pick up some data. Do we have insurance? We're going to put yes. Beautiful. Do you have a license? Yes or no? We do have a license, otherwise we wouldn't be buying a car. What is your credit score? What does it need to be for us to qualify? It needs to be greater than 660. Whoops, that was an accident. We'll just say 900. Okay, this should be true. This should be true. This should be true as well. So the entire condition should evaluate to true, selling us a car. Okay, now what I want to do is get all the way here, but I want the else statement to get executed. So I'm going to restart the runtime. Remember, you should test every single possible scenario in your code. We'll once again go for A. What is your, speaking too soon. What is your budget? Again, 20,000. We'll keep going. We'll tell them that we don't have insurance. Do you have a license? We'll tell them that we do. What is your credit score? We'll keep it at 900. All right, now this is true, this is true as well, but this one is false because we're using the AND operator. One of them is false, so the entire condition is going to end up being false, telling us that, sorry, they cannot sell me a car. Beautiful. So everything is working as it should for case A. Case B should be a lot quicker. So let's go ahead and do that. Test case B. You chose option B. All right. What is your car valued at? We're going to say 25,000. How much do you want to sell it for? We'll say 20,000. Sorry, I'm getting ahead of myself here. Let me execute this. Execute that. So I just entered the 20,000 from before. Don't be confused. Price 20,000. The value is greater than the price. The price is less than 30,000, so they're going to buy my car. Beautiful. Now let's test the final scenario where we once again want to buy a car. We chose option B, I know. What is your car valued at? This time we're going to say 10,000. What is your selling price? We're going to say 12,000. And because the value is not greater than the price, this whole condition is going to end up evaluating to false, running the code inside of else. Sorry, we're not interested. Now I could debug the runtime one more time where this is true and this is false, but I think you get the point. We just built a really interactive application by implementing control flow into our code, by just adding another skill into our toolbox, which is to selectively execute code based on conditionals. We were able to create much more complex applications than we did in the last section. I hope you're proud of yourself for making it this far. We're going to be adding a lot more skills to our toolbox in the upcoming sections where we learn how to use functions, loops, and arrays, so I hope you're ready. But in the meantime, the next challenge is coming up. You're going to be, once again, using all of these skills again, so I wish you the best of luck. As you write more and more code inside main, you'll start to notice that it becomes increasingly cluttered and messy. And the more code that you write, the more unreadable that it becomes. That's why functions are so important. Instead of writing all of your code inside of a single code block, you can split it up into functions and call them as needed. In this lesson, you will learn to define functions and call them. Create a new folder, call it section 4. Launch the folder inside of VS Code by simply dragging it. So here we have code that sings the chorus to some Michael Jackson song, and we need to sing it 4 more times. So what you would do with your current knowledge is simply copy and paste this 4 more times. And then upon running this code, boom, we just sang the chorus the required number of times. But if you look at the code, this is very, very tedious. What if we had to sing the chorus 20 times? Are you going to have hundreds of lines of code? Of course not. There must be a more efficient way. So how do we perform the task of singing the chorus 5 times without actually copying and pasting the code 5 times? What you need to do is group this code into a function. So what I'm going to do is create a function whose name reflects the task that it performs. The function is going to sing a chorus, so I'm going to call it sing chorus. Notice how the function name is lower camel case. The first word starts with a lowercase letter, and every word that follows starts with an uppercase letter, just like how we would name variables. In any case, anyways, what follows the function name is brackets, because here is where you would define parameters. You will learn more about parameters in another video, and to the left of the function name is where you specify the return type. You haven't learned about return types yet, so for now, just say void. Void means our function won't return anything. It's only going to perform the task of singing a chorus, and then we can specify a level of access, which for now is always going to be public. Public means the function can be publicly accessed from any package or subfolder, but because we've only got one package with a single class in it, doesn't really matter what level of access you specify. For now, we're always going to make our functions public to keep things simple. And because we're going to be calling the function from main, which is static, we need to make our function static as well. Why do we need to make our function static, you might ask? Understanding how the static keyword works once again requires an understanding of object-oriented programming, which we're not going to cover until Module 2. So for now, just know that we need to make our function static in order to call it from our static main entry point. We follow our function signature up with curly brackets, which is where we're going to define the task that it performs. In this case, our function will perform the task of singing a chorus. All right. And how do we make sure that this function gets invoked 5 times? If you want to invoke a function, simply write the function name and click on the first option. Boom. Now we just called the sing chorus function. But we want sing chorus to be executed 5 times, so we'll copy and paste this 4 more times. All right, and now we can see this in action by visualizing the runtime step by step. So I'm going to put one breakpoint at line number 4, and that's all. Alright, and now what we could do is just step over line number 4. Boom. It calls the sing chorus function, which prints our chorus. I could step over line number 5. Once again, it calls the function and prints our chorus again. I can keep stepping over lines number 6, 7, and 8. And the end result is our function getting called 5 times, printing the chorus 5 times. Now this wasn't very interesting. What I want to do is press the restart button. And instead of just running the function all at once, what I want to do is step into it. So press step into. Alright, we've called our sing chorus function and now I've stepped inside of it. Do not press step into again because that's going to step inside the logic of print line, which we don't want to do. So once again, press the restart button and step inside of sing chorus as we call it. And once you step inside the function, only press step over at this point. We want to step over lines number 13, 14, 15, and 16. And as we do so, our function is performing the task of singing a chorus. Beautiful. I can step inside the function again because we are calling it in line number 5. As we call the function, it gets invoked. And the function once again sings the chorus. Here we're calling the function once again in line number 6. I'm going to step inside the function as it's being executed and step over every single line of code inside the function to see it sing the chorus in real time. I can do this 2 more times for my entertainment. And 1 last time. It's pretty cool how we can visualize our app running line by line. And so the take-home message from all of this is that this function is a grouping of code that performs a task, but it's also a reusable grouping of code. We can reuse it as many times as we need to. And now you'll notice that main is also a function. It has a very similar signature to our sing chorus function. Every function in Java has a specific task that it performs. While the sing chorus function performs the task of singing a chorus, the main function performs the task of running your application. The main function has a very specific signature that the JVM looks for when you run your app, and when it finds your main function, it executes it, just like here we're executing the sing chorus function. Pretty darn cool if you think about it. So to recap, you defined a function and called it. A function is a grouping of code that performs a task. You can reuse the function as many times as you need to. Most functions rely on parameters to perform their task. Functions with parameters expect to receive values. Functions without parameters do not expect to receive any values. In this lesson, you will create a function that defines parameters. First, create a new file named parameters.java and make sure the class has a main method. The area of a rectangle, as you know, is equal to length times width. You've been given 3 rectangles, and each rectangle has different dimensions. Our job is to calculate the area of each rectangle. How will we do this? Step 1 is to create a function that expects to receive a length and a width. Here I have a function called calculateArea. The function expects to receive 2 double values, a length and a width. A parameter stores a value that your function expects to receive. The function calculateArea defines 2 parameters, therefore it expects to receive 2 values. The next step is to call the function by passing in an equal number of values. In order to call the function calculateArea, you need to pass in 1 value for every parameter that it defines. A value that you pass into a function is known as an argument. The function calculateArea defines 2 double parameters. Each parameter expects to receive a double value. So in order to call the function, you need to pass in two double values. The actual values that we pass in are called arguments. In step 3, the function uses its parameters to perform a task. The function calculateArea uses its parameters to calculate an area. If we were to trace the runtime, first we're calling calculateArea. The values that we pass into the function are arguments. When the function gets invoked, the first parameter stores the first value that was passed in. The second parameter stores the second value that was passed in. The function uses the value inside each parameter to perform its task. It calculates an area and prints it. You might be wondering, why is this beneficial? Think about it. If you want to calculate the area for 3 different rectangles, I can just call this function 3 different times, each time passing in a different set of arguments. If I call the function and pass in these values, the first parameter stores the first value that was passed in, the second parameter stores the second value that was passed in, the function uses the value inside each parameter to calculate an area, and it follows that the function can calculate an area for any pair of values that get passed in. The function is completely reusable. Let's do this in code, starting with step 1, creating a function that expects to receive a length and a width. Alright, our function is going to be publicly accessible. It will be void, it's not going to return any values. We'll talk about return values in the next video. And we're going to call the function calculateArea. Our function calculateArea expects to receive 2 values, so we need to define 2 parameters, double length and double width. Think of a parameter as a variable that just stores whatever value gets passed into our function. So double length will store the first value that gets passed in, and double width will store the second value that gets passed in. Task 2 is to call the function by simply passing in 2 values. I'm going to call the function calculateArea, and the reason this is not auto-completing is you'll remember the function calculateArea needs to be static as well in order for it to be called from the static main function. Don't worry about what static does. We will talk more about static in Module 2, Object-Oriented Programming. For now, just know that we need to have it in order to call this function from main, and now I'm going to calculate the area for a rectangle with a length of 2.3 and a width of 3.6. The values that I'm passing in are called arguments. The variables that will end up storing these values are called parameters. It's really important that you make that distinction. In step number 3, the function is going to use its parameters to perform a task. So when this function is called, it's going to receive 2 values, where each value gets stored inside of a parameter, and now we can use the parameter values to calculate an area. Double area is equal to length times width. And after we calculate the area, we can print it. System.out.println. The area is equal to the area that we calculated, and we are done. And now instead of running our code the normal way, we will visualize the runtime as we've been doing in the workbook solutions. So I'm going to put a breakpoint here, and that's it. And now you'll remember that for this to work, for us to be able to visualize the runtime, you need to launch the exact folder that contains your Java file. In this case, section 4. And now we can press debug to visualize the runtime. And in order to step inside the function that I'm calling, I need to press the button step into. All right. So I'm calling the function calculateArea, passing in 2 values, passing in 2 arguments. The first parameter, length, stores the first value that was passed in. The second parameter stores the second value that gets passed in. So now length equals 2.3 and width equals 3.6. And to further prove to you that parameters are essentially just variables, press this button and you can visualize the length variable and the width variable. And now we can use the values inside of each parameter, the values inside of each variable, to calculate an area for a rectangle with a length of 2.3 and a width of 3.6. and the area for such a rectangle is 8.28. Once you reach this line, do not press step into, press continue to resume execution naturally, and the area for a rectangle with such dimensions is 8.28. What's beautiful about this is that the function is reusable. I can call it as many times as I want to calculate the area for any rectangle that I want. I can calculate the area for a rectangle with a length of 1.6 and a width of 2.4, for a length of 2.6 and a width of 4.2. It doesn't matter. I can reuse the function as many times as I want to, and this is a really, really powerful way of coding. All right, let us visualize the runtime once more. So here I'm calling the function calculate area in line number 3. I'm going to step inside the function that we're calling. The length parameter stores the first value that was passed in. The width parameter stores the second value that was passed in. I will keep stepping into the function. The area based on the values that were passed in is equal to 8.28. And now do not make the mistake of pressing step into, because then it's going to step into the print line function, which we don't want to do. Press step over to run this line, and the area is 8.28. And now if I want to continue to the next breakpoint, I can press the continue button. All right. Now I'm calling the function again, passing in a value of 1.6 and another argument that equals 2.4, stepping into the function that we're calling. The first parameter stores the first value that was passed in. The second parameter stores the second value that was passed in. And now we're calculating an area based on the parameter values. If I keep stepping into, area equals 3.84. Don't make the mistake of pressing step in, because then it's going to step into the print line function, which we don't want to do. We will step over this line, and it prints area is equal to 3.84. Continuing to the next breakpoint, stepping into the function again, the length parameter equals 2.6, the width parameter equals 4.2. We calculate an area based on these parameter values, and then we can print the area, 10.92. And now if I press continue, because there are no other breakpoints that come after, the runtime will just terminate. Beautiful. So to recap, a parameter stores a value that your function expects to receive. When a function defines parameters, then in order to call it, you need to pass in a matching number of arguments. Based on the position of the parameter, it's going to store the value that gets passed in, and then we can use these values to perform our task. You can return values from a function. It's bad practice for your function to handle the final results, but it's good practice for your function to return the final result. Your function is going to return the area. Start by creating a new file called returnvalues.java and make sure that the class has a main method. First thing we'll do is just copy all the code from earlier into returnvalues.java. We currently have a problem in that our function here is performing two tasks. It performs the task of calculating an area, and it also performs another task of printing that same area. At this point, we might as well call the function calculate area and print it. Obviously, we're not going to do that. It is bad practice for your function to handle the final result. It should return the final result. So in step 1, your function must define a return type. The return type specifies what type of value that your function will return. We expect to return a double, so the function's return type is going to be double. In step 2, your function needs to return a value. The function calculateArea returns the final result, the area that it calculates. And the value that you return must always match the return type. The return type is double, so the value that the function returns needs to be a double. The function call retains, it holds on to the return value. First, we're calling calculateArea. When the function gets invoked, the first parameter stores the first value that was passed in. The second parameter stores the second value that was passed in. The function uses the value inside of each parameter to perform its task. It calculates an area and then it returns it. The function call retains, it holds on to the value that was returned, and we can store the return value in a variable. If you want to store the area for 3 different rectangles, I can just call this function 3 times, each time passing in a different set of arguments. If I call the function and pass in these values, the first parameter stores the first value that was passed in, the second parameter stores the second value that was passed in, the function uses the value inside of each parameter to calculate an area, the function returns the final result, the function call holds on to the return value, which we can store inside of a variable. Every time I call the function, I can store the final result that it produces inside of a variable. Let's do this in code, starting with step 1, in that your function must define a return type. The return type specifies what type of value this function will return. We expect to return a double, so the function's return type will be double. Step 2 is for your function to return a value. Your function should not be the one to handle the final result, so we're going to delete this print statement, and instead what this function will do is return the final result, the area that it calculates. And the value that you return must always match the return type. The return type is a double, so the value that the function returns needs to be a double as well, and our area variable is a double. In step number 3, the function call retains, it holds on to the return value. And the only way to confirm this is by visualizing the runtime, so let's put 3 breakpoints over here and press the debug button. Let's step inside of calculateArea. The length that was passed in is 2.3, the width that was passed in is 3.6. As a result, we produce an area that equals 8.28. If I step over, and here we can see that our function call holds on to the value 8.28, and then we can store the double that it retains inside of a variable. So if we continue to the next breakpoint, now we're calling calculateArea again, this time passing in arguments of 1.6 and 2.4. Each parameter stores a value that was passed in, so length stores 1.6, width stores 2.4, and now we're using these values to calculate an area, and here we're returning the area that the function produced. Upon doing so, this function call holds on to the return value of 3.84, which we can then store in a double variable. So let's do that right now. I'm going to stop the runtime. As we hover over calculateArea, it tells you that it returns a double, which we can then store in a double variable. Double area1. Do the same thing throughout. Alright, revisualizing the runtime. Here we're calling calculateArea, passing in values of 2.3 and 3.6 Stepping inside the function, we calculate an area based on the values that were passed in. Stepping inside even more, here we're returning the area that was produced by our calculate area function. Stepping over, the function call calculate area holds on to the return value of 8.28, and then we're storing that return value inside of double area 1. Continuing to the next breakpoint, now area 1 equals 8.28, and every time we call this function, the final result that the function produces gets stored in a variable. So area 2 equals 3.84, and area 3 is going to equal 10.92, and now by pressing continue, since there are no other breakpoints, the runtime finishes. So you learned how to return a value from a function. When you call a function, it's going to use the value inside of each parameter to calculate an area. The function returns the final result. The function call holds on to the return value, which we can then store inside of a variable. Every time I call the function, I can store the final result in a variable. As mentioned before, you can return values from a function. It is bad practice for your function to handle the final result, but it is good practice for your function to return the final result. So in this lesson, you will create a function that returns a string. Start by copying and pasting the following text underneath your return values class. Highlight it. If you're using a Mac, press Command/. If you're using Windows, press Control/ to comment out the text. And now we can begin. Alright, we will use the same function signature as before, but this time our function will be returning a string. So we specify a return type of string, and the function name will be explain area. The function expects to receive a language value when called, so we define one language parameter of type string. Alright. You'll notice right away that we get an error. The error is that the method must return a result of type string, but right now our method is not returning anything. So in order to adhere to the return type, we need to return a string value. So we will return hello. And now, whenever we call the function, it's going to return a string of hello, but that's not what we want to do. What we want is to compare the language that gets passed in against 3 possible cases. So the first case is if the language that was passed in is English, in which case we can return area equals length times width. If the language that they pass in equals French, then we can return the following. If it's Spanish, then we can return the Spanish text. You'll notice that this time we don't need to put the break keyword. Why do you think that is? To put it simply, while break would only break the switch statement, return would break the entire function when invoked. So you do not need to put break after returning a value. It's going to return the corresponding value and immediately break the entire function. Alright, but now you'll notice we still have an error here that says this method must return a result of type string. That is really weird. If the case is English, we're returning English text. If the case is French, we're returning French text. And if the case is Spanish, we're returning Spanish text. But the function needs to return a string no matter what, otherwise it's going to throw an error. So we did not account for the scenario where a user might say case Italian. If they put case Italian, none of these cases are going to get executed and the function is not going to return anything, but it needs to return a string no matter what. So what we have to do is say default. Default accounts for every other scenario that doesn't match these three. In that case, we can return language not available. So whenever you specify a return type, you need to make sure that something gets returned no matter what gets passed in. Here we have a return type of double. This function is always going to return a double no matter what. Here we have a return type of string. The function is always going to return a string no matter what the scenario may be. Now the error is gone, which means we can start playing around. So here I'm going to say string English explanation is equal to whatever the explain area function returns when we pass in a language of English. And we will copy this 4 more times. String French explanation will equal whatever explain area returns when we pass in a language of French. String Spanish explanation will equal whatever explain area returns when we pass in a language of Spanish. And string Italian explanation will equal whatever the explain area function returns when we pass in a language of Italian. And now what we're going to do is visualize the runtime, but starting from line number 7. So put breakpoints here. Make sure that you have launched the exact folder that contains your Java file. Otherwise, visualizing the runtime might not work for you. And now we can go ahead and press the familiar debug button. So all of this code ran naturally because we didn't have any breakpoints here. And you can see that each area variable stores a different value depending on what was passed in its respective function call. And now we move on to line number 7. Here we're calling explain area, passing in a value of English. Once you press step inside, now we can keep pressing step over. In fact, I recommend you do so, otherwise you're going to be taken to the string class and we don't want to deal with that. In fact, take it as a rule of thumb, once you already step inside the function, then you can just keep pressing step over. So we're going to press step over and the matching case is English. Return, what it's going to do is it's going to return this string, and as soon as it does that, it's immediately going to break the entire function. The explain area function call retains the value that was returned, and here we're setting the English explanation variable equal to that return value. Moving to the next breakpoint. Here we're calling the explain area function again, this time passing in a value of French. The parameter stores the value that was passed in, and here we can compare that value against 3 possible cases. The case match is case French. As soon as the return keyword gets invoked, it's going to return the following string, and as soon as it does return the string, return is always the last thing that ever runs in a function, so it's automatically going to break the entire function. The explain area function call retains, it holds on to the value that was returned, which we're then storing in a string variable French explanation. Alright, now we have 2 variables, each one equaling a different explanation depending on what was returned by the function when it was called. And now we can just press continue. The Spanish explanation equals the Spanish explanation that was returned by the function. And Italian explanation is going to equal, I should have pressed step over instead of continue, because then it just continued to the next breakpoint. There was no breakpoint and it just terminated the runtime. So let me re-visualize the runtime, only putting a breakpoint at line number 10. I'm going to step over this line instead of continuing execution. The Italian explanation variable equals whatever was returned by the function when it was called. We can assume the default case was the one that executed, returned a value of language not available. The function call held on to the return value, which was then stored in a variable called string Italian explanation. All right. We just created another function, but this one returns a string and this one returns a double. But I find this function much more interesting because we've got some conditional logic going on in here. Let us apply some conditional logic in here as well. So in real life, you would never have a negative length or a negative width. So what we can say is if length is smaller than 0, Or if the width is smaller than 0, then clearly the values that they passed in are invalid. So we're just going to say system.out.println invalid dimensions, and then we can say system.exit 0. So if one of the values that gets passed in is negative, then we're going to print out a message telling whoever called the function that they messed up, and we're going to terminate the runtime. So we will call the function again, this time passing in a value of -5 and a width of, you know what, we will keep the width valid. All right, let us just put a breakpoint over here, debugging the runtime, stepping inside of calculate area. So this if statement will only execute if the length is smaller than 0 or if the width is smaller than 0. The length is -5, which means this is going to evaluate to true. Because one of the comparisons is true, this entire condition is going to become true courtesy of the OR operator, which means it's going to print invalid dimensions and it's going to terminate the runtime. All right, that is all. You created functions that return values. In order to do a final recap, let us visualize the runtime everywhere. So first we're calling the function calculate area, passing in 2 values. The parameter length stores the first value that was passed in. The parameter width stores the second value that was passed in. Here we're checking if one of these values is less than 0, but because none of these are 0, both of these are going to evaluate to false, which means the entire condition is false, so this will get skipped. Here it calculates an area that equals 8.28. Here we are returning the area. The function call holds on to the area value that was returned, which we're then storing in a variable called area1. Here we can just continue to the next breakpoint. Area 2 equals 3.84. Area 3 equals the value that was produced by the calculate area function when we passed in these values. And now here, if we step inside, unfortunately the length equals -5, which means this will evaluate to true, meaning the entire condition is going to become true courtesy of the OR operator. It's therefore going to print invalid dimensions, and our application will terminate right here and now. But if we were to comment this out, revisualize the runtime, continue, each area stores a value that was produced by the calculate area function depending on what was passed in. And here we can press continue, stepping over the final line. And here every string variable equals a string that was returned by the explain area function depending on which value was passed in. Alright, that is all we're going to cover for return values. I really hope you've been enjoying these breakpoint sessions. Alright, let us just jump right into it. So here we've got 2 functions. This one returns a double when called. This one returns a string when called, but for the sake of variety, let us add another function. But this one, unlike these two, is not going to return a value. You guessed it, it's going to be void. And this void function is going to be called print area. And this function is not only going to print the area, but the length and width that were used to produce that area. So it's going to need to define 3 parameters, double length, double width, and double area. And you might be wondering, why is this function void and why are these returning values? I will get to that in just a second, but just bear with me. Here we're just going to print a rectangle with a length of length and a width of width has an area of whatever area that gets passed in. Okay. So why is this void and why is this returning a value and why is this returning a value? Well, as I mentioned before, A function should only be performing a single task. This one performs the task of calculating an area. The function is already performing a computation. It should not be the one to also handle the final result of that computation. It should return the final result and let whoever is calling the function to deal with that result as they see fit. The explain area function is performing one task. It takes in a language, and based on the provided language, it compares it against 3 possible cases, and it explains the area in their preferred language. This is a form of computation. The function is already doing so much work, so it should not be the one to handle the final result. It should simply return the result of that computation. Whenever a function is performing a calculation or a computation of some sort, it should not handle the final result. It should just return the result and let whoever is calling the function to deal with that result as they see fit. But the function print area, its only task is to print the area. It's not performing any calculations, it's not performing any computations, so we cannot expect it to return any values. That's why it remains void. Void means the function does not return a value. When called, it's simply going to print a message depending on what gets passed in. So what we're going to do is we're going to keep this simple. We're only going to call explain area once. We're only going to call calculate area once. When we calculate an area for the following length and width, we're going to print that area using the print area function. The first value that we pass in is the length. The second value that we pass in is the width. And the third value that we pass in is the area that was produced from the length and the width. And here we're just going to print the English explanation normally. Alright, putting breakpoints here, here, and here, revisualizing the runtime. So when you calculate an area for a length of 2.3 and a width of 3.6, you get a value of 8.28, and inside of the print area function, we're simply printing that a rectangle with a length of 2.3 and a width of 3.6 has an area of 8.28. If I just simply continue to the next breakpoint, we're going to see that in our terminal. String English explanation is going to equal whatever the explain area function computes based on the language that was passed in. So the language that was passed in is English. We expect the explain area function to return the following text. That's exactly what it does. The English explanation variable stores whatever the explain area function returns when we pass in a value of English, and here we're just printing it. Alright, the point I wanted to drive home was that when your function isn't performing any sort of computation or calculation, if it doesn't need to return anything of significance, then it needs to be void. Void means the function doesn't return anything when it performs its task. So when you're just printing something, there's really nothing to return. But when your function is performing some sort of calculation, some sort of computation that is needed to produce a final value, then you need to return that value from the function, and then let whoever is calling the function to handle that value as they see fit. Doc comments can be used to describe what a function does. In the past 3 workbooks, I left you doc comments to guide your code. And this one is from Workbook 4.3. Notice how easy it is to read because very succinctly it tells you exactly what the function does, what the parameters are, and what the function returns. If you're working in a team of developers, you should have a doc comment for every function. It helps collaborators understand what your function does without having to read your code. So in this lesson, you're going to learn how to write doc comments. First thing I'll need you to do is create a new class by yourself inside the section for project. Create a new file named .comments.java and make sure the class has a main method. So we're going to start off by writing a function. Inside .comments, we're going to write a random function that's void. I'm going to call it greet. And it's just going to print hi. And just before the function, I'm going to write /** and press enter a few times. And Java creates a skeleton for us to write a .comment. Next to the first star, I'm going to write function name, which is greet. And beside the last star, I'm going to write inside the function followed by a bullet point that describes what it does, and it prints hi. And there you go. This .comment effectively describes what our function does. Now we're going to write a function with parameters. Public static. It's going to be void, and I'm going to call it print text. And it's going to receive two string parameters, name and age. And inside the function, I'm going to print hi. I'm whatever name value is passed in. And whatever age value is passed in. Years old. And now once again, before the function, I'm going to write /**. Press enter a few times and check it out. It recognizes the two parameters in my function. And now this is just a preference, but in brackets, I'm going to add the data type of each parameter. So the name parameter is of type string, and the age parameter is of type string as well. Good. Now, like before, write the function name beside the first star. And describe the function beside the last star. So we'll say inside the function, colon. I'm going to add a bullet point that says this function prints the name and age as part of a text. Now we're going to write a function with a return value and document it. I'm going to make a function that returns a double. I'm going to call it calculate area. And it's going to receive two parameters, length and width. And inside the function, I'm going to calculate the area of a rectangle by multiplying the length and width values that are passed in. And then I'm going to return the area value. And once again, right before the function, I'm going to write /**. Press enter a few times and check it out. This time it recognizes the parameters and that you have a return value. And you know me, I like to add the data type of each thing in brackets. The parameters are all of type double, and the return value is a double as well. As always, I'm going to add the function name. And next to the last star, I'm going to describe the function by saying, inside the function, and then I'll add a bullet point that says this function calculates the area and returns it. That's all. It's pretty easy, isn't it? All you have to do is press /** a few times and Java creates a skeleton that we can use to fill out and document our function. In this lesson, you learned to describe functions using Java docs. When you write /** followed by enter, Java generates the format and all you have to do is write the function name, give a small description, and if you want to get super fancy, write the type of each thing in brackets. The scope of a variable determines its lifespan. And then we can start. Okay, so before we look into our code, here we have a variable called area defined inside the scope of a function. The moment you call this function, it creates the variable, and the moment your function stops running, it destroys the variable. It does not exist in memory anymore. It's gone. And I often see students try to access a variable outside the scope that it was defined in. At this point, area doesn't exist anymore, so Java has no idea what you're talking about. The take-home message is you can never access a variable outside the scope that it was defined in. Think of the curly brackets as a boundary, and your variable cannot cross that boundary. I'm going to start by putting a breakpoint at line number 12 and pressing debug. So here we're calling the function calculateArea, passing in two values, 2 and 4. The moment that I execute line number 19, it's going to create a variable called area. You'll notice here that it says local. The variable area and the parameters are local to the calculateArea function. The moment that I stop running this function, the moment that it's done, all of these variables were just destroyed. They do not exist in memory anymore. They are gone. We will do the same thing here. Step inside of calculate parameter. Param1 and param2 are local to this function. And if I execute line number 25, parameter gets created, and the moment that the function is done running, it's going to destroy all of these variables. They are not going to exist anymore. So, what if I try to access parameter outside the scope that it was defined in? What if I try to access parameter right here and set it equal to something like 10? Java has no idea what I'm talking about. Parameter does not exist outside the scope that it was defined in. Again, think of these curly brackets as boundaries, and your variable cannot cross, it cannot exist outside of this boundary. Neither can these parameters. Alright, now let's talk about global scope. This variable, instead of being local to just one function, it's defined at the level of the entire class. So you can access it anywhere. I can access the variable here, I can also access it here and here as well. Again, think of the curly brackets as a boundary. These curly brackets span the entire application which means this variable can go wherever it wants, really. This variable is globally scoped. It exists across the entire app, and it will never die as long as the application is running. So here, what I'm going to do, this is very bad practice, but instead of passing in these values as parameters, I'm going to remove all of the parameters. Remove all of the parameters here as well. Remove these variables. Because these aren't accepting parameters anymore, we don't need these anymore. And now I'm going to define two global variables. And now you'll remember that because the main function is static, we need to make every other function that we're calling from it static as well, while the same thing goes for variables. Here, let's just say I want to print length. If I remove the static keyword, it will not work because you cannot access a quote-unquote instance variable from a static context. Again, you'll learn more about the static keyword in Module 2. Covering it now would not make any sense. All right, let's print the width as well. Put in a new line. And so here, all I'm really trying to demonstrate is that because these are globally scoped, we can access them from anywhere within this entire boundary. I can access length and width here as well. I can print the area of both of these values. Both these values as well. So here I left you some comments. You'll notice this is a local variable, and these are global variables. They are global to the entire app. Let's go ahead and re-debug the runtime. And you'll notice that the global variables don't really show up in our debugger. That's because our debugger is only showing us variables that are local to the function itself. The only variable that's local to the main function is args. That's why you're seeing it right here, the parameter args. Stepping inside of calculate area, the only variable that is local to calculate area is area itself. Here we determine that the area of length times width, the global variables is 8. Running that. Going inside of perimeter, the only variable that's going to be local to this function is the one that we just created. 2 times 2 plus 4 is 12. All right. And now the moment that this function is done running, it's going to destroy any variables inside of it. And we're done. Now I actually recommend against using global variables. You should keep everything local and use parameters, because when you have too many global variables, you start losing track of what's really going on. You make yourself prone to a lot of bugs. But for the sake of this lesson, I want to emphasize that when you're coding in Java, think of the brackets as a boundary. These curly brackets span the entire application, so your variables which were defined at that level can be accessed everywhere. They are global to the entire app. These brackets define the scope of a function. This variable is local to its function and can only be accessed within this boundary. The Java Development Kit provides so many built-in functions that you can just call out of the box. From a string, you can call .length and it returns the length of a string. From a string as well, you can call .toUpperCase and it returns the same string but in uppercase. You can call math functions. This one expects a number and returns the square root. This one expects a number and returns the absolute value. This one expects two numbers and returns the maximum between them. And this one returns the lowercase form of a string. So many useful functions that you automatically have at your disposal by virtue of just installing Java. And you might be thinking, oh, I need to memorize all of them. Never ever try to memorize code. Ever. Every single function that you see in this video is documented online, and there are millions of them. That being said, a good developer never memorizes code. A good developer knows how to read documentation and find resources. And in this lesson, that's exactly what we're going to do. So in scenario 1, we need to find a built-in function that prints a message to the console, and the function is going to expect a parameter of type string. I know what you're thinking, println. Println is actually a function that we can access from system.out. Here you can see that println expects a parameter of type string, and the argument we're going to pass in is the following. We're going to debug the runtime shortly. Here we need to find a built-in function that returns the length of a string. All right. So if I were to look online and say string functions Java, and I'm going to say Oracle so that we can go to the Oracle documentation, and I'm going to say Java 17. Now, by the way, if you were to just copy and paste this onto Google, it would give you the answer right away, but I want you to get used to reading documentation. So here are all of the built-in functions that we can call on strings. We want a function that returns the length of a string. So what we'll do is look for something like length. So I'm going to press Command F or Control F if you're using a Windows computer. Look for length. Use that as a keyword. I don't see anything here, nothing here, nothing here. And here you can see we have a function called length that returns the length of a string. I'm going to click on the following link. It's going to take me to its description. This is a function that returns the length of a string as an integer. So if you want, you can say int length is equal to example.length. If you want, you can also hover over the length function, and it tells you that it is a function that returns an integer, and that integer is the length that we're going to end up storing in this variable, which I'm then going to print. Now I could have just printed the return value directly, but for the sake of example, let's do it like this. Scenario 3, find a built-in function that converts a string to lowercase. So this does not expect any parameters, but it does return a string. So let's type in our keyword. Let's say lowercase. Okay, nothing so far. To lowercase. It converts all the characters in the string to lowercase, and you can see that it returns a string. So what we can do is say string, I'm going to call it lowercase, and it's going to equal the return value from calling to lowercase on our string value. Then we can go ahead and print the result that was returned. Okay, here it tells me to find a built-in function that checks if a string starts with a specific prefix. So I can go back here and type prefix. Beautiful. I can click on starts with to get an official description. So this function expects a parameter, the prefix that you're looking for, and it's going to return a Boolean that describes the result of the operation. True if the character sequence represented by the argument is a prefix, and false otherwise. Right now, you are reading documentation that describes how a built-in function works, and I hope you're really proud of yourself because this is how seasoned developers research code. All right, so we can go back here and say Boolean, because we know the function is going to return a Boolean, does start with prefix. A little verbose, but you know what? For the sake of example, we'll go for it. Is equal to the variable itself, dot, starts with, and we're going to check if it starts with the characters Java. And here we're just going to print the result of the operation. Does it start with the prefix? And here we'll just say, or we'll just print the result of the operation. Cool. Now we got to find a built-in function that replaces all occurrences of a specified character in a string with another character. So the function that we're looking for is going to require two parameters and return a string. Both of the parameters that it requires are going to be characters. Let's look for the keyword occurrences. Maybe that'll help us find it in the Java docs. Boom, we have a function called replace that expects two parameters of type char and returns a string. It returns a string resulting from replacing all occurrences of old char in the string with new char. Okay, so what we'll do is we know the return value is going to be a string, so we'll say updated string is equal to original dot replace, and we're going to replace everywhere it says A with an O. And now we can go ahead and print the updated string. Notice how I'm not memorizing anything. I've got my description and I'm looking up the Java docs based on the description, based on what I intend to achieve. Now we need to find a built-in function that calculates the square root of a number. So I could just copy and paste this onto Google. And, well, I should specify Java. And all of these links will give you an answer. But I really want you to get used to reading documentation. So what I'll do is I'm just going to say math functions Java Oracle 17. We're going to be checking the Oracle documentation for Java 17. And you know what? Java 18 will do just fine. So the keyword that I'm going to be looking for is square root. Let's go ahead and say square root. And here we have a function called sqrt, which expects a double parameter and returns a double value. Cool. So what I'll do is I'll say double square is equal to math. So how do I know that our function is accessible from math? If you go up there, it tells you that math is a class that contains all methods for performing basic numeric operations, and all of these methods are inside the math class. The math class is publicly accessible, and we can say math.square root. The square root I want to take is of the following number. Okay, so if you want to know where you can access your built-in function from, just look on top, the math class. Okay, I'll drill into the math class later just to show you what it looks like. Here we need to find a built-in function that calculates the power of a number, takes two parameters and returns a double. Let's just look for a power. Okay, there you go. Math.pow. You can go ahead and read this entire description. It's very comprehensive, but pretty much your first value is the base and the second value is the exponent. So this returns a to the b. We want to do system.out math.pow 2 to the power of 3. You know what? Let's use the variables. They were declared for a reason. Base to the exponent. And let's not forget to print what we have over here. Okay. Now we need to find a built-in function that generates a random number between 0 and 1. This seems like, once again, a math function, so we'll go here and type random as a keyword, and there's a random function that we can call. It returns a double value greater than or equal to 0, but less than 1, so 0.99999 or something. So here we'll go back, and we'll say double random decimal is equal to math.random. So as you can see, math.random, it only returns a double as was required, but it doesn't actually accept any parameters because, well, why would it? We'll go ahead and print it. And this should be our last scenario. Find a built-in function that returns the larger of two numbers. The keyword I'm going to look for is max. Nothing here. Math.max. It returns the greater of two integer values. So it accepts two parameters and it returns the larger of A and B. So we're going to say int larger number is equal to math.max number 1 and number 2. Printing larger number, and we should be good. Now we can go ahead and debug our code line by line. So I'll put a breakpoint here, 11, put a breakpoint at line 23, line 35, 48. Basically, I only care about the built-in functions, nothing else. 92, 104. Okay. We'll step over line number 11. And print line is also a built-in function that we've been using all throughout this course. If I step inside of this function, you'll see that print line is a void function that expects a parameter of type string. It's like any other function we've been defining inside of this course. And then here it performs the magical task of writing our string value to the console. Beautiful. So now what I'm going to do is press continue so that we can just go right to the next breakpoint. I don't want to go through all this. All right. So now I'm going to go inside of the length function. Length simply returns the length of your value. In this case, it's going to return the number 4, which we eventually print. Okay. ToLowerCase is a function that expects no parameters and returns a string. We can step inside of it. No parameters returns a string. Beautiful. Which we then print. All right. This is going to check if word starts with the characters Java. It returns a Boolean. Indeed, it does. And this is going to replace all occurrences of A with the letter O, and it's going to return that value, which we then store in this variable. We could step inside of it just to look into the function itself. You can see it expects two characters, which we passed in as arguments, and returns a string. We are storing that string inside of updated string. Now it says Jovo is fun. That's quite humorous. And now square roots expect us to pass in a number, and it's going to return the square root as a double, which we are storing here. Now, if you right click on math and go to type definition, this is the math class that contains all of the different math functions that we can call, tan, cos, whatever. All of these functions are documented here. And if you read the doc comments, you can also see their description over here as well. Do not memorize any of them. This is the square root function that we're calling that expects a double and returns a double. Pretty cool that we have access to all this info. So we can go ahead, take the square root. The square root of 9 is 3. Perfect. And now here, math.power takes in 2 arguments, and it's going to return a double result. 2 to the power of 3 is 8. Cool. Math.random generates a random number between 0 and less than 1. In this case, it generates 0.74. We're going to be using the math.random function very often in the next few videos. And now here, math.max is going to return the maximum of 2 integers. All right, 10 is obviously greater than 5, and that is all. And so to recap this lesson, I just want to say never ever memorize code. Get used to looking online to read documentation and find resources. That's what every great developer does. There are millions of built-in functions, and memorizing all of them is impossible. This project is going to test everything that you learned so far. At this point, you know how to organize your code into functions, define functions that take parameters, call functions and pass in arguments, and return values from your function. The DICE project is going to cover all of these concepts, but there is a twist. Like every project, you're going to add interactivity to your application using Scanner. So let's get right into it. First thing I'll need you to do is create a new class by yourself inside the section 4 project. Create a new file named DiceJack, and in the DiceJack class, create the main method. Now, DiceJack is a simple game. The user can pick 3 numbers. For example, I could pick the numbers 4, 3, and 5. And if you add them up, the sum is 12. Then they need to roll the dice 3 times. Let's assume they roll 3, 4, and 4. The sum of those numbers is 11. Now, I would win the game if the sum of my dice rolls is smaller than the sum of numbers that I choose. And if the difference between the 2 numbers is less than 3, in this case I would win because the sum of my dice rolls is smaller than the sum of my numbers. And the difference between the 2 numbers is less than 3. So we're going to write code that performs 2 tasks. The first task is to roll the dice, and the second task is to check if the user won. 2 tasks imply 2 functions, so let's get started. Now honestly, most of these tasks sound really easy. It's nothing we haven't done before, but this one is going to require some strategizing. Java provides a math function called math.random. Math.random returns a decimal between 0 and less than 1, so 0.99999. The lowest extreme is 0. The maximum value it can return is 0.9999, less than 1 but extremely close. Those are the 2 extremes. Math.random will return a value between this range. Whenever you call math.random, the decimal that it returns is bound between 0 and 0.99. But what can we do in order to return a decimal between 0 and less than 6? Pause the video and really think about your answer. The correct answer is multiply its result by 6. Think about it. The minimum value is 0. 0 times 6 is still 0. The maximum value that can be returned is less than 1. 0.999 multiplied by 6 is 5.999, less than 6. Now the range becomes 0 to less than 6. These are the 2 extremes. Our code will always return a decimal that is bound between 0 and less than 6. Alright, now what can we do to ensure that our current code returns a decimal between 1 and less than 7? Pause the video and think about your answer. The correct answer is to add 1. The minimum value from our current code is 0, and then 0 plus 1 equals 1. The maximum value that our code can currently return is less than 6, 5.999. That plus 1 is going to equal 6.999. Now the range becomes 1 to less than 7. Those are the 2 extremes, and our code will always return a decimal that is bound between 1 and less than 7. Now here comes the cherry on top. The minimum value that our current code returns is 1. If we typecast the minimum to an integer, it's still 1. The maximum value that our current code can return is 6.99999, And if we typecast the maximum to an integer, we just cut off all the decimals, and the maximum value that our code can produce is 6. So now the range becomes 1 to 6, those are the two extremes. Our updated code will always return a whole number that is bound between 1 and 6. And just like that, we have code that can be used to roll dice. Alright, it is now time to code everything up. Alright, let's begin. Our function is going to perform one task, which is rolling dice. So we expect it to return an integer that represents the dice that was rolled. Of course, it's going to be called roll dice, and the roll dice function is not going to need any parameters to perform its task because everything will be random. Here we can say double random number is equal to math.random times 6. So math.random, what it's going to do is return a decimal that is greater than or equal to 0 and less than 1. So it's going to return a decimal that is bound between 0 and 0.9999999. And whatever decimal that it ends up returning, once you multiply that by 6, then that decimal is going to be bound between 0 and less than 6, 5.999. Alright. And now here we can say random number plus equals 1. So whatever decimal gets returned from this line, if we were to add 1, then that number can be anything from 1 to less than 7. And if we were to return the typecasted result, return whatever the random number is but converted to an integer, then that number can be anything between 1 to 6. And the result that gets returned will always be a whole number that is bound between 1 and 6. Now we can test it out by calling the function 3 different times and setting up some breakpoints. So roll dice, roll dice, roll dice. Int roll1 is equal to roll dice. We'll call this a roll2, and we'll call this a roll3. And we're just going to print each roll. All right. Print the third dice roll. Let us visualize the runtime. I will step inside of roll dice. So the result here is always going to be bound between 0 and less than 6. In this case, we'll step over this line. What gets returned is 1.93. And the result here is always going to be bound between 1 and less than 7. In this case, whatever we got from the first line plus 1 ends up being 2.9. Typecasting this to an integer, we get a dice roll of 2, and that return value gets stored in the variable roll1. Continuing to the next breakpoint, here we roll the dice a second time. The result here is always going to be a decimal that is bound between 0 and less than 6. In this case, we get a random number of 0.28. The result here will always be a decimal that is bound between 1 and less than 7. In this case, whatever we got in line number 15 plus 1 is 1.28. The result here will always be a whole number between 1 and 6 because all we're doing is cutting off the decimals, and we get a dice roll of 1. And here we're storing the return value inside of a variable called roll2. So now we've got 2 dice rolls. Here we're rolling the dice for a third time, stepping inside the function. The result here will always be a decimal that is bound between 0 and less than 6. In this case, we get 2.30. The result here will always be a decimal that is bound between 1 and less than 7. In this case, whatever we got in line number 15 plus 1, and after typecasting whatever we get from line 16, the result here is always going to be a whole number between 1 and 6. In this case, we're going to get a dice roll of 3. And then we store that return value in a variable called roll3. And then you know what? Let's just let execution resume. We'll press continue, and then it's going to print all of our dice rolls, 2, 1, and 3. So now what I'll actually do is I'll say javac dicejack.java, java dicejack, and I'm just going to keep running this code so I can get a variety of dice rolls. Notice that I keep getting values between 1 and 6. So if you really want to test out your code, keep running it and make sure that your minimum is 1 and that your maximum is 6. Welcome back. Let's go ahead and wrap up our game. The first thing I'm going to do, is ask the user to enter 3 numbers between 1 and 6. Enter 3 numbers between 1 and 6. And you know what? Instead of print line, which prints our message and moves to a new line, let's use print, which is simply going to print our message. Make sure to leave a colon and some empty space so that the user has room to enter 3 integers. And before we can do any of that, let's initialize an instance of scanner, new scanner system.in. Okay, and now what I'm going to do is say int number 1 is equal to scanner.nextInt. By the way, nextInt is a built-in Java function because it is a function that you just automatically have available to you, courtesy of the Java Development Kit. The nextInt function, as you can see, it receives no parameters and it returns an integer result, which we are then storing inside of a variable. So pretty much everything that you're calling is a function, whether it's a function that you're defining yourself or a function that lives in the hidden world of Java. You can probably right click and say go to definition, and you'll see that it is indeed just a function, no parameters, and a return value. Okay, let's not dwell on that too much. Number 2 is equal to scanner.nextInt. Int number 3 is equal to scanner.nextInt. All right. We need to implement some safeguards. We need to make sure that the numbers they input are actually between 1 and 6. And I don't want to clutter the main function with any more logic. I want to write functions where each function performs a specific task. That's going to look a lot cleaner. So the first function I'm going to implement is public static. It's going to return a Boolean, and it's going to be called r less than 1 because this function will perform the specific task of checking if any of the dice rolls are less than 1. So it's going to not the dice rolls, if any of the numbers that they input are less than 1. So it's going to receive 3 numbers, int number 1, int number 2, and int number 3. And it's going to return the Boolean result of comparing number 1 against a particular threshold. We want to make sure that none of the numbers are less than 1. And so because we're using the OR operator, if any of these numbers are less than 1, then this whole comparison is going to return true, telling us that they inputted a bad value, or at least one bad value for that matter, which means we cannot allow them to proceed. We'll get to that in a bit, but we need another function that checks if any of the numbers are higher than 6. We cannot allow them to exceed that magnitude as well. So we're going to return the Boolean result of checking each number against a particular threshold. If any of the numbers are greater than 6, we want to return true. We want an indicator that tells us if the user isn't following the rules. Okay, And now before we start using these functions to achieve our desired output, what I want to just do is visualize the runtime. So I'm going to say Boolean first result is equal to r less than 1. So we're going to check, or we're going to start by testing our functions. Boolean second result is equal to r higher than 6. Okay, I'm going to put a breakpoint at line number 16. And let's say scanner, we don't need these anymore. Let's say scanner.close so that we can satisfy this warning. Okay, press debug. So here I simply have to input 3 integers. Let's say if I follow the rules 4, 5, and 6, both of these should return false. We can step inside of them if you want. I'll step inside of r less than 1. 4, 5, and 6, none of these are less than 1. So because all of these comparisons are false, the entire condition is going to be false. That's what it's going to return, which is what will eventually be stored in our variable. First result is false, and this should return false as well for the same reasons. Okay. Restarting the runtime, if I make one of these values less than 1 and I make the others accurate, this should return true because at least one of the numbers is less than 1. This gives us an indicator that they are not following the rules, and this will be just fine. But because at least one of the functions is throwing us a red flag, we would need to tell the user that they can't play the game anymore. And one thing I just realized is we should probably name this is less than 1 rather than r, because this returns true if at least one of the numbers is less than 1. So it would make way more sense to write that. Remember, the name of your function should, as much as possible accurately describe the task that it performs. This checks if at least one of the numbers is less than 1 or higher than 6. Okay. So now instead of storing the Boolean in a variable, we're going to use that Boolean to determine which block of code should run. So if any of the numbers that they input is less than 1, or if any of the numbers they input is higher than 6, then we cannot allow them to proceed. We're going to say system.exit 0. Now all this does is it terminates the application. It stops the JVM. Nothing else. Don't overthink it. In the future, we're not going to be using system.exit 0 anymore. We're going to be throwing runtime exceptions in module 2. So don't really give this much thought because it's not really common practice. But for the sake of finishing our app with our existing knowledge, we're going to use system.exit 0 to just terminate the app if they enter bad data. And if they do, we're going to say you entered numbers outside the valid range. Okay? Let's try this out now. I'm going to enter the numbers 4, 5, and 6. This is going to return false because none of the numbers are less than 1. This should return false because none of the numbers are higher than 6, which means nothing here is going to get executed. We did not need to shut down the application. But if the user were to enter bad data, let's say -1, 2, and 5, or 4, this is going to return true because at least one of the comparisons is true. This entire condition is true, telling the user you entered numbers. This should be in parentheses because it could be one number or multiple. You entered numbers outside the valid range, and then system.exit 0 shuts down the application. That's all it does. Don't overthink it. Alright, and now I want you to think about how tedious your code would be if we didn't use functions. Instead of having one function call that returns a Boolean here, you would have had 3 comparisons. Instead of having one function call here, you would have had 3 more comparisons, and you would have kept cluttering your main function with more and more code. Eventually, your code would be very unreadable. But look at how expressive this code is. Here I'm checking if any of the numbers is less than 1. Here I'm checking if any of the numbers is higher than 6. This reads like English. So All I can really emphasize is whenever possible, use a function. It makes your code a lot more descriptive. All right, I'm going to stop rambling on because now we want to check if the user wins at line number 21. So if we reach this line of code, the app did not terminate, which means they inputted valid data. And you'll remember the user wins if their sum of numbers is greater than the sum of dice rolls and if the difference between the sums is less than 3. So what we can do is say, or create another function that performs the task of checking if the user won. So public static boolean user won. It's going to receive the sum of numbers and it's going to receive the sum of dice rolls. And upon receiving these sums, it's going to return a boolean that gets produced by checking if the sum of numbers is greater than the sum of dice rolls. That's one of the conditions we need to check to see if the user won. And we need to also check if the sum of numbers minus the sum of dice rolls is less than 3. So if both of these conditions are satisfied, then we know the user won. And so here, once we reach line number 21, we know that the user inputted valid data. We can check to see if they won. If user won. Here we need to add up the sum of numbers. So number 1 plus number 2 plus number 3. We need to compare that against the sum of dice. You know what? Instead of doing that, how about I create separate variables for them? So int sum of numbers is equal to number 1 plus number 2 plus number 3. And sum of dice rolls is equal to roll 1 plus roll 2 plus roll 3. And we're going to check if the user won by comparing the sum of numbers against the sum of dice rolls. If they won, then we can say, congratulations, you won. Otherwise, print better luck next time. Okay, and before we wrap up, let us just focus a little bit on aesthetics. I'll put a new line here, put a new line here. And before showing the result, let's at least display their sum and the computer sum. So we'll say your sum is the sum of numbers. And then we'll say computer sum is sum of dice rolls. Or you know what? Let's call this dice sum. All right, and I think now we should be ready to run our application. I'm going to put just one breakpoint over here at line number 26. Press debug. All right, enter 3 numbers between 1 and 6. We've already tested these conditions, so let's avoid all this and just enter valid numbers 4, 5, and 3. So my sum is 12, the dice sum is 15. If I go inside of user 1, my sum of numbers is not greater than the sum of dice rolls, so automatically it's going to return false, and I'm going to lose. All right, not fun. Let's try this again. I'm going to enter the numbers 5 or 6, 5, and 5. So if I step inside of user 1, so this time my sum of numbers is greater than the sum of dice rolls, but the difference between them is not smaller than 3. So once again, I lose. Let me try this again. Let me aim for a number like 12. So let's say 4, 4, and 4. I'm still going to lose. Try this one more time. I'll aim for a number like 15 this time, or let's say 13. Still lose. How about 5, 4, and 4? Again, this game is pretty darn hard. 7, 5, 3. Oh, my bad. I fell for my own trick. Let's say 4, 5, and 5. All right. I still lose. You know what? This condition is a little too harsh. Let's say less than 5. We'll say 5, 5, and 5. I entered 15. The dice sum is 12. So if I step inside of user 1, the sum of numbers 15 is greater than the dice sum 12. All right, so I satisfy this condition, and the difference between them is less than 5. 15 minus 12 is less than 5, which means that I finally win. Congratulations, you won. All right, and this is pretty much it. Now, don't focus too much on the mechanics of the game. The reason that I built this game is to show you how much cleaner functions make your code. Instead of writing all of this code inside of main, just imagine how messy that would have been. We grouped unique pieces of code that perform a particular task into functions. This grouping of code checks if any of the numbers is less than 1. This grouping of code checks if any of the numbers is higher than 6. This grouping of code checks if the user won. And this performs the task of rolling a dice. None of these functions are performing more than one task. They all perform the task that is described and nothing else. And as a result, the code inside of our main function, our main method, is very expressive and very easy to follow. I hope you're proud of yourself for making it this far. In the next section, we're going to continue adding some skills to our Java toolbox, so I hope you're ready. See you soon. Consider a scenario where you need to call a function 6 different times, like sing chorus. Instead of tediously copying and pasting the code for each repetition, you can use a for loop to streamline the process and achieve the same result more efficiently. Now imagine another situation where you want to continue rolling dice until you roll doubles. In this case, you don't know how many attempts it will take to satisfy the condition. A while loop is perfect for this. There is no need for counters or increments. The while loop simply runs until the condition is fulfilled. While loops are perfect for executing code an unknown number of times. In this lesson, our primary objective is to develop a solid understanding of for loops. A for loop is designed to run code a specific number of times. The for loop has 3 parts. The start, this loop starts with I equaling 0. The stop condition, this loop is going to keep running as long as I is less than 3. And the step size, I is going to increase by a step size of 1 every time the loop runs. Let's go and have a look. Start by creating a new folder called Section 5 to kickstart this section. We are going to launch this inside of VS Code. Our first task is to print numbers from 1 to 10. So what we need to do is create a for loop whose counter starts at the number 1, The loop is going to keep running so long as the counter is less than or equal to 10. And every time the loop runs, we need to increase the counter by 1. During each run of the loop, we will print the counter. Before we debug the runtime, how is this going to work? Well, I is going to start off by equaling 1. 1 is less than or equal to 10, so our loop will run. After the loop runs, I++ is going to increase I to equal 2. 2 is still less than or equal to 10, so our loop is going to run. After the loop runs, I++ will increase the counter to equal 3. 3 is still less than or equal to 10, so our loop runs, and this is going to keep happening. When I equals 10, the loop will still execute because the condition is satisfied, but then I++ is going to increase the counter to be 11. Once it does that, this condition will be false and our loop will break. Let's visualize the runtime, put a breakpoint at line number 7. All right. So first I equals 1. I is less than or equal to 10, so our loop is going to keep running. I++ is going to increase our counter to equal 2. 2 is still less than or equal to 10, so our loop is going to run. Now I++ is going to increase the counter to equal 3. 3 is still less than or equal to 10, so our loop runs. And this is going to keep happening so long as I is less than or equal to 10. So at this point, I is equal to 10, I++ is going to increase the counter to equal 11. 11 is not less than or equal to 10, so our loop breaks. All right, and ultimately, we printed the numbers 1 to 10 using a for loop. Could we have done this differently? Of course. We could have changed this condition so that the loop keeps running so long as I is less than 11, and we would achieve the exact same result. Let's visualize it. So I starts off equaling 1. 1 is less than 11, so our loop runs. I++ increases the counter to 2. 2 is less than 11, so our loop runs. And this is going to keep running so long as I is less than 11. Okay, and now at this point, I++ is going to increase the counter to equal 11. 11 is not less than 11, so our loop breaks. And using a different condition, we were able to achieve the exact same result. So there's always more than one way of writing a for loop. Which one should you use? It is more common and more concise to use the less than operator. This would work the exact same way, but you should favor using less than. Alright, in example 2, we print hello world 5 times. So using a for loop, which starts at I equaling 0. Wait, why 0? Why not 1? Here we only used a counter of 1 because we were basically forced to. We needed to print numbers from 1 to 10, so I needed to start at 1. But with for loops, it is more common for I to start at 0. Why? Well, that's because loops and arrays, which you'll learn about in the next section, they go hand in hand. The index of an array starts at 0, and when you're looping through an array, it only makes sense for your counter to start at 0 as well. So unless it's a special circumstance, favor your counter starting at 0. Okay? And this loop is going to keep running so long as I is less than 5, and every time the loop runs, we are going to increase the counter by 1. And during each run of our loop, we are going to print hello world. Alright, let's visualize the runtime, remove this breakpoint, press debug. I is going to start off equaling 0. I is less than 5, so our loop runs. I++ increases I to equal 1. 1 is still smaller than 5, so our loop runs. I++ is going to increase our counter to 2. 2 is still smaller than 5, so our loop ran. I++ is going to increase our counter to 3. 3 is still smaller than 5, so our loop ran. I++ is going to increase I to equal 4. 4 is still smaller than 5, so our loop ran. But this time, I++ is going to increase our counter to equal 5. 5 is not less than 5, so our loop breaks. So in total, our loop ran 5 times, where the counter equaled 0, 1, 2, 3, and 4. Alright, and if you wanted to use the less than or equal to operator, which I don't recommend, you would have to make this into a 4 to achieve the exact same result. But I'm going to stick with the less than operator. Okay, now we print the multiplication table of 5 up to 10. So 5 times 1, 5 times 2, 5 times 10. Here, what I'm going to do is create a for loop, and this time I is going to start at 1 because that's what the scenario describes. The loop is going to keep running so long as I is less than 11 because we want 10 to be included in our loop. Then we're going to say I++. And during each run of our loop, we are going to print that counter I times 5. Okay, let's visualize the runtime. I'll remove the breakpoint at line number 14, press debug. So I is going to start off equaling 1. 1 is less than 11, so our loop runs. 1 times 5 is 5. Cool. I++ is going to increase our counter to equal 2. 2 times 5 is 10. I++ is going to increase our counter to equal 3. 3 is less than 11, so our loop ran. I++ is going to increase our counter to equal 4. 4 is less than 11, so our loop ran. And this is going to keep happening so long as I is less than 11. Okay, now I++ is going to increase our counter to equal 11. 11 is not smaller than 11, so our loop breaks. In essence, we printed the multiplication table of 5 from 1 up until 10. We could make this a bit more interesting by adding some text. We can say multiplication table right on top. And before printing the result, I'm going to start off by printing the counter, followed by a colon, followed by the result. Put a new line here, remove the breakpoint, and this looks a lot better. Okay, so here you can see the counter going from 1 up until 10. Pretty nice. Now we print the numbers from 10 to 1 in reverse order. So here, what we need to do is create a for loop where I starts off equaling 10. Okay? And what should our condition be? When should we stop the loop? We want our loop to keep running so long as I is greater than 0. Okay? And now, every time the loop runs, we want to decrease I because we want it to go from 10 up until 1. Okay? We'll just put a breakpoint at line number 28, press debug. So I is going to start off equaling 10. Actually, you know what? Let's create some spacing. We'll say reverse order. Press debug again. So I is going to start off equaling 10. 10 is greater than 0, so our loop is going to run. I minus minus is going to decrease I to equal 9. 9 was bigger than 0, so our loop ran. I minus minus is going to decrease I to equal 8. 8 is less than 0, so our loop is going to run. I minus minus is going to decrease I to equal 7. 7 is greater than 0, so our loop is going to run. And this keeps happening so long as I is greater than 0. And now I minus minus is going to decrease I to equal 0. 0 is not greater than 0, so our loop is going to break. And just like that, we started with I equaling 10, and the loop kept running so long as I was greater than 0. Alright, now we print the first 10 even numbers. The first 10 even numbers are 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. we need a loop that prints all of these numbers. So what I'll do is I will create a for loop that starts at I equaling 0. The loop is going to keep running so long as I is less than 19. And every time the loop runs, instead of increasing I by 1, we're going to increase it by 2. I plus equals 2. Remember the plus equal operator. And during each run of the loop, we are going to print I. Let's try this out. Put a breakpoint at line number 36. So I starts off equaling 0. 0 is less than 19, so the loop runs. Sorry, let me just put some spacing over here. Here I'm going to say even numbers. Start again, press debug. I is going to start off equaling 0. 0 is less than 19, so our loop runs. I plus equals 2 is going to increase I to equal 2. 2 was less than 19, so our loop ran again. I plus 2 is going to increase I to equal 4. 4 is less than 19, so our loop is going to run. Okay. And this is going to keep happening so long as I is less than 19. In essence, printing the first 10 even numbers. At this point, I plus equals 2 is going to increase I to equal 20. 20 is not less than 19, so our loop breaks. Our stop condition worked perfectly. Alright, and you can get really creative with for loops. There's always more than one way to accomplish the same task, as long as you acknowledge the start. Where does your counter start from? The stop condition. When do you want your for loop to stop? In this case, we want this loop to keep running so long as I is less than 5. And your increment. Every time the loop runs, how should you increment the counter? This is the type of thing that requires a lot of practice, so get ready for a lot of workbooks. While loops are designed to execute code an indefinite number of times. To review, let's assume there's a function you want to call 6 times. Because the number of loops is definitive, then you can use a for loop that keeps count until we reach the desired number of executions. But in scenarios where it's not certain how many times a piece of code needs to run, while loops are ideal for executing code an unknown number of times. In this lesson, our primary objective is to develop a solid understanding of while loops. Okay, what is a while loop? A while loop keeps running while a condition is true. It follows that while loops only have one component, a condition. As long as that condition is true, the code keeps running. Alright, start by dragging the file that you just downloaded to section 5 and let's begin. In example 1, we have to write a while loop that simulates rolling a dice until a 6 is rolled. We don't know when a 6 is going to roll, so this is a perfect use case for a while loop. Okay, and this while loop needs to keep running until we eventually roll a 6. So what I'll do is I'll create a variable called dice roll, and at first I'll set it equal to something random like -1. And we need this loop to keep running so long as the dice roll doesn't equal 6. As long as this condition is true, we need to keep rolling the dice. And then we're going to say dice roll is equal to whatever we roll. The idea is that as soon as we roll a 6, this condition will be false and then the while loop will break. Let's put a breakpoint at line number 7, press debug. Dice roll starts at -1. -1 is not equal to 6. This condition is true, so we gotta roll the dice. We just rolled a 4. 4 is not equal to 6, so we need to roll the dice again. We just rolled another 4. The condition is true, so the while loop runs. Now we rolled a 2. 2 is not equal to 6, so the while loop runs again. Now we rolled a 3. And the while loop keeps running until we eventually roll a 6. We don't know when that's going to happen, but as long as this condition is true, the while loop keeps running. But now we rolled a 6. 6 is not equal to 6, so the while loop breaks. And just like that, the while loop kept running until we achieved our desired result. Now you know what I'm going to do is I'm going to print the dice roll every single time the loop runs and just press run. And here we got really lucky and we rolled a 6 the very first time. Let's press run again. Interestingly enough, it took a gazillion dice rolls until we eventually rolled a 6. That's pretty cool. So the number of times a while loop runs is pretty indefinite. Here you're seeing a very extreme example that just happened in real time. In my first execution, the while loop only ran once because we rolled a 6 right away. The condition was false and it broke. In the second execution, my while loop ran 20 times until we eventually rolled a 6, breaking the while loop. Alright, pretty cool. Now we generate random numbers between 1 and 100 until a number greater than 90 is generated. So let's create a variable called random number. At first, I'm going to set it equal to -1. And here I'll say while the random number is not greater than 90, while it's less than or equal to 90, we need to keep running this loop until we eventually generate a random number that is greater than 90. Okay? Let's remove the print statement here so that we don't clutter the output. I'm just going to print the random number, and this is taking up way too much space for no reason. I'm going to put one breakpoint at line number 14 and press debug. Okay, so the random number starts off at -1. -1 is less than or equal to 90, so our while loop keeps running. Here we generate a random number of 86. 86 is still less than or equal to 90, so our loop keeps running. And until we generate a number that is greater than 90, our loop is going to keep running. How many runs will it take until we achieve our desired result? It seems like a lot, because the range that we want our number to be in is pretty narrow. But it doesn't matter. Our while loop is going to keep running so long as this condition is true. Alright, we finally generated a random number of 97. 97 is not less than or equal to 90, so now we know that our loop needs to break. We achieved our desired result. And how many runs did it take until we achieved our result? Quite a bit. But it doesn't matter because the while loop is designed to run code an indefinite number of times. We don't know how many times it's going to take for our function to finally generate a random number that's greater than 90, so we set up a while loop that keeps running until we achieve our desired result. Okay, now we write a while loop that keeps doubling the number variable until it's greater than 1,000. So we'll start with a number that equals whatever random number gets generated. And here I'm going to create a while loop that keeps running so long as that number is less than or equal to 1,000. And every time the loop runs, we are going to multiply that number by 2. We have no idea what that random number is, so we also don't know how many runs it's going to take until that number is greater than 1,000. But not to worry, we have a while loop that's going to keep running so long as that number is less than or equal to 1,000. And before we press debug, let's print our number each time, remove the print statement here, put a breakpoint at line number 20, and press debug. Okay, so the number that was generated is 47. 47 is less than or equal to 1,000, so the while loop runs. Here we multiply that number by 2, now it equals 94. 94 is still less than or equal to 1,000, so the while loop runs. 188 is still less than or equal to 1,000, so the while loop runs. And the while loop is going to keep running until we reach a number that is greater than 1,000. So right about now, the number is 1,504. 1,504 is greater than 1,000, so our while loop is going to break. And in essence, our while loop kept running until we achieved our desired result. We have no idea how many times the while loop needed to run. It kept running while this condition is true. Okay? And that's pretty much it. We ran our code so many times. Now, what do you think would happen if we just said, while true, print hello? What do you think would happen here? Well, before we run this code, I need to warn you. If you're using a Mac or a Windows computer, you can stop the output using Control-C. Okay? If I press run, the while loop just runs forever. Press Control-C and stop the output. Why did this happen? The while loop keeps running so long as whatever you put in these brackets is true. Here we didn't actually put a condition, we just put a boolean of true so we can expect it to run forever. What if I put false here? We get an error right away because it's telling you this is unreachable code, it's dead code. A while loop breaks when it's false. If you just set it equal to false, then it's never going to run. So here it's basically telling you, what are you doing? What's the purpose of this loop if it's never ever going to run? And that's pretty much it. That's all we're going to cover for while loops in this lesson. There are going to be a ton of workbooks to test your knowledge, so I will see you there. But in the interest of a very short mini recap, a while loop is designed to run code an indefinite number of times. Break and continue statements provide you with greater control over your loops. Up until now, you've used for loops and while loops to execute code multiple times. When you need to run code a specific number of times, a for loop is the better choice. On the other hand, when it's unclear how many times a block of code needs to run, a while loop is more suitable. And in this lesson, you will learn how to use the break and continue keywords within your loops, which will grant you even more control over them. The continue keyword skips a run in the loop and continues with the next one. I'm only going to do examples that rely on continue at first. Here we need to write a loop that prints numbers from 1 to 10 but skips the number 5 using continue. So I'm going to create a for loop that starts with I equaling 1. The for loop is going to keep running so long as I is smaller than 11. And then every time the loop runs, we increase the counter by 1. Here what I'll do is I'll say if the counter ever equals 5, we need to skip this run in the loop using the continue keyword. Nothing after the continue keyword is going to run. So if we do reach line number 14, then that number is not equal to 5, in which case the loop is going to run normally. Here we need to print all even numbers from 1 to 20, skipping odd numbers. Recall from the variables section that a number is even if its modulus by 2 is equal to 0, and a number is odd if its modulus by 2 is not equal to 0. So here what I'm going to do is say for int I has to start at 1, I is smaller than 21 because we want the numbers to go from 1 to 20, I plus plus, and here I'll say if I modulus 2 is not equal to 0, if the number is odd, we need to skip that run in the loop using continue. Nothing after continue is going to run in that loop, but if we do reach line 28, then we simply print that number. Okay, let's have a look. I'll put a breakpoint at, you know what? Let's add some separators. Here I'm going to say new line, even numbers, and here I'm going to say new line, I don't know, numbers. Okay. I'll put a breakpoint at this for loop and at this one as well. Press debug. So I starts off equaling 1. 1 does not equal 5, so the loop just runs normally. This continues until I eventually equals 5. Because I equals 5, continue is going to skip this run in the loop and continue to the next one. And then the loop is just going to run normally from here. And just like that, continue successfully skipped the number 5 because nothing below it is going to run. It simply continues to the next run in the loop. Alright, now for this example, I starts off equaling 1. 1 is an odd number, so continue is going to skip this run in the loop and continue to the next one. Now I equals 2. 2 is an even number, so the loop runs normally. Now I equals 3. 3 is an odd number, so continue skips this run and continues to the next one. And this is going to keep going until our stop condition is eventually fulfilled. And whenever the number is odd, continue skips that run in the loop. Otherwise, the loop just runs normally. Let's keep going. All right, and now our stop condition should be fulfilled and we are done. And that's pretty much it for the continue keyword. Remove the breakpoints. And now we can talk about the break keyword. The break keyword, when invoked, breaks the loop entirely. So here we need to write a loop that goes from 1 to 10. Let's just copy what we have here. But we need to stop when the number 5 is reached using the break keyword. What I'm going to do is put a breakpoint at line number 6, press debug. So the loop is just going to run normally at first with I equaling 1, 2, 3, 4. And once we reach 5, break simply breaks the loop entirely. Pretty simple. So while break breaks the entire loop, continue skips a single run in the loop. So here I starts off at 1, 2, 3, 4, and once we reach 5, continue is only going to skip this run in the loop and continue to the next one. So while break breaks the loop entirely, continue just skips a single run. Let's demonstrate this again. Here we write a loop that finds the smallest number greater than 20 that is divisible by 3 using the break keyword. And now, similar to how a number is even, similar to how a number is divisible by 2 if its modulus by 2 equals 0, a number is divisible by 3 if its modulus by 3 equals 0. So here we can say for int I is equal to 21, because we need to find the smallest number greater than 20. I is smaller than 30. It really doesn't matter what your stop condition is here, because there are plenty of numbers divisible by 3 between 21 and 30, 21 included. So you already know that this loop is only going to run once, I++. And here we say if that number, if its modulus by 3 is equal to 0, if it's divisible by 3, then what we need to do is break the loop. And before breaking the loop, I'm going to print the smallest number greater than 20 divisible by 3 is I. Whatever number broke this loop. Okay, let me press debug, remove this breakpoint. Okay, I starts off equaling 21. 21 is divisible by 3, so our loop is going to break right away. Let me put some spacing here. What if we made this a little bit more interesting? How about we write a loop that finds the smallest number greater than 20 that is divisible by 8? And here we can change this message to be the smallest number greater than 20 divisible by 8 is whatever number breaks this loop. Press debug. 21 is not divisible by 8. 22 is not divisible by 8. 23 is not either. 24 is divisible by 8. 24 divided by 8 equals 3. So the smallest number greater than 20 that is divisible by 8 is 24. And because we found this number, we can break the entire for loop. Now what if we said something like 11? What if we wanted the smallest number greater than 20 divisible by 11? In this case, 21 is not divisible by 11. However, you can divide 22 by 11. The smallest number greater than 20 divisible by 11 is 22. All right. So to recap, now you have complete control over your loops. You can use for loops to execute code a specific number of times, while loops to run code an indefinite number of times, and you learn how to use break and continue within your loops, granting you even more fine-grained control. A nested loop is a loop inside of another loop. This for loop is going to repeat code 3 times. But what if I placed another loop inside of it, one that also runs code 3 times? How many times is hello going to print? Before I break it down for you, I encourage you to pause, take out a pen and paper, and try to trace the runtime of the code that I'm about to redisplay. Okay, I hope you figure it out. Hopefully that went well. In this lesson, you're going to learn to use nested loops. First thing you need to do is create a new class inside your section 5 folder. This file is going to be called nested loops. and make sure the class has a main method. The nested loops has an outer loop and an inner loop. The outer loop is the big loop, and the inner loop is the smaller loop inside. This print statement is going to run 9 times, because each pass from the outer loop is going to run the inner loop to completion. The first pass is going to run the inner loop 3 times. The second pass is going to run the inner loop 3 times. And the third pass is going to run the inner loop 3 times. In total, the nested loop ran 9 times. So in nestedloops.java, I'm going to start by making a loop that runs exactly 3 times. The loop starts with the counter I equaling 0. The loop is going to keep running as long as I is less than 3, and after each run, we're going to increase the counter value by 1. And so every time this loop runs, we're going to print the value of the counter during that run. So system.out.println run, and I'll connect the counter value during that run I. And great, we printed the counter value during the first run, second run, and third run. Now I'm going to write a for loop inside the current one. The loop starts with the counter j equaling 0. The loop is going to keep running as long as j is less than 3, and after each run, we're going to increase the counter j value by 1. And every time this loop runs, I'm going to print the counter value. And before I explain what's going to happen, it might be worth it to just run the code and see the output. And, as I expect, every pass from the outer loop runs the inner loop to completion. Hello, this is myself 3 years into the future. I decided to include breakpoints in this lesson because I think it could benefit a lot from them, so I'll add a breakpoint here and press debug. The outer loop begins with I equaling 0, which is less than 3, so the outer loop starts running, printing the current counter value I. Then it reaches the inner loop, which initializes j to 0. Since j is less than 3, the inner loop starts running and prints the current counter value, and the inner loop will continue to run as long as j is less than 3. So let's keep going. Now j++ is going to increase j to 3. Because j is no longer less than 3, the inner loop breaks, completing the first run of our outer loop. Now I is going to be incremented to 1. We've reached the second run of the outer loop, which is once again going to run the inner loop to completion. The key takeaway here is that each run of the outer loop runs the inner loop to completion. I++ increases I to 3, which fulfills the stop condition for the outer loop, so the entire nested loop breaks. Alright, let's go through this one more time. Again, the key takeaway is that each iteration of the outer loop runs the inner loop to completion. So first I equals 0, and the inner loop will keep running as long as j is less than 3. Now I equals 1, and the inner loop keeps running as long as j is less than 3. Now I equals 2, and the inner loop keeps running as long as j is less than 3. I++ is going to increase our counter, which means it will no longer be less than 3 and the entire nested loop breaks. Alright, that's all. I'm going to hand this presentation back over to myself from the past. Okay, so what are some applications of nested loops? Nested loops are useful when you're working with 2D arrays. You haven't learned about arrays yet, so you're not going to see nested loops for the remainder of this section. But they are going to come back in the next section, I can promise you that. We can use arrays to store many values at the same time. So far you've only been storing one value at a time, but sometimes these values can be closely related, and creating one variable after another can be very messy. So what we can do is store all of these values at the same time in an organized way. This is called an array, and in this lesson you will use arrays to store many values at once. And here you can see we've got 4 different values being stored in 4 different variables. Whenever you find yourself defining variables like this, kingdom 1, kingdom 2, kingdom 3, and kingdom 4, whenever you find that your variable creation is being very redundant, then it's probably a good time to use an array. Arrays in Java look like this. If I want to store many integers at once, then I can just put square brackets next to the integer type, and I can store many integer values in the same array. That being said, an array can hold many values, but all of them have to share the same type. For example, integers points to an array of integer values, words points to an array that stores string values, and decimals points to an array that stores double values. So here what we need to do is store an array of string values. The variable that will point to the array is going to be called kingdoms, and I will set this equal to a new array that stores 4 kingdom elements. Mercia, Wessex, we'll just copy them over. We're good to go. Alright, and now what I want you to do is put a breakpoint and press debug. The variable does not store the array directly, it stores a reference that points to it. What I want you to also notice is that each element is stored at an index. Mercia starts at index 0, Wessex at index 1, Northumbria at index 2, East Anglia at index 3. So here what I can do is print the element at each index. We will print the element at index 0, at index 1, 2, and 3. So here we created the variable kingdoms with a reference at 9 that points to an array of 4 elements. Here we print the element at index 0. Here we print the element at index 1, 2, and 3. And now what happens if I try to access an element outside the range of the array? So what happens if I try to access an element at index 4? We know this doesn't exist, so what Java is going to do is throw an index out of bounds exception. In essence, crashing our application, telling us that we have an error in our code. Index 4 is out of bounds. So you might be thinking, wait, index 4, wouldn't that be the 4th element? In almost every other programming language, including Java, we start counting from 0. So the first element is at index 0, and the 4th one is at index 3. Index 4 is out of bounds. And now another thing I want to mention is that you might expect that by printing kingdoms, it should print every single element inside of the array. Well, what gets printed instead is a hash code representation of the reference. So you'll remember that a variable stores a reference that points to an array, and you don't really need to know this, but what gets printed is the hash code representation of our reference. What I want you to take away from this lesson is that if you have many values that are closely related, you can store all of them at the same time inside of an array, and then you can access each value in the array using an index. In this video, you used array to store many values at the same time, and then you accessed each element using its index. And if you try to refer to an index number that doesn't exist, Java's gonna throw an index out of bounds exception. Arrays and loops are like siblings. Imagine you have an array containing 6 elements, and you want to access each element in the array. Would you prefer to index them all individually or use some kind of loop that iterates through every single element in the array? I think the looping approach would be more efficient. I've already gone ahead and launched the starter project, set it up inside of section 6, and let's begin. Here we want to loop through every single element inside of the numbers array. So I'll create a for loop that starts at I equaling 0. The loop is going to keep running so long as I is smaller than the length of the array. Interesting. What is numbers.length? Every single array has access to a length property that returns the number of elements inside the array. So this loop is going to keep running so long as I is less than 5, and for each run of the loop, we say I++. Okay, and now what we can do is print every single element at index I. How is this going to work? Let's debug the runtime. I'll put a breakpoint at line number 6, and let's begin. So I starts off equaling 0. The element at index number 0 is 22. Now I is 1, and here we're accessing the element at index 1. Now I is 2, so we access the element at index 2. Now I is 3, we access the element at index 3. Now we print the element at index 4. Pretty darn cool. Now here's something else we can do. You can actually autocomplete a for loop, and you'll notice here it says for I. If you click on it, VS Code auto-generates a loop that runs through the length of the array. And you might have noticed we're given the option to create another type of loop, for each. For clarity, let me call this number instead of I. For each simplifies looping through an array without the need for a counter or a counter increment or anything. It just automatically iterates through every single number inside of the numbers array. Here I can just say print every single element, every single number that you're currently iterating through. Press debug. So first we loop through the first number 22, the second number 24, the third number 26, the fourth number 29, and the fifth number 30. Okay. So as you can see, this is much cleaner and more concise than the traditional for loop. But the traditional for loop is way more flexible. For example, it would be really hard to do example 3 or example 4 with the for each loop, because here we need a loop that prints every second element of the grades array. This is a scenario where we need the counter I to give us more control over the looping process. But for something like example 1 or example 2, you can go ahead and just use the for each loop. Here we're simply looping through every single string inside this array of strings without bothering with counters. For each just magically runs through every single element inside of the array. And for very simple scenarios like this, the for each loop is perfect. But for a scenario like example 3, we need the flexibility of a traditional for loop. Here I need to use a for loop to print every second element of the grades array. We need to set up a step size of 2. You've done this countless times in the past, so I'll erase through it. For int I is equal to 0, the loop is going to keep running so long as I is smaller than grades.length. I++. So this loop is going to run through the length of the array, and during every single run, we're going to print the element at index I. However, I made a mistake of saying I++. We need this to be I plus equals 2, because we want to step through every second element of the grades array, starting from 0 to 85, 90, 88. Let's put a breakpoint over here. Press debug. So we start off at I equaling 0. Print the grade 95. Now I is going to equal 2. Print the grade 85. All right. So this loop does everything with a step size of 2. This would be really hard to accomplish with a for each loop. So going forward in this course, to stay consistent, I'm going to keep using the traditional for loop, because I don't want you to think, oh, do I use a for each loop? Do I use a traditional for loop? Let's just stick with one approach for now until we're more comfortable. Furthermore, for your benefit, I'm not going to use the autocomplete feature anymore in this section because I want you to get used to defining the loop yourself. This is really important. All right, with that out of the way, let's continue with our examples. All right, example 4, use a for loop to double each element in the values array. Simple enough. For int I is equal to 0, the loop is going to run through the length of the values array, I++. Remember that length just returns the number of elements inside the array, so this loop keeps running so long as I is less than 5. And whenever we run through the loop, we're going to say values at index I will equal itself times 2. Let's see how this works. Put a breakpoint at line 27, press debug. So first we access the element at index 0, we set it equal to itself times 2. Beautiful, and we keep doing that until we're done. By the way, using a for each loop in this case would have been pretty much impossible. Let me call this a value, okay, and comment this out for now. This, once defined, is just some random variable. It's completely independent from the array itself. So if I say value is equal to value times 2, all you're doing is changing this temporary variable that we're iterating through. It has nothing to do with the array itself. So if I were to actually debug the runtime and show you, here we extract the first element, the value of 3. If I say value is equal to value times 2, nothing really happens to the array. So again, the for each loop is really just for very simple operations. In order to update an element in the array, we need to access it using its index. So most of the time you need this counter for operations that require index manipulation. So we're usually in this course going to rely on the more traditional and more flexible for loop. All right, enough rambling. Take home message: when in doubt, use the traditional for loop. Here we want to capitalize the elements of a string array. Another example where we cannot use for each because we need to index every single element inside of the colors array. This loop is going to run through the length of the colors array. And for every loop that we go through, we're going to index an element and set it equal to itself, capitalized, to uppercase. I want this option. Okay. Let's do example 6 real quick. Find the index of a specific value inside of an integer array. Once again, here we need to access an index, so we need to use the traditional for loop. For int I is equal to 0, I is smaller than data.length, I++. As soon as the element at a particular index equals a value of 4, we need to automatically print that index. Okay, so this should output 0, 2, and 4, and 6. Let's press debug. Here we run through every single element inside of the colors array. We set the element at index 0 equal to itself, but uppercase. We set the element at index 1 equal to itself, but uppercase. We set the element at index 2 once again equal to itself, but uppercase. Here we run through the length of the data array. Every time we run through it, we check if the element at that index equals 4. If it does, we print that index. So 4 is located at index 0, nothing at index 1, and the element at index 2 does equal 4, so we return that index. Nothing at index 3. The element at index 4 does equal 4, so we return that index. Okay, nothing at index 5. The element at index 6 does equal 4, so we return that index. All right. And that is all. Looping through an array is pretty darn easy. All you gotta do is define a start, loop through the length of the array, and depending on the steps that you want to take throughout the array, you define an increment. If you want to go through the elements one by one, you say I++. If you want to go through the elements 2 at a time, you say I+ equals 2, so on and so forth. I hope you enjoyed this lesson. It's going to be followed by a lot of workbooks, so I hope you're ready. It's time to learn how to update arrays. So far we used a for loop to run through the length of an array. And now you know how to create arrays as well as how to access their values. The last step is to learn how to update them. So inside your section 6 folder, create a new file named updatingarrays.java, and inside the class make sure there's a main method. Just like we can access array values from their index, we can update them all the same. Say you have an array of 3 elements. If you want to change an element, just refer to its index and then change the value. It's that simple. And so I prepared a fun example for us to learn about how to update arrays. You decided to pursue your lifelong dream, open up a cafe, the Java Cafe. Your menu starts off pretty simple. It offers 3 beverages: the espresso, iced coffee, and macchiato. So inside the class, we're going to store the menu in one array. String menu is going to equal an array of 3 string values: espresso, iced coffee, and macchiato. Now, I don't know about you, but I'm a bit tired of using loops to print the array. Java has a function called toString. It takes your array as an argument and it returns a string that we can print. So first, write the word arrays, wait a bit, and click on the first option, and what that's going to do is auto-import the utility class. And so from the arrays utility class, we can use the toString method. The toString method is going to take your array as an argument and return a string copy. We can store the string copy in a string variable. And this is really convenient because we can now print the contents of menu as one long string. Run the code and nice. toString returns a string copy of the array which you can easily print. Now instead of storing the return value then printing it, I'd rather just print the return value in one line. And your cafe is all set up and people are going nuts, but nobody's buying the macchiato. So you decide to sell lattes instead. So what we're going to do is we're going to update the value at index 2 and set it equal to latte. Alright, perfect. Now let's say you want to add more items to the menu. Is it possible to change the array length? And the answer is a big fat no. You cannot change the length of an array. And that's really unfortunate because your Java cafe is becoming really popular. And you need to expand your menu to accommodate new customers. There is a lot of demand for house blend and dark roast. But the problem is, once you create an array, you cannot resize it. The current array only has room for 3 items. So what I can do is create a new array that can store 5 string values. So inside the code, I'm going to create a new array that can hold 5 menu items. String menu is equal to new string that can hold 5 elements. The new array has 5 elements with indexes of 0 to 4, and by default, the values are null. Now we're going to create a loop that runs through every item in the old menu. So for int I is equal to 0, remember indexing an array always starts at 0 such that the last index in the array is always 1 less than the array's length. I++. And during each run, we're going to print the index I. As well as the value that we're indexing in the menu. Alright, we're off to a good start. It runs through the length of the old array and it prints every element. Now we need to copy each element from the old array into the new array. So I'm going to delete this code. And I'm going to set every element to new menu equal to the element in menu with the same index. And so from a visual standpoint, this loop runs 3 times and copies every value from menu to the same index as new menu. To prove this, I'm going to print the contents of new menu as a string. And as you can see, the first 3 values are copies from the old array, because there was only 3 values to copy from the old array. But we still have to add house blend and dark roast to our menu. So what we'll do is we'll update the element at index 3, set that equal to house blend. And we'll update the element at index 4 and set that equal to dark roast. Rerunning the code. And the Java Cafe is back in business. Hello, this is Ryan. 3 years into the future, I thought that this lesson could benefit from some breakpoints, so here we are. I'm going to put one breakpoint at line number 6 and press debug. Alright, so menu is fixed at 3 items. We cannot add more items to the menu, but we can update existing items. We're going to update the element at index 2 to be latte instead of macchiato. And then here we print everything as a string, okay. And now we decided that we want to add more items to the menu, so we create a new array with the capacity to store 5 items. Then we're going to run through all of the items in the old menu and use it to populate the new menu. So we set the element at index 0 of our new menu equal to espresso. We set the element at index 1 of our new menu equal to the element at index 1 of the old menu. And we set the element at index 2 of our new menu equal to latte. Alright, and our new menu still has room for 2 more items. We're going to add house blend at index number 3 and dark roast at index number 4, and that is all. In this lesson, you learn how to update arrays. You opened up your first cafe. The menu only had 3 items. Your cafe became very popular, so you decided to add house blend and dark roast to your menu. The problem was you cannot resize an array once you create it. You copied the 3 elements from menu into new menu. And then you manually updated indexes 3 and 4 with house blend and dark roast. I told you earlier that a variable cannot store an array. It stores a reference that points to it. Because of this, another variable can actually store a reference that points to the same array. Isn't that weird? As far as I know, there isn't an official name to describe this phenomenon, so I call it the reference trap. In this lesson, we're going to talk about the reference trap, the violation that causes it, and the solution that prevents it. First things first, inside section 6, make a new file named referencetrap.java, and inside the class, make sure it has a main method. This trap happens when many variables share a reference to one array. This is bad, and I call it the reference trap, because if I change the array through one variable, the other variable gets affected as well. In this example, I set numbers equal to an array of 3 values. But notice that I can update the array from another variable, numbers too. This is bad. This is a trap. And to avoid the reference trap, do not set array variables equal to each other. That's because, well, suppose you have a variable that stores an array of integers. Numbers stores a reference that points to the array. If I set another variable equal to numbers, it's going to copy what's inside. And what's inside is the reference. So now both variables share a reference to the same array. And so the reference trap happens when we set array variables equal to each other. Numbers stores a reference that points to the array, and by setting numbers2 equal to numbers, it copies the value inside, and what's inside is the reference. Now both variables share a reference to the same array. So it's not a coincidence that number2's reference is also a pink circle. I want to commit this violation and show you the trap in code. So let's assume you're a manager at the Java Cafe and you have the staff list from last year. I'm going to set a variable string, staff last year, is equal to an array of 3 values, Tommy, Joel, and Ellie. And now I'm going to print the contents of staff last year as one long string. Good. Nothing too hard. We're just printing an array of string values. And now this year, only one staff member changed, and you're too lazy to rewrite another array. So you decide to set another array variable equal to this one. String staff this year is equal to staff last year. And you're going to print the contents of this array as well. Okay, we're off to a good start. And now, unfortunately, Joel went missing and a new employee named Abby took his place. The staff this year changed, so we're going to change index 1 from the second variable. Rerun the code. Uh-oh, that's not good. I meant to only update this year's staff list, but last year's staff list updated as well. This is very bad because now last year's data is ruined. This is the reference trap I was telling you about. When you set a variable equal to another, it copies the value inside, which is a reference. If I update the array through one variable, it will affect the other because now they both point to the same array. This is bad. Hello, once again, this is Rayan, 3 years from the future. Once again, I decided that this lesson could benefit from some breakpoints, so here we are. I'm going to put a breakpoint at line number 6 and press debug. So here, staff last year stores a reference of @15 to an array. By setting staff this year equal to staff last year, all you're doing is copying over the reference. Now, both of these variables share a reference @15 to the exact same array. And the fact that we can update one array through 2 separate variables is very, very dangerous. The state of a variable should not change because you updated another. In a perfect world, every variable should point to its own array. So what's the solution if I want to copy an array into another variable? How do I do it? The solution is to make a new array. This trap occurs when you set array variables equal to each other. So don't be lazy. Create a new array and then copy every value into the new array using a for loop. So back in our code, we're going to do just that. I'm going to set staff this year equal to a new string array with a length of 3 elements. Then I'm going to create a for loop that starts at int I equals 0, and it's going to run through every element in one of the arrays. They both have a length of 3, so it doesn't matter which length you use. I++. And during each run, I'm going to update each element in staff this year by setting it equal to an element from staff last year with the same index. Now I can rerun the code. Okay, perfect. We successfully copied every element from the staff last year to the staff this year. Now what happens if we change index 1 from the second variable? So I'm going to change index 1, and I'm going to set that equal to Abby. And the world makes sense again. Sweet. That's because you set staff this year equal to a brand new array. The loop copies every value from staff last year to the same index as staff this year. And now each variable stores a unique reference to its own array. Updating the second variable should have no effect on the first. Once again, this is Rayan from the future. Let us visualize the runtime using breakpoints. Press debug. Here I'm setting a variable staff last year equal to an array with 3 elements. Staff last year stores a reference of @10 to its own array. And here we create a brand new array that can store 3 string elements. Staff this year stores a unique reference to its own array. Here we use the for loop to set every single element inside of staff this year equal to an element inside of staff last year. And because these 2 arrays live in completely different memory locations, this is one array, this is another, updating staff this year should have no effect on staff last year. Now here's a better solution, arrays.copyof. Because for something so simple, the for loop is so much code. The arrays utility class that we've been using to call the toString method has another useful method called copyof. It takes 2 arguments, the array that you want to copy and how much of it you want to copy. This looks a lot easier and it seems like a much better solution. So I'm going to update our table, and don't worry, this will be in your cheat sheet. So in your code, remove this monstrosity and replace it with arrays.copyof. And arrays.copyof requires 2 arguments, the array you want to copy, staff last year, and how much of it you want to copy. We're going to copy the full length of the array. Alright, and we get the same result. That's because staff this year is equal to a copy of the old array. I left out the second argument in this animation just because there wasn't any room, but you get the point. Each variable points to a unique array. I hope now you realize that working with arrays is like playing with knives, but as long as you're careful and you follow my table, you should be fine. Once again, this is Rand from the future. Let's visualize the runtime using breakpoints. Staff last year stores a reference to an array that contains 3 elements. Arrays.copyof, what it's going to do is create a brand new array in memory. So the reference of @25 points to an array that was just created at a completely different memory address. And arrays.copyOf, it's going to internally iterate through all of the elements in staff last year and copy it over into our new array. Pretty darn cool. And we should expect the same results as before because we're updating the element inside of a completely different array, an array that lives inside of a completely different memory address. We should be fine. The staff last year is Tommy, Joel, and Ellie, and the staff this year is Tommy, Abby, everyone's least favorite coworker, and Ellie. In this video, you learned about the reference trap. The reference trap happens when you mishandle arrays. Do not set array variables equal to each other. This doesn't copy the array, it copies the reference. The right way to copy arrays is to use arrays.copyOf. It sets the variable equal to a copy of the original array. And now each variable points to a unique array, and you don't have to worry about the state of one variable changing because you updated another. We can use two-dimensional arrays to store data that come in the form of a table. Let's imagine you have a list of grades for one student, Harry. Harry got a 72, a 74, a 78, and a 76 in his courses. Now an array of integers can easily store this list of data. But what if there are more students? This data isn't a list anymore. It's a table with 3 rows. So it looks like we're going to need 3 arrays to store each row of data. Okay, sure, that's fine, but what if there were 100 students? Are you going to create 100 arrays? I sure hope not. Because when your data comes in the form of a table or a grid, you need to use a 2D array, which would look something like this. And it's a lot easier to manage one array as opposed to hundreds. So in this lesson, you're going to learn when to work with 2D arrays. First things first, create a new file named 2darrays.java, tdarrays, and inside the class, make the main method. So what is a 2D array? A 2D array is an array that contains arrays. 2D arrays are perfect when your data is in the form of a grid or a table. Every row in this table is like its own array. One array can store the first row of data, a second array can store the second row of data, and a third array can store the third row of data. But instead of creating many integer arrays to store individual rows, we can bundle this data into a 2D array. This 2D array is capable of storing every row in this table. Because this 2D array has 3 rows, and each row is like its own array, and we can access each row with an index that goes from 0 to 2. Also, each row, each array, contains elements with indexes that go from 0 to 3. And so, in order to create a 2D array, you need to write the type of data you're storing with 2 brackets. This means we're creating a 2D array of integer values. The first bracket is the number of rows, so we're basically creating a table with 3 rows, and the second bracket is the number of elements in each row. In this case, each row of data is going to contain 4 elements. And so from a visual standpoint, this code is going to create an array with 3 rows and 4 columns. And by default, every value is going to start at 0. Let's try it out. Inside your class, create an array with 3 rows and 4 columns. Int grades is equal to a new integer 2D array. The first bracket is the number of rows. We're going to have 3 rows. The second bracket is the number of elements in each row, and each row is going to have 4 elements. Okay, what now? So we have 3 rows, and each row is basically an array with 4 elements. We can grab the row, or in other words, the array of values at index 0, 1, or 2. Now in our code, we can index each array and print its contents using arrays.toString. We can print the array at index 0, the array at index 1, and the array at index 2. And as expected, each row is an array with 4 elements. The first array has Harry's grades, the second one Ron, and the third one Hermione. So I'm going to print some messages to reflect this. I'll put a tab of space, followed by Harry, and a colon. I'll do the same thing for the next 2 print statements. Ron and Hermione. Alright, we're off to a pretty good start. So how do you update 2D array values? Just like before, you can update array values from their index. You can access any item in this table with 2 indexes. If I want to change Hermione's grade in charms, the first index is the array we're interested in. In this case, here I'm fetching the row. I'm fetching the array with an index of 2. The second index refers to the element in that array. In this case, I'm grabbing the value that's inside row 2 and has an index of 3 within that row. So with this information, I can start by updating Harry's grades. All of Harry's grades are in the first row, row 0, so the first bracket is going to index the array, the row that we're interested in. And we can use the second bracket to index a specific element in row 0. Harry got a 72 in potion, a 74 in herbology, a 78 in arithmancy, and a 76 in charms. I can go ahead and run the code. And as you can see, this updates every element in the first array. Now we're going to do the same thing for Ron and Hermione. Ron's grades are in the second row, the row with an index of 1. So once again, we use the first bracket, the array we're interested in, and then we can use the second bracket to index a specific element in row 1. Ron got a 65 in potion, a 64 in herbology, a 61 in arithmancy, and a 67 in charms. And we can replicate this logic for Hermione's grades. I can run my code, and everything works out. I hope you can appreciate that 2D arrays are perfect when you want to store a table of data. Instead of using multiple one-dimensional arrays to store each row individually, we can use a 2D array to store the entire table at once. I want to introduce a faster way of initializing 2D arrays, because the code is getting a bit long. Since we already know what the values are, we can create the array and define the values in one line. This code is going to create a 2D array with 3 rows of values. Each row is an array bundled in a 2D array. So we'll try this out in our code. Each row of data is basically an array, so we need one array to store Harry's grades, one array to store Ron's grades, and another to store Hermione's. Run our code. And everything works as it should. The code looks a lot better. Okay, so how do we access each value in a 2D array? Once again, we can access each value using the 2 indexes. If I want to access Hermione's grade in charms, the first index gets the array, it gets the row with all of her grades, and the second index gets the grade that we're interested in. So I'm going to wrap up this lesson by printing all of their grades as part of a string. Once again, we use the first bracket to specify the row that we're interested in. All of Harry's grades are in the first row, row 0, and his potions grade can be found in index 0 of the first row. His herbology grade is in index 1. Arithmancy index 2. And charms index 3. I can do the same thing with Ron, except that all of his grades are in the second row, row 1. And we can wrap up by doing the same thing with Hermione's grades. They're all in the third row, row 2. And that's perfect. You created an array that stores 3 rows of data, and then you accessed every value in this table using the indexes. We always start with the index of the array, followed by an index for the item inside. In this lesson, you learn to work with 2D arrays. A 2D array is an array that contains arrays. Each row of values is an array bundled in a 2D array. This makes them perfect for storing a table of data. That's because each array is like a row inside of a table, and you can access any value in the table using the indexes. The first index fetches the array that we're interested in, and the second index gets the element inside the array. As I mentioned before, arrays and loops are like siblings. If you want to run through the elements of a normal array, you can use a simple for loop. But what about a 2D array? In this case, you need a nested for loop. Oh yes, we finally get to use nested loops. In this lesson, you're going to use a nested loop to run through a 2D array. I want to start by looping through a single row in a 2D array. We know that each row is an array with a list of values. I want the array that holds Hermione's grades, so the first index needs to be 2. The first bracket indexes the row that we're interested in. The second bracket indexes the element in that row. As you can see, the first index is fixed at row 2, and the second index needs to start at 0 and go up until 3. So I can use a for loop that runs through every element inside row 2. This for loop starts at j equals 0. The loop is going to keep running as long as j is smaller than the length of row 2, and during each run, notice that the first bracket is fixed at row 2, and the second bracket is going to vary with j. So remove these print statements, and using loops, we can print the grades in rows 0, 1, and 2. So this for loop is going to start at j equals 0. The loop is going to keep running as long as j is smaller than the length of row 0. And during each run, we're going to print every value inside row 0. So the first bracket is going to be fixed at row 0, and the second index is going to vary with j. We can apply the same logic to run in Hermione's grades. We can make another for loop that starts at j equals 0. The loop is going to keep running as long as j is smaller than the length of row 1. And during each run, we're going to print every value inside row 1. So the first bracket is fixed at row 1, and the second bracket is going to vary with j. And for the sake of expediency, I'm just going to copy this loop and change it such that the loop is running through the length of row 2. And during each run, we're going to print every value inside row 2. Sweet, I think it's time to run the code. And everything works out. It prints every value from the 2D array. But instead of using print line, I'm just going to print everything in one line. Okay, now it's really hard to tell the values apart from the lack of space, so after printing each row of data, I'm going to add a new line. Much better. Now it's even more evident that each loop is running through an entire row and printing every grade in that row. But the output is still a bit cluttered, so I'm going to add a space after printing each grade. And we're making a lot of progress. Before we continue, I prepared an animation so that you can visualize how the code is working so far. This animation is a bit long, so if you feel comfortable with what we talked about so far, feel free to skip ahead. Okay, I hope this visual clarified any doubts you were having, but it seems like we need to write a for loop for each row. That can't be right. If there were 100 rows, are you going to write 100 loops? Of course not. This is why we use nested loops. It's not a good idea to have a loop for every row, because the loops are pretty much identical. So instead of creating one loop for every row, we need to use a nested loop where the outer loop runs through every row, and the inner loop runs through every item in that row. In a nested loop, I typically represents the row index, and j represents the element in the current row. This outer loop is going to keep running as long as the row index I is smaller than the length of our 2D array, which is the number of rows. The outer loop starts with a row index of 0, and then as we hit the inner loop, the row index I is fixed at 0 and the inner loop counter j is indexing every value in that row. After the inner loop runs to completion, the row index I increases by 1. And so once again, we hit the inner loop, the row index I is fixed at 1, and the inner loop counter j is indexing every value in that row. And finally, the counter I increases to 2, and as we hit the inner loop, the row index I is fixed at 2, and the inner loop counter j is going to index every value in that row. And then the outer loop breaks when I is no longer smaller than the length of our 2D array, when it can no longer index the rows. So now we can fix our code by printing the grades in every row using nested loops. The outer loop is going to start with a row index of 0. It's going to keep running until the row index traverses the length of our 2D array. And during each run, the outer loop is going to index a specific row. So I is going to start by indexing row 0, row 1, row 2, and once I equals 3, this condition is going to turn false. And so the inner loop is going to start at the first element in that row, j equals 0. And it's going to keep running until j indexes every element in the current row. And j++. And inside the inner loop, we can print the contents of our 2D array. The first bracket is going to index each row, and the second bracket is going to index every element in that row. Okay, we're making a lot of progress. Once again, I'm going to print everything in one line. And now we can add a new line after running through each row. So after the inner loop runs to completion, we know that we've just printed an entire row, so here we can add a new line. Rerunning our code. That is perfect. And now every time we index a grade value, we can add some space. And that's pretty good. I'm going to wrap up this code by printing the name next to each grade value. We know that Harry's grades are in row 0, Ron's in row 1, and Hermione's in row 2. So we can add a switch statement. And it's going to compare the outer loop counter, the row index I, against 3 cases. If it's the first run of the outer loop, we're going to print, not print line, print, and then we're going to add a tab of space, Harry. And don't forget to break your switch statements. If it's the second run of the outer loop, we're going to print Ron. And if it's the third run of the outer loop, we're going to print Hermione. And I think we're ready to run the code. And that is all. Hello, this is Rayanne. 3 years into the future, I decided that this lesson could benefit from some breakpoints, so I will add one at line number 9, and let's begin debugging. Alright, so we start off by creating a 2D array with 3 rows. The outer loop is going to start by going through row 0, Harry's grades. Okay, and here the inner loop is going to go through every single grade inside of row 0. The first grade at row 0 is a 72. The second grade at row 0 is a 74. The third grade at row 0, again, is a 78. The fourth grade at row 0 is a 76. The inner loop runs through every single element in the row, then we print a new line, and we start again. Now I++ is going to increase I to 1. Now we're going through the second row, row 1, Ron's grades. And this inner loop is going to go through every single grade for Ron, every single grade inside of row I, row 1. The first grade at row 1 is a 65. The second grade at row 1 is a 64. The third grade at row 1 is a 61 and a 67. After we're done going through every grade in the row, we print a new line. Alright, and now we are locked in at row 2, the third row, Hermione's grades, and the inner loop is going to go through all of Hermione's grades. We print the first grade inside of row 2, the second grade inside of row 2, the third one, and the fourth. And once we're done, we went ahead and printed all of the grades inside of our 2D array. And I will once again hand this presentation back over to Rayanne 3 years into the past. In this lesson, you ran through a 2D array with a nested for loop. The outer loop runs through every row. The inner loop runs through every item in that row. The outer loop starts with a row index of 0, and then the inner loop runs through every element at row 0. After the inner loop runs to completion, the outer loop increases the row index I by 1. The second pass starts with a row index of 1, and once again the inner loop runs through every element in that row. And then the third pass starts with a row index of 2 and runs the inner loop again. It's good to plan your code before you write it. In Module 1, we built surveys, games, and all kinds of apps. We never needed to plan our code around objects, so why should we start now? If you think about it, every app is more of the same. You make a few variables and then you call a function. But look closely. Variables work together to describe some sort of object, some sort of thing. In this case, these variables work together to describe a car. The function describes what the object does. A car drives. And now the more code you write, the more variables and functions you're going to have. Before you know it, your code's going to get really messy. But once again, notice that the variables are closely related. The second set of variables describe another car. The premise behind object-oriented programming is to find closely related variables and combine them into an object. For now, don't worry about the syntax, but I hope you can appreciate that grouping many variables into an object makes your code organized and easier to read. Don't take my word for it, compare the two codes. It's pretty clear that programming using objects results in higher quality code. In this lesson, you're going to learn how to plan your code around objects. Before you start coding, you need to plan your code around objects, and this involves 3 steps. Look for objects. In other words, look for things. Look for fields that describe each object. And look for actions that each object can perform. Okay, someone hired you to build a dealership application, and they gave you requirements. Now read the passage and try to identify objects, fields that describe each object, and actions that each object can perform. An object is a thing. An object is something that you can see or describe. After reading this passage, where do you see objects? There are two types of objects. We can classify them as dealership and car. Now, fields describe an object. In the requirements, we need to find closely related fields. Which fields work together to describe a car? It's pretty clear that the make, price, year, and color can describe a car object. But what would describe a dealership object? The cars. The dealership is identified by the cars that it manages. Now the next step is to find actions. An action describes what the object can do. Objects can do stuff. They can perform actions. Now in the requirements, look for actions that a car can do. A car can drive. Now look for actions that a dealership can do. A dealership can sell cars, and it can search for cars based on the make and the price. Now from the requirements, we can assume that a car object combines 4 fields and 1 action. The dealership object has 1 field and 2 actions. Alright, after planning your objects, you can start creating them. You found 2 types of objects, car and dealership. So how do we create the object? Let's take for example the car object. To create a car object, you need to write the type of object you're creating and pass in the fields that describe it. Using this format, you can create car objects such that each car is capable of driving. If you don't use objects, your code is going to look like this. So, if you want to write higher quality code, you need to program using objects. It makes your application organized. In this lesson, you learn to plan your code around objects. So first look at the requirements, and from the requirements, identify the objects, identify fields that describe each object, and then identify the actions. And in the end, this is the outline we came up with. There are 2 types of objects, dealership and car. The car object combines 4 fields and 1 action. The dealership object has 1 field and 2 actions. Creating a car object requires you to write the type of object you're making and pass in the fields that describe it. And using this format, we can create car objects such that each car is capable of driving. Objects make your code organized and easier to understand. Object-oriented programming means organizing your code around objects. And the purpose of object-oriented programming is to write high-quality code. In this lesson, you will create 2 car objects. Before we start, create a new folder, call it section 7. Inside the folder, create a file named main.java. And then make sure that your class has a main method. So your boss wants you to write code based on these requirements. And before you write a single line, step 1 is to identify the objects. We can define what an object is based on 2 criteria. An object is a thing that contains fields. And furthermore, an object is a thing that performs tasks. Take some time to remember these 2 bullet points. Now then, how many objects can you identify from this passage? I only count 1 type of object, car. So based on the first bullet point, which describes an object as a thing that contains fields, char is a thing that contains the fields make, price, year, and color. Going back to our criteria, an object is also a thing that can perform tasks. In this case, a char object can drive. So let's keep track of our progress. We identified one object, char. A char is defined by its make, price, year, and color. And furthermore, a char can drive. So that was step 1. You identified one type of object, char. Step 2 is to create a class. The class is a blueprint from which you can create an object. Previously, we identified that every char is defined by its make, price, year, and color. So based on these fields, we can create a blueprint. Our class, our blueprint, will declare that every single char needs to define a make, price, year, and color. Inside your project, create a new file called char.java. And inside the char class, we declare that every single char needs to define a make. It needs to define a price, a year, and a color. And that's all. The char class is a blueprint, and from this blueprint, we can create many char objects. And that's actually step number 3. From the char class, you will create char objects. The object will be of type char. Here we are creating a new object of the char class. The variable automatically stores a reference to that object. And once I create an object, I can modify its fields. So what we'll do in our code is, from the char class, from the blueprint that we just developed, we're going to create 2 char objects. The first object will be of type char. I will call the variable Nissan, and the Nissan variable will store a reference to a brand new object of the char class. This char object is automatically going to contain 4 fields. We can set the first field, the make, equal to Nissan. We can set its price equal to $10,000. We can set its year equal to 2020. And we can set its color equal to green. Let's visualize the runtime. Here we are creating a new object of the char class. And the variable Nissan stores a reference to that object, and the object's fields by default are going to start at 0 or null. Here we update that object's make to Nissan. Here we update its price to $10,000. Here we update that object's year to 2020, and here we update this object's color to green. And how easy was that? Using the same blueprint, I can create another object of the char class. I will call this variable Dodge. And the Dodge variable will store a reference to a brand new object of the char class. This brand new char object is going to have a make that equals Dodge. It's going to have a price that equals 11,000. It's going to have a year of 2019, and it will have a color of blue. And let us once again visualize the runtime. Press debug. Here we are creating a new object of the car class. This variable Nissan automatically stores a reference to that object. The object's fields by default start at 0 or null. Here we update that object's make. Here we update its price. Here we update its year. And here we update its color. Here we're creating another object of the car class, and the variable Dodge is going to store a reference that points to that object. The object's fields by default start at 0 or null, and once again we update every single field in that object. At this point, we successfully created 2 objects of the car class. And finally, we can print the fields of each object. The first object, if I hover over the variable that points to it, you can see has a make of Nissan, a price of 10,000, a year of 2020, and a color of green. So that's what's going to print. Beautiful. The second object, if I hover on the variable that points to it, has a make of Dodge, a color of blue, a price of 11,000, and a year of 2019. Let's just press continue. And that is exactly what prints. So to recap, you created 2 objects of the car class. A car class is a blueprint from which you can create concrete car objects. The constructor is the first thing that runs when you create an object. Having a constructor allows us to create the object and update its fields on the exact same line. This is a big improvement on our previous code where we created the object and then in 4 separate lines we updated its fields. This looks really disorganized. So it stands to reason that in this lesson, you will use a constructor to update an object's fields. The constructor runs as soon as you create an object. And the purpose of a constructor is to update an object's fields. Let's go through the process. Step 1 is to create a constructor that defines 4 parameters. And to make a constructor, you need to specify the level of access, which tends to be public, the class name, followed by parameters. In step 2, you have to call the constructor while creating a new car object. New car creates a new object of the car class, and while creating the car object by passing in 4 arguments, you're calling the constructor that expects to receive 4 parameters, and inside of the constructor is where you should update the newly created object's fields. And that's why step 3 is that the constructor must update the object's fields. The keyword this refers to the current object. The purpose of this is to distinguish between fields and parameters. You'll notice here that the parameters have the exact same name as the object's fields. So we can use the this keyword to refer to the current object, the object that called the constructor, and it follows that this.make refers to the field in that object. And we can set that field equal to the make parameter. In turn, we can set every field equal to the parameter that was passed in. And that's all. Once the constructor is done updating the objects as fields, the object has been fully initialized and our variable will store a reference to it. Alright, let's put all of this into code. Step 1 was to create a constructor that defines 4 parameters. The constructor will be public, and the constructor will get called whenever we create objects of the char class. And whenever the constructor gets called, it's going to expect 4 parameters to be passed in. It's going to expect a make, a price, a year, and a color. Step 2 is to call the constructor while creating a new char object. So now that we've created our own constructor, Java is going to expect us to call it after we create a new char object, and we can call the constructor by passing in an equal number of arguments. We will pass in a make of Nissan, a price of 10,000, a year of 2020, and a color of green. And now instead of updating the object as fields in 4 separate lines, the constructor is going to do it in a single line. And do the same thing over here. After we create a new object of the char class, we want the constructor that expects 4 parameters to get called. So here we're going to pass in 4 values. Dodge, 11,000, 2019, and blue. And now instead of updating the object as fields in 4 separate lines, the constructor is going to do it in a single line. Looking good. And now step 3 is for the constructor to update the objects as fields. Every object that we define from the char class, it's going to have a field that matches a parameter in the constructor. So what we can do to distinguish between them is say this. So this refers to the current object that's calling this constructor, which means that this .make refers to the field in that object. And here we can set the current object's field equal to the make that gets passed in. Here we can set the current object's price field equal to the price value that gets passed in. Here we can set the current object's year field equal to the year value that gets passed in. And here we can set the current object's color field equal to the color value that we pass into our constructor. And that's really it. Whenever we create a new object of the char class, the constructor that expects to receive 4 values is going to get called, and it's going to update every single field in that object. This is looking really good. Let us visualize the runtime to see this in action. So here we're creating a new object of the char class. If I press step inside, it's going to step inside the constructor that expects to receive 4 values. The make is Nissan, the price is 10,000, the year is 2020, and the color is green. You can also visualize the parameter values over here. This points to the current object that we just created, the new char object. By default, all of the fields start at 0 or null. So inside the constructor, we set every single field inside of the current object equal to a parameter. This.make equals make. This.price equals the price value that we passed in. This.year equals the year value that we passed in. And this.color equals the color value that we passed in. Alright, once the constructor is done updating the object as fields, the object has been fully initialized. So now our variable Nissan is going to store a reference to it. And now here once again we're creating a new object of the char class. If I press step into, it's going to step inside the constructor that expects to receive 4 values. This refers to the current object that we just created. Here we can see the parameter values that were passed in. Here we're setting this.make, the current object's make field, equal to the make value that we passed in, Dodge. Here we're setting the price field of the current object, this.price, equal to the price that we passed in, 11,000. Here we're setting the year field of the current object, this.year, equal to the year value that we passed in. And here we're setting the color field of the current object, equal to the color that was passed in, blue. And once the constructor is done updating the current object's fields, now the object has been fully initialized, and our Dodge variable will store a reference to that object. So now we've got two variables. Each variable stores a reference that points to a brand new object. And here we can print the field values of each object. So our Nissan has a make of Nissan, a price of 10,000, a year of 2020, and a color of green. That is exactly what should reflect in our print function. Here we print every single field of the object that our Dodge variable points to. So this object is going to have a make of Dodge, a color of blue, a price of 11,000, and a year of 2019. And that's really it. In this lesson, you used a constructor to update an object's fields. New car creates a new object of the car class. By passing in 4 values, we call the constructor that expects to receive 4 parameters. This points to the current object, the newly created object that called the constructor. So this .make refers to the field in that object, and we can set that field equal to the make parameter. And we can set each field in the current object equal to the parameter that was passed in. And that's really it. Once the constructor is done updating the object's fields, the object has been fully initialized, and our variable will store a reference to it. In this lesson, you will add getters to the car class. You might be wondering, everything is working nice and perfect. Why are we adding getters? The issue with this syntax is, let's just say my intention is to just access the object's make field. Well, using this same syntax, I could accidentally update this field to be Toyota, when in fact it should have a string called Nissan. So having direct access to an object's field is not very safe, and it's considered very, very bad practice, which is why we have to make every single field private to the car class. So private means that the field is private to the class that it was defined in. It is not visible anywhere else. So if we go back to main.java, here we're trying to directly access the make field, but the make field is not visible. Each field is private to the class that it was defined in. It is not visible anywhere else. The thing is, I still need to print the Nissan object's fields, so how can I get all of its field values? So while the fields are private, a getter is a public method whose return type depends on a particular field, and it's always going to be called get followed by the name of your field. Again, using camel case. And what it will do is return the field of the current object that calls this method. Now we'll create another getter. This one needs to return a double. It will be called getPrice. And it will return the price field of the current object that calls this method. Now notice we don't need to say this.make or this.price because there is no conflicting parameter. Java is smart enough to return the make field of the current object that calls this method. Now we're going to need another getter. This one will return an integer. It's going to be called getYear. And it needs to return the year of whatever object calls this method. The final getter we need to declare is one that returns a string. It will be called getColor, and it needs to return the color field of whatever object is currently calling this method. So now what we have is perfect. Our fields are safe, sound, and private, and each field has a public getter that returns a copy of its value. So now we're good to go. Here, because we no longer have direct access to an object's field, what we can do is call its getter. So Nissan.getMake, Nissan.getPrice, Nissan.getYear, and Nissan.getColor. We can do the same thing here. From the Dodge object, we can call getMake. Here we can call getPrice, getYear, and getColor. Okay, I'm going to add breakpoints inside every getter because it's going to be really hard pressing the step into button when we're already inside the printline function. So we'll put breakpoints here. So at this point, we've created two new objects of the car class. Each variable stores a reference to that object. First, we call getMake for this object. This refers to the current object that's calling this method, and here we return the make field of that object. The second getter that gets called was getPrice, which is going to return the price field of the current object. The third getter that gets called is getYear, which is going to return the year field of the current object. And the fourth getter that gets called is getColor, which is going to return the color field of the current object. If I press next, it prints every single field inside of the Nissan object. And now once again, we call getMake, getPrice, getYear, getColor, but we're going to call these getters for this object. And so once again, this points to the current object that's calling this method. That object's make is Dodge. That's what's going to get returned. Here we return the price of the current object. Here we return the year of the current object. And here we return the color. And that's it. So to recap, you should always use getters to access your objects' fields. In this lesson, you will add setters to the char class. Currently, we have no way of updating an object's field because they were made to be private to the class that they were defined in. So that's why we need to add some public setters. So here we say public, void, and a setter is always going to be called set followed by the field name. A setter does expect to receive a parameter whose type depends on the field itself. So this is going to receive a make value, and it's going to set the field in the current object that's calling this setter, this.make, equal to the make value that gets passed in. So notice here we do need the this keyword to distinguish between the field and the parameter that gets passed in. Whereas in the getter, there are no parameters, so make will automatically refer to the object's field. Alright, so now we will add another setter that is available to the public. This one will be called setPrice. It's going to receive a double price, the same type as your price field, and when this setter gets called, it's going to set the price field of the current object equal to the price value that gets passed in. Alright, now we're going to need another setter, public void. This one will be called setYear, and it's going to receive a year value. We can reference the current object that calls this method using the this keyword, and we can set its year field equal to the year value that gets passed in. Finally, we need one more setter. Here we'll say public void. This setter will be called setColor, and its responsibility will be to update the color field with whatever color value gets passed in. And the current object that calls this setter, we're going to set its color field equal to whatever color value gets passed in, and that should be all. And now, even though our fields are private, we have public getters to return the fields as value, and we have public setters to update them. So here what I'll do, before printing the object's fields, we'll update the color of this object. So here we'll say Nissan.setColor, and we're going to update its color to jet black. And we'll do the same thing for this object. We will say Dodge.setColor, and we're going to give it a color of jet black as well. Alright, and you know what? Let's just say the dealership is having a 50% off sale. What we'll do is we'll say Nissan.setPrice, and we're going to set its price field equal to the current price divided by 2. We can do the same thing here, Dodge.setPrice. That's going to equal the current price of the Dodge object divided by 2. Alright, I'm going to need breakpoints in setColor, setPrice, and getPrice. I'll put 4 breakpoints here, and we're good to go. So at this point, we have 2 char objects. The first thing we'll do is from this object, we're going to call setColor. So here, this points to the current object that called this method, and here we're setting this.color equal to the color value that was passed in, jet black. Alright. Now we're calling setColor from this object, the object with a reference of 11. We can step inside. This points to the current object that called this method, and here we're setting this.color equal to the color value that was passed in, jet black. Alright. So at this point, we've updated both of our objects as color fields. And now here, Nissan is going to update its price field by first getting its current price. So getPrice is going to return the price field of the current object. So 10,000 divided by 2 means we're passing 5,000 into setPrice. This points to the current object that's calling setPrice, and we're setting this.price equal to 5,000. Alright, going to the next breakpoint. Here we're setting the price for this object by getting its current price divided by 2. So first we're going to go to get price. Get price is going to return the price value of the current object that's calling it 11,000. The value returned is 11,000. That divided by 2 is 5,500. That's what's going to get passed into set price when an object with a reference of 11 calls it. This points to the current object that called set price, and here we're setting this dot price, the current object's price field, equal to 5,500. So at this point, we have fully updated both objects, the object with a reference of 10, the object with a reference of 11, and here we're just printing all of the fields. I don't want to step inside of get price again, so let me just remove all of my breakpoints. And we are done. So this recap is fairly simple. You should use setters to update your objects' fields. In this lesson, you will generate getters and setters. Go to the extensions marketplace, and then there, look for the Java Code Generators extension. Once you do, install it, enable it, do whatever you have to do. I already have it installed and enabled. And just to be on the safe side, close your editor and reopen it. Once you do, what we're going to do is delete all of the getters and setters that we've made so far. And now we can just right-click, say Java Code Generators, and click on Generate Getters and Setters. And now you'll notice that when you generate your getters, it uses this .make when you really don't need to. Because the purpose of this is to distinguish between the field of the current object that's calling this method and the parameter that gets passed in. Here, if you just say return make, it's automatically going to return the field of the current object that calls getMake, but it's also good practice to put the this keyword anyway. So you can remove the this keyword, you can leave it, doesn't really matter in this context, but because that's what was generated, we're going to leave it. That being said, I am rarely ever going to use the Java Code Generators extension in this course because I want you to get used to writing your own getters and setters. I think it's really good practice. So this will probably be the last time that you see me using the Code Generators extension. But if you really want to use it yourself, then knock yourself out. In this lesson, you generated getters and setters. In this lesson, you will add a copy constructor to the char class. Our current constructor is working just fine, so why do we need to add another constructor? You need to know what a mutable object is. A mutable object is an object with setters. Here, as you can see, the char class has setters, which means that every single object of this class is going to be mutable. After we create each object and use the constructor to initialize its fields, we can still update these fields courtesy of our setters. Here is where things get messy. When dealing with mutable objects, avoid setting variables equal to each other. You will fall into the trap where both variables will share a reference to the same object. New char creates a new object of the char class. While creating the char object by passing in 4 arguments, you're calling the constructor that expects to receive 4 parameters. And inside the constructor, we update the newly created object as fields because the this keyword refers to the current object, the object that called the constructor. And here we set every single field in the current object, the object that we just created, equal to a parameter value that was passed in. And that's all. Once the constructor is done updating the object as fields, the object has been fully initialized, and our variable will store a unique reference to it. Now if I declare another variable of type char and set it equal to the first one, here we're not creating a new object. All we're doing is copying over the reference. Now both variables share a reference to the exact same object. The problem is now I can update one object through two variables. This is an imbalance and it's a very big problem. Before we continue, there is a text file inside of your resources folder. Please download it. And once you download the file, delete the following code and copy the file's contents over here. The Nissan variable stores a reference that points to this object, and by declaring another variable of type char and setting it equal to the first one, all we're doing is we're copying over the reference. Both of these variables are going to share a reference to the exact same object. So what do you think is going to happen over here? Let's visualize the runtime. Let's put one breakpoint here, here, and here. Here we are creating a new object of the char class, and the variable is going to store a unique reference to that object. But here we are not creating a new object. All we're doing is we're copying over the reference. Now both variables share a reference to the exact same object, which means now I can update one object through two variables. When dealing with mutable objects, you should avoid setting two variables equal to each other. You will fall into the trap where both variables store a reference that points to the exact same object. Let's remove all the breakpoints. So what we're going to do is create a copy constructor. And here is the process. Step 1 is to create a constructor that defines one parameter. So inside of your char class, like any other constructor, like the one we have over here, you need to specify the level of access, which is going to be public, followed by the class name, because they'll be creating objects of the char class. But the copy constructor, unlike this one, is going to get invoked when they pass in one parameter upon creating the object. And that parameter has to be of type char, which we're going to call source. Step 2 is to call the constructor while creating a new char object. So here, new char creates a new object of the char class, and while creating this object, we could either pass in 4 arguments or we could pass in 1 argument. Since I want to call the copy constructor, I'm going to pass in 1 argument, an argument of type char, which means upon object creation, we're going to be calling the constructor that expects to receive 1 char parameter. And inside of the constructor is where you should update the newly created objects as fields. So that's why in step 3, the constructor must update the object as fields. The this keyword refers to the current object, the object that's going to be calling the constructor. The source parameter is going to refer to the object that's being passed in. And here we set every single field in the current object, the object that was just created, equal to a field value from the source object, the object being passed in. So we'll set the price field in the current object equal to the price of the object being passed in. We will set the year field of the current object equal to the year field of the object we pass in. And we're also going to copy over the color field. And that's all. Once the constructor is done updating the current object as fields, that object has now been fully initialized and our variable will store a unique reference to it. Once again, I'll put breakpoints and let's visualize the runtime. Here we're creating a new object of the car class, and the Nissan variable stores a reference of 15 that points to this object. And now here, once again, we are creating a brand new object of the car class, and we're passing in one argument of type car. If I press step inside, it's going to step inside the constructor that expects to receive one parameter of type car. This points to the current object that we just created, the new car object. And source references the object that we passed in, the one that had a reference of 15. And here we're setting every field in the current object equal to a value from the source object. And once the constructor is done updating the current object's fields, now the object has been fully initialized, and our Nissan2 variable is going to store a reference to that object. Here I'm updating the object with a reference of 25, and now here I'm updating the other object that has a reference of 15. You added a copy constructor to the car class. When dealing with mutable objects, objects that have setters, you should avoid setting variables equal to each other. You will fall into the trap where both variables share a reference to the same object, and then that one object can be updated through two variables. Instead, you should create a brand new object of the car class and call the copy constructor. In this lesson, your cars will quote-unquote drive. We identified earlier that every object of the car class should contain 4 fields. Rightfully so, we defined 4 fields inside of our car class, but every car can also perform the task of driving, so we need to now add a method inside of our car class called drive. It's going to be a void method, and it's not going to expect any parameters. And when a car drives, we're just going to print the following message. You bought the beautiful. Then we're going to print that car's year, followed by some empty space. We'll print that car's color, followed by some more empty space. Then we'll print that car's make. You bought the beautiful some car for some amount of price. Period. Then we're also going to print, please drive your car to the nearest exit. Alright, let's clean up a little over here. I'm going to delete all of these mutations. I will put this at the very end. And instead of printing these 2 messages, I'm just going to call Nissan2.drive. I'll put a breakpoint, visualize the runtime. So here we're calling the drive method from this object, this Nissan. I'm going to step inside of it. This points to the current object that's calling this method. So here we're printing that object's year, that object's color, that object's make, and its price. And that's really it. Now, do note that we don't actually need to put the this keyword over here. We should observe the same result. Again, the drive method is being called by the following object. This points to the current object that's calling this method, and year, color, make, and price are referencing the year, color, make, and price fields of whatever object is currently calling this method. So here we're still printing the current object's year, price, make, and color. Let's add the this keyword anyway. It doesn't hurt. In this lesson, you added a drive method to the car class. Nothing special. In this lesson, you will add another field to your car class. Your boss updated the requirements, and now he wants every car to contain a make, price, year, color, and a parts field. So we're going to have to make some changes to the car class. Alright, let's follow our boss's requirements. We're going to add a parts field over here, string parts, such that every single object of this class is going to have 5 fields, which means we need to update the constructor. So let's just go ahead and use Java code generators, generate a constructor using all fields. So whenever we create a new object of the car class, we are now expected to pass 5 values so that we can call the constructor that expects to receive 5 parameters. That way the constructor can set every single field inside of the current object that's being created equal to a value that gets passed in. We will pass in all of the appropriate values momentarily, but for now, whenever we create a new object of the car class, passing in a source object, the copy constructor is going to get called. So we need to set the parts field of the current object, and we can add our respective getters and setters by using Java code generators, getters, and setters. Now you might be wondering, why did I use Java code generators even though I promised to never use it again? That's because I want to warn you that the code that was generated for you is a little bit dangerous. Before I explain why, what I want to do is set one variable called spare parts equal to a new array that stores 2 elements. It's going to store spare tires and, I don't know, spare keys. And here I need to pass in a 5th argument so that we can call the constructor that expects to receive 5 parameters, and we should be good. Now, I know that you're used to writing this instead, but this is just a shorter way of specifying that you're creating a new string array. And from now on in this course, this is the syntax that we're going to use to initialize arrays in a single line. Alright, now that we're all set up, I want to mention that arrays in Java are mutable objects. So here I'm initializing an array that contains 4 elements. And you should know by now that the new keyword means that you're creating an object. This code creates a new object of the string brackets class. And when you're dealing with arrays, instead of initializing fields, you're initializing elements. This array object has 4 elements. And what makes an array a mutable object is that you can still update its elements after it's been created. And ultimately, our variable stores a reference to this array. Alright, so knowing that arrays are ultimately just mutable objects, when we're dealing with mutable objects, we should avoid setting variables equal to each other. We're going to end up in a scenario where two variables share a reference to the same object. So going back to our code, here we are committing a crime of setting the two variables equal to each other. We're doing the same thing here. All we're doing is passing references around, which is very, very dangerous. Here we're returning a direct reference to the parts array, and here we're setting two variables equal to each other. So we've added our parts field, but there is a lot of stuff that we need to fix, and we'll be doing that in the next 4 videos. In this lesson, you added a parts field to the char class. We established that arrays are mutable objects, and when you're dealing with mutable objects, you should avoid setting variables equal to each other, because you're going to end up in a scenario where two variables share a reference to the same object, and that is the reason why in the next 4 videos we're going to fix our constructors, getters, and setters. In this lesson, we're going to fix the constructor. We established that arrays are mutable objects, and when you're dealing with mutable objects, you should avoid setting variables equal to each other, because you're going to end up in a scenario where two variables share a reference to the exact same object. Before I visualize the runtime, what I'm going to do is update the element at index 0 of the spare parts array, and instead of spare tires, I'm going to set it to a spare filter. Okay, and now let's visualize the reference trap in action. So here I'm creating a new object of the string class. I'm creating a new string array that has 2 elements, tires and keys. The variable spare parts stores a reference to this array. Here I'm creating a new object of the char class. Because I'm passing in 5 arguments, it's going to call the constructor that expects to receive 5 parameters. This points to the current object that we just created, the new char object, and here I'm setting every single field in the current object equal to a parameter value. Now everything is business as usual until we get to this .parts. The parts parameter stores a reference to the array that was passed in, so here all we're doing is we're copying over the reference. So remember the reference at 10. Same thing over here, we're creating a new object of the char class, passing in 5 arguments. In the 5th argument, we're passing in a reference to the following array, a reference of 10. Again, updating the current object is business as usual until we get to this .parts equals parts. Here we're just setting our parts field equal to the reference that is stored inside of the parts parameter. Alright, and here is the issue. The parts field in each object, as well as the outside variable, they all share a reference to the exact same array. So by updating the array through the outside variable, everything else gets affected as well. This is really, really bad. And so what we'll do is we're going to set our parts field equal to a copy of the array that gets passed in. So we'll set it equal to arrays.copyOf. The copyOf method is going to return a copy of the parts array, and we're going to copy the full length of the array. And now, let me put that back, rerun our code. So here we're creating a new object of the string brackets class, a new string array that stores 2 elements. Our variable spare parts stores a reference to that array. Here we are creating a new object of the char class, passing in 5 different arguments. In the 5th argument, all we're doing is we're passing over a reference. And so the constructor that expects to receive 5 values is going to get called. And here we're updating every single field inside of the current object, the object that was just created. And here arrays.copyOf is going to create a brand new array based on the one that was passed in. And so our field is going to store a unique reference to that new array, which is perfect. Now we create another object of the char class passing in 5 arguments, which means the constructor that expects to receive 5 parameters is going to get called. Here we update every single field inside of the current object that was just created. So we're going to update the object as make, its price, its year, its color. The parts field is going to store a unique reference to a brand new array that gets created by arrays.copyOf. And this is looking really good. Now, if I look at the outside variable spare parts, if I look at the Nissan object as parts field, if I look at the Dodge object as parts field, each of them stores a unique reference to their own array, which means making this update here is only going to update the array with a reference of 10. This one. The new array copy with a reference of 28, the new array copy with a reference of 32, they are not affected because we followed this one golden rule. When you're dealing with mutable objects, and arrays are mutable objects for reasons that we explained in the previous video, you should never set 2 variables equal to each other. Otherwise, you'll end up in a scenario where 2 variables share a reference to the exact same object. In this lesson, you fixed your constructor. In this lesson, we're going to fix the copy constructor. We determined that arrays are mutable objects, and as a result, you should avoid setting variables equal to each other. Otherwise, you're going to end up in a scenario where more than one variable share a reference to the exact same object. Before we start, defining this variable was just for demo purposes. What I can do is just create a new array and then pass it in ad hoc. And now let's visualize the runtime. It wouldn't hurt to revisualize the creation of these objects, so let's just jump right into it. Here we're creating a new object of the char class, and into the constructor we're passing in 5 arguments. The 5th argument is a new string array. Because we passed in 5 arguments, the constructor that expects to receive 5 parameters gets called, and the parts parameter stores a reference to the array that was passed in. Alright. And this points to the current object that was just created, and here we're setting every single field inside of the current object equal to a parameter value. We're looking good. Here once again we're creating a new object of the char class. Into the constructor we're passing in 5 values, so it follows that the constructor that expects to receive 5 parameters gets called, and here we update every single field inside of the current object. And here a copy of the array that was passed in is created, and our field is going to store a unique reference to this brand new array. Alright. Here we're creating a new object of the char class. Because we're passing in 1 argument of type char, the constructor that expects to receive a char parameter is going to get called. This points to the current object that was just created, the new char object, and source points to the object that was passed in. Here we are setting every single field in the current object equal to a value from the source object, and now the source object's parts field stores a reference to its array, which means here all we're doing is we're copying over the same reference. That's not good because the new object we just created as well as the source object, now they both have fields that share a reference to the exact same array. This is not good. So here we see Nissan 2's parts field stores a reference of 20, and now Nissan's parts field stores a reference to the exact same array. And if I were to update this array through one of their setters, both Nissan and Nissan 2 are going to get affected, and this is not good. We fell into the reference trap. Now I'm not going to bother updating one of their fields. We know what's going to happen. The solution to the reference trap is when you're dealing with mutable objects, avoid setting variables equal to each other because you're going to end up in a scenario where 2 variables share a reference to the same object. So here, instead of just copying over the reference, we will say this dot parts is equal to arrays arrays.copyOf. What arrays.copyOf will do behind the scenes is create a brand new array based on the source object's parts field, and we're going to copy the full length of the array. Alright, if we revisualize the runtime, we should have bypassed the trap. So here we create a new object of the car class. The object's going to end up having 5 fields. The parts field stores a reference of 19 to its array, and we don't care about the dodge object. Here we're creating a new object of the car class whose values are going to derive from the object that Nissan points to. So because we're passing in one argument of type car, we're going to call the constructor that expects to receive one car parameter. This points to the current object that's calling this constructor, the one that was just created. Here we update every single field in that object. And now what arrays.copyOf is going to do is it's going to create a brand new array based on source.parts, to which our current object's parts field will store a unique reference to. And just like that, we fixed our copy constructor. Everything is back to normal. Every single object has a parts field that stores a unique reference to its own array. In this lesson, we fixed the copy constructor. Now we just gotta fix the getter and setter. In this lesson, we're going to fix our getter. We determined that arrays are mutable objects, and as a result, you should avoid setting variables equal to each other. Otherwise, you're going to end up in a scenario where more than one variable share a reference to the exact same object. The parts field is going to store a reference to some array, and here our getter, by returning this.parts, all we're doing is we're returning a direct reference to that array, which is pretty dangerous. So here, what if I set an outside variable, string car parts equal to Nissan.getParts. And then what if I change the car part at index 0, and instead of tires, it's going to be, we'll just go with the usual filter. What do you think is going to happen? So here we're creating a new object of the car class. Inside, we're passing in 5 values, which means we're going to call the constructor that expects to receive 5 parameters. Here we set this.make equal to the make that was passed in, the price to the price, let's visualize it, the year to the year. Here we update this.color to the color that was passed in. And here we're creating a copy of the array that was passed in, and our parts field is going to store a unique reference to that new array. Okay, we're looking good so far. And now our Nissan variable stores a reference to the object that we just created. From this object, we are calling getParts. This points to the current object that just called getParts. And what getParts is going to do is return this.parts. And all it's really doing is returning a reference to an array. It's going to return the reference of @28. And that's really dangerous because now the outside variable car parts and the Nissan object's field parts, both of them share a reference to the exact same array. And now by updating the array from our outside variable, our Nissan object gets affected as well. And this is really bad. The state of our object should not be updated because we changed an outside variable. This is just a recipe for bugs. So instead of returning a direct reference to our parts array, what we're going to do is use the arrays.copyOf method to create a copy of this array, and we will copy the full length of the array. And as the copyOf method creates a brand new array, we're returning a unique reference to that. So now we should be safe. Let's try it out again. Our getter should be bulletproof. Here, once again, we're creating a new object of the car class, passing in 5 values. The constructor that expects to receive 5 parameters will get called. Here we update that object as make, price, year, color. And here we create a brand new array that is a copy of the one that was passed in. And that parts is going to store a unique reference to that copy. So our constructor is good. From that same object, we are calling getParts. This points to the current object called getParts. Here, instead of just returning this.parts, we're creating a copy of the following array, and then we're returning a unique reference to that. Alright, and here we can see that getParts returned a unique reference to a copy of the following array. And because these are two separate arrays, updating our car parts should have no effect on our Nissan object, and we are good to go. So our getter is all good, which means in the next video we're going to fix our setter. In this lesson we're going to fix our setter. Let's go ahead and delete all of this. And I'm not even going to bother visualizing the reference trap for set parts because our mistake is very obvious when you consider that an array is ultimately a mutable object. And when you're dealing with mutable object, you should avoid setting the variables equal to each other. Otherwise, you're going to end up with two variables sharing a reference to the same object. Here, as you can see, we're setting our field directly equal to whatever parts variable gets passed in. All that's going to do is copy over the reference. That is no good. Instead, we're going to create a copy of whatever array we get. We're going to copy the full length of the array. And then our parts field is going to store a unique reference to the brand new array copy. If you want, you can feel free to create a car parts variable, pass it into your setter, see what happens, visualize the runtime, but I'm just going to move on. In this lesson, you will add a toString method to the car class. Before we start, remove this setter as well as the drive method. We understand what they do. And what I'm going to do is print the first variable. We'll print Nissan. And what do you think is going to happen when you just print the car variable? Let's find out. It prints the class from which the object was created, car, followed by an @ symbol, followed by a string that represents a hash code. This seems kind of random. Why does it print this? Let's put a breakpoint right over here and find out who the culprit is for this string that's being returned. So if I keep stepping inside, eventually we'll find out who is responsible for this. And here it is, the toString method. The toString method is going to return a string, and that string is going to be the class name of whatever object is currently being printed, followed by the @ symbol, followed by a string that represents a hash code. So Java is going to print whatever toString returns. So here you'll see that toString returns the class name from which our object was created, followed by an @ symbol, followed by a string that represents a hash code, and what the toString method returns is exactly what gets printed. And because Java prints the result of the toString method, we can actually use that to our advantage. What we're going to do is copy this method over here. And now, whenever I print any objects of the car class, Java is going to end up using the result from this toString instead of the default one. So we overrode the default toString method. Let's just test our theory. I'm going to put a breakpoint right here. And I'm going to put a breakpoint right here. Here we are printing something of type car. So because we have a toString method in our car class, Java is going to end up printing the result of that instead. My hunch was correct, but instead of printing the class name followed by the @ symbol and a string, I want to print something more descriptive. Once you do, copy its contents over here. All this is doing is it's printing every single field inside of the current object that's being printed. All right. So here, because we're printing something of type char, it's going to print whatever toString returns for that object. Here, if I print the object that belongs to Dodge, Java is going to print whatever toString returns for that current object. And if I print the car object that belongs to Nissan 2, Java is going to print, once again, whatever string toString returns for that object. Let's visualize the runtime. Now, before I do anything, let me put my breakpoint over here. Here I'm printing the car object that belongs to Nissan, which means the toString method from the car class is going to get called, and Java's going to print whatever that toString method ends up returning, which in this case is a string representation of every single field in this object. Perfect. Here, once again, by printing the car object that belongs to Dodge, Java's going to call the toString method from the car class, and the toString method is going to return a string that represents every single field in the current object that's being printed. Java ends up printing that string, and here I'm just going to press continue. Continue, we get the point. Now, what we basically did was we overrode the default toString method for objects of the car class. And actually, if you were to use the Java code generators extension and say generate me a toString, you'll notice that there's an override annotation. Because we are quote unquote overriding the default toString, I don't want to get into what override is just yet. That's something we're going to cover in the inheritance section. So for now, just know that as long as you follow the exact same signature that is inside of the all-encompassing object.class, then you are in a sense overriding the default toString. If you want to use Java code generators, by all means feel free, but I'm not going to cover override until we get to the inheritance section. In this lesson, you added a toString method to the car class, which is perfect because what the toString method returns is exactly what gets printed. So your boss just updated the requirements. Now we have a dealership that sells many types of cars. So I count another type of object, a dealership. That dealership contains many cars that it's going to sell. All right, so now we're ready to create a new object of the dealership class. Once you do, please copy its contents inside of your main method. Alright, so if I were to visualize the runtime, press debug. Here we're defining a new array that stores 1, 2, 3, 4, 5 car elements. The cars variable stores a unique reference to this array, and each element in this array stores a reference to a car object. The element at index 0 stores a reference to the Nissan. The element at index 1 stores a reference to the Dodge car object. The element at index 4 stores a reference of 21 to the Mercedes object. And now what we need to do is fill a dealership with cars from this array. So we'll start by creating a new dealership.java file. And every object of the dealership class is going to contain an array that can store elements of type car, and we're going to call the field cars. And every class needs a constructor, so let's go ahead and generate it. Generate a constructor using all fields. This constructor is going to get called whenever a new object of the dealership class is created, and upon object creation, an array of cars needs to get passed in. So let's do just that. Here I will create a dealership variable that stores a reference to a new object of the dealership class, And upon creating this dealership object, we're going to pass in an array of cars. And before we visualize the runtime, you'll remember that arrays are mutable objects. And when dealing with mutable objects, you should avoid setting variables equal to each other because you're going to end up in a scenario where two variables share a reference to the exact same object. In this case, we're setting two variables directly equal to each other, which means we are prone to the reference trap. Let's visualize the trap in action. What I'm going to do is from the cars outside variable, I'm going to update the element at index 3 of the array. And instead of a Honda, I'm going to set it equal to a Hyundai. Now, in a perfect world, this change should only affect the following array, and the state of our dealership should remain unaffected, but unfortunately, that's not how things are going to work out. So cars is going to store a reference to an array. Each element in this array stores a reference to a car object. Here, as I create a new object of the dealership class, I'm passing in an array of cars, which means the constructor that expects to receive an array of cars will get called. And unfortunately, by setting our field equal to the cars parameter, all we're doing is we are copying over the reference. And this is looking pretty bad because if I continue, our cars field shares a reference to the exact same array as the outside variable. And if I update the element at index 3 of our array from the outside variable, our dealership is going to get affected as well. This is not good. The state of our dealership should not change because we updated a variable from the outside. So you would think, okay, let's just say this.cars is equal to a brand new copy of whatever original array gets passed in, and we're going to copy the full length of the array. Unfortunately, we're still going to be stuck in the reference trap, and let me show you why. Here, what I'm going to do is say cars at index 3. And I'm going to set its color to blue. All right. Let's visualize the runtime and see why we're still stuck in the trap. Now, I really want to emphasize that every single element in this array stores a reference to an object. And namely, the element at index 3 stores a reference of 15 to a car object. All right. Here I'm creating a new object of the dealership class. And because I'm passing in an array of cars, it's going to end up calling the constructor that expects to receive an array of cars. And arrays, arrays.copyOf, it is indeed going to create a brand new array to which our cars field will store a unique reference to. The flaw is that the array that it creates is an exact copy of the original. So every single reference that the original array stores gets copied over. Here, the element at index 0 of our cars field and the element at index 0 of our cars parameter, they share a reference to the exact same car object. This is not good. And so after we've created our new dealership object, the dealership variable will store a reference to that object. Unfortunately, the element at index 3 of our cars field and the element at index 3 of our outside variable, they share a reference to the exact same object. So by updating the object with a reference of 15 from the outside variable, the state of our dealership is going to get affected as well. This is very unfortunate. Instead of relying on arrays.copyOf, we're going to copy over every single element ourselves. We're going to say this.cars is equal to a new array that can store elements of type car, and the length of this array is going to depend on the length of the cars array that gets passed in. Alright, now we need to update every single element inside of this array. So for int I is equal to 0, I is smaller than this.cars.length. We need to run through its full length, I++. First, what we can do is access the element at index I, and that element is going to store a unique reference to a new car object. Here we're creating a new car object. We want to call the copy constructor upon object creation because this new car object is going to derive all of its values from the object at index I of our car's parameter. And this is what you call a deep copy. Alright, now we should have bypassed the trap. Let us visualize the runtime. So here our car's outside variable stores a reference to an array of car objects. Here we're creating a new object of the dealership class, passing in this same array. First and foremost, we set this .cars equal to a brand new array that shares the same length as the one being passed in. So right there, we bypass the first part of our trap in that the cars field stores a unique reference to its own array, but now we need to populate every single element with an object. So here we start at I equals 0, and we set the element at index 0 of our cars field equal to a brand new object of the car class. And because we're passing in the car object at index 0 of our parameter, the copy constructor is going to get called. This points to the current object that we just created, the new car, and source points to the element at index 0 that we passed in from our car's parameter, and here we update every single field in the current object equal to a value from the source object. And now the element at index 0 of our car's field is going to store a unique reference to a brand new car object. Perfect. Now I equals 1. So here we're indexing the element at index 1. Once again, we're going to set that equal to a new object of the car class, and we're passing in the car at index 1 of our car's parameter as an argument, which means the constructor that expects to receive one car is going to get called. This points to the current object that we just created, the new car object. Source points to the car object that we passed into our constructor, and here we set every single field inside of the current object to a value from the source. Perfect. And now the element at index 1 is going to store a unique reference to the new car object we just created. Now I equals 2, which means we're indexing the third element from our car's field. We're once again setting that equal to a new object of the car class. Whenever you create a new car object, one of your car constructors is going to get called. And because you're passing in one argument of type car, in this case, we are passing in the Nissan from our car's parameter. So the constructor that expects to receive one car is going to get called. This points to the current object that we just created. Source points to the object that was passed in, and here we set every single field in the current object equal to a value from the source object. Alright. Now the element at index 2 stores a unique reference to a new car object that we just created, and I'm not going to go through the elements at index 3 and 4, you get the point. I'm just going to fast forward. Oh, I was hoping there would be a breakpoint over here so that you can visualize that we're not affected by the trap anymore. So, you know what? Let me just remove these breakpoints and skip all the way over to here. So here you can see the dealership object is cars field. The objects in this array are completely independent from the objects in this one. So here, by updating the car object with a reference of 55, it's just going to update that object. Beautiful, and our dealership is going to remain unaffected. In this lesson, you will finalize the dealership application. And now you might be wondering, wait, Rayan, don't we need getters and setters? A getter that gets all the cars and a setter that updates all the cars. I don't really feel too excited about having these getters and setters because let's imagine that the dealership had 1,000 cars. Are you going to return 1,000 cars? That seems a bit preposterous. Are we going to update 1,000 cars at once? I don't think so. And obviously here we're falling into the reference trap, so we would have to fix that as well. But if we're not going to use something, it's better to just not even have it. So inside dealership, at least for me, it doesn't make sense to have getters and setters. But inside of the main class, I left you a text file that I want you to download. Copy all of its contents inside of your class. I wanted to save you the trouble of setting up Scanner, asking user questions, and keep the focus on object-oriented programming. So what's happening here is we are prompting the user to browse through our collection of cars. Upon printing dealership, we would want its toString method to get invoked, and the toString is going to return a string that describes every single car in the dealership. And as you know, Java's gonna print whatever toString returns. Then we ask them which car they're interested in. They can choose between the car at parking spot 0 or the car at parking spot 4. So if we were to put a breakpoint right over here and run our code, by printing dealership, what it's gonna do is print whatever string toString returns. So if we keep stepping inside, it's going to eventually call the toString method that is inside of object.class. All that's going to do is print the name of the class from which our object was created, so dealership, followed by an @ symbol, followed by a string that represents a hash code. So ultimately, this is what gets printed when we print our dealership, which is not very useful because printing a hash code and then asking them what car they're interested in does not make any sense. What we need to do is override the toString method for objects of the dealership class. And so now whenever we print objects of type dealership, Java is going to know to invoke this toString and print whatever string it returns. And the string that we're going to end up returning is inside a text file labeled dealership toString. This toString defines a variable called temp that at first equals an empty string. Here we run through every single car in the cars array, and for every single car that we run through, we append its parking spot into our string. We call toString from the car object, returning a string that describes all of its fields, appending that as well, and ultimately temp is going to end up storing a string that describes every single car in our dealership. And that's what we want to get printed before we ask the user what car they're interested in. So we're going to get an output like this. Java prints the result of our toString method, which is simply a description of every single car in our dealership. Then we ask them what car they're interested in. From parking spot 0 to parking spot number 4, we need to save their choice in a variable, which we're doing right here. And then we simply sell them the car. So here I'm going to say public void sell. It's going to receive an index. And the idea is that whatever car they buy, they need to drive it out of our parking lot. And that's it. We're done coding the application. So here we can say dealership.sell, and we will sell them whatever car they want. Let's test all of this out. Which car are you interested in? We are interested in, let's say we're going to buy the Nissan. The dealership object is going to call the method sell. This points to the current object that called the sell method, the dealership. Here we access the element at index 2 of our cars array. And from this car object, this Nissan, we're going to call its drive method. This points to the current object that called this drive method, our Nissan car object. And here we're simply printing, you bought the beautiful Nissan, please drive it to the nearest exit. And just like that, I bought a beautiful Nissan for $5,000. We are done. Now I want you to notice how clean the code is inside of main. By simply printing the dealership, we're printing a collection of cars. And here the dealership sells me a car. This reads like English, which is why you should always plan your code around objects. We planned our code around car and dealership objects, which ultimately resulted in higher quality code. I consider this to be the most important lesson in this course because deep copying, what it does is it protects the internal state of an object from external modification. And accordingly, in this lesson, we're going to use deep copying to protect the internal state of our dealership object from external modification. And you should get two errors, one at line number 14 and, well, wherever you see get car and set car because we haven't implemented them yet. So the first thing we'll do is inside of our dealership class, we're going to create some space. And I'm going to say public car because our get car method is going to return a car from the cars field based on the index that it receives. And instead of returning a new copy of whatever car is in the cars array, we're just going to return that car directly, which is very, very dangerous because all we're doing is we're returning a direct reference to that car. You'll see that in just a second. I'm just going to implement the setter now, public void set car. That's going to receive an index and it's going to receive a new car. And its purpose is to set an element at a particular index in our cars array equal to the new car that was passed in. This is also really, really dangerous, and you'll see why in just a second. So for now, let's just go back to main, place one breakpoint over here at line number 14 and press debug. Here we're calling dealership.getCar. So if we step inside of getCar, this points to the current object that called it, this dot cars, and here we're returning the element at index 0 of this dot cars. So it's going to return a reference to the object at 23. This is really, really dangerous because at this point we're basically exposing the internal state of our dealership. By returning a direct reference to one of the objects inside of it, the outside variable car at index 0 is going to end up storing this reference. And now, if we have a look at our dealership, if we have a look at the element at index 0, it shares a reference to the exact same object as the outside variable. This is really, really bad because if I go to line number 18, and if I update the make of the object through our outside variable, the state of our dealership is going to get affected as well. This is really, really bad. Let's continue. Here I'm creating a new object of the car class. I'm going to step inside of set car. So this points to the current object that called this method, our dealership object. This dot cars at index 1, we're going to end up setting this equal to the new car that was passed in. But the danger behind line 18 is all we're doing is setting this element equal to a reference of the same car object that's being passed in as an argument. So this element should store a reference of at 41. Let's just make sure of it. It and the argument share a reference to the exact same car object. This is really, really bad because if I go back, the argument that was passed in, new car, has a reference of at 41. Let's collapse this. The car at index 1 of our dealership has a reference of at 41. And so by updating the outside variable, our dealership gets affected as well. This is really, really bad. The way we wrote this code, for example here, we're basically exposing the internal state of our dealership. We're returning a direct reference to one of the car objects inside of it. So here's what we need to do. We're going to do some deep copying. So deep copying, all it is creating duplicates of your objects to make sure that you're protecting the internal state of your class, to make sure that sensitive information is not being leaked. So here I'm going to say car. We're going to create a new object of the car class. And which constructor should we invoke? We can invoke the copy constructor because Upon creating this new car object, we want all of its field values to be derived from the car object that they're interested in, the car at whatever index they're requesting. And now, instead of returning a direct reference to the car object inside of our cars array, we're going to return the car copy. And you know what? Let's call this copy for clarity's sake. We're going to return a copy of the object that they want, because we cannot expose the internal state of our dealership. And here, instead of setting the element at whatever index of our car's field directly equal to a reference to the same car object being passed in as an argument, what we're going to do is once again create a copy. We're going to set it equal to a brand new object of the car class whose field values are going to derive from the new car that's being passed in. So that's going to call the copy constructor with this as the source object. And now instead of setting this directly equal to the argument being passed in, we're going to set it equal to our car copy. And this is how we can use deep copying to protect the internal state of our class. And now we should be free of the quote-unquote reference trap. We can rest assured that no matter what we do in our main class, the internal state of the dealership should remain intact. So let's go ahead and re-debug our code. We'll step inside of getCar again. Here, instead of returning a direct reference to the car object at index 0, what we're doing is we're creating a brand new object of the car class, and that's going to invoke the copy constructor. So this refers to the new object that we just created, and the source object refers to the car at index 0. And here we're setting every single field inside the copy equal to a value from the source. And now that we've got our copy, we can safely return that instead. So now car at index 0 stores a reference to an object that is completely distinct from the object inside of our dealership. So if I decide to modify the car at index 0 from the outside variable, it should have no effect on our dealership. 0. Perfect. And now here, if I create a new object of the car class and I use my setter to update the object at index 1, let's do it. Before I set the element at the index equal to the new car, what I'm doing is I'm creating a new object of the car class whose fields are going to derive from the new car object that's being passed in. So that's going to call the copy constructor with the new car acting as the source object, and this pointing to the new object that we just created. And here we're setting every single field in the new object equal to a value from the source object. And now we're setting the element at index 1 of our car's field. We're setting it equal to the brand new copy that we created. And this ensures that the element at index 1 is completely distinct from the argument that was passed in. So now new car, it has a reference of at 41, and our car inside the dealership, it has a reference of at 45. They are completely distinct from each other. This is a completely different object, so if I update this one, it should have no effect. Beautiful. And just like that, we used deep copying to protect the internal state of our dealership. We employed deep copying here. We employed deep copying inside of getCar and inside of setCar as well. I hope you enjoyed the course. If you want to delve deeper, make sure to check out the extended Ultimate Java Bootcamp, whose link can be found inside of the video description to cover more advanced Java concepts. And if you haven't subscribed already to this channel, make sure to do so to stay updated on all of my tech content. See you in the next one.